everyone, I welcome you all to the live session on full course on DevOps Tools by Intellipaat. This session is a must-watch session for everyone who wishes to learn DevOps and make a career in it. This session is taken by multiple experts who will be teaching you everything about DevOps and its tools from basics to advanced level. Before we begin the session, make sure to hit the subscribe button and also like our videos so that it will motivate us to come up with more such interesting live sessions. DevOps is one of the widely used tools that help in the field of development and operations. It is a collection of tools and technologies combined to carry out various business processes. It aims to bridge the gap between two departments in an IT organization, that is, development and operations. DevOps engineers are in huge demand and are one of the highest paid practitioners in IT industry. On saying that, let's see the agenda of the day. Firstly, we will begin with Introduction to DevOps. In that, we will tell you what is DevOps and why do we need it. Post that, we will be learning DevOps lifecycle in detail. Then later on, we will be covering all the DevOps tools like Git, Jenkins, Kubernetes, Maven, Puppet, Nagios, Docker, Ansible, Nexus, ELK, JFrog, and NPM. Then finally, we have covered how to become DevOps engineer, followed by DevOps interview questions and answers. So guys, this session is going to be very interesting. So stay tuned and watch the video till the end. Now let's begin the session.
The DevOps. Now, the common problem that we observed here is that in the infrastructure readiness, there's a lack of collaboration. The working fine in DevOps problem now, again, the collaboration issues. Now, because of the major point is that because of the collaboration issues, because people don't know each other, there is a lot of time wasting in delivering applications, basically. Now, the DevOps talks about mainly building this collaboration between the developer teams to the operation teams, basically. Now, that's why people say that development team plus operation team is equals to DevOps team, right? People talk about it. I hope you are able to relate the things now, why it is DevOps and everything, right? What exactly are the problems? Now, if you ask me that team, the definition of my DevOps, I say that it's nothing new there, right? We just want to reorg. It's not any new team to hire. It's not any new skill to hire, basically. Think about it. It's not at all a new skill. It's not at all a new team, something. It's just that you are having the same roles, but you just need to reorg, saying that, hey, everybody who is working in a project, starting from the development till the production, the different teams are now being reorged and say that, hey, you're all responsible for delivering this project to the end user, right? That's what we wanted, basically. So technically, team, if you talk about it again, right, DevOps is an agile IT operation delivery required to match the cadence of agile IT development. What do you mean by that again? Now, we understood that, right? So whenever we brought in the agile into the development phase, there is a lot of improvement, right? Like the developers and QAs and business analysts were collaborating each other to achieve the goals, right? Because they were all participating in a single call. They collaborated well, they talked to each other, they delivering the goals on time. That's what happens. The collaboration was built with that. And then of course, the style of the delivery also changed. That is also helping them to achieve a more faster development process. Now, think about if I apply the same concept to the operation team, right? So thinking about it, why can't we bring in the same operation teams into the same stand-up call, right? Which means that we want to extend agile into the operation side, right? That's the only thing, team. So think about it. DevOps is not a replacement of agile, like waterfall or agile was a replacement of a waterfall. Don't think that a DevOps is a replacement of agile. It is nothing but it's an extension of agile, basically, right? The agile was already implemented in the development areas. Now we want to extend this into the operations. We want to bring everybody into the same call. When everybody is on the same call, people get to know each other, means the collaboration will be started. Now, if the client gives a new requirement in the sprint call, right, a sprint planning call, the developer takes it, the developer says, okay, this is what it is. Now, the same team, operation team can say that, hey, if you're talking about new requirement, are there any changes on the infrastructure side? Then they can say that, hey, this is not as required Java 9, you can start working on it, right? Now, this is what happens, team. So the collaboration is increased, right? Then the operation team works on Java upgrade process, development works on the development of the new feature. By the time these people finish the development, the operation teams will be ready with the new infrastructure with Java 9. So the application can be delivered immediately. So infrastructure readiness problems can be resolved with simple collaboration of this effort, right? Now that's why we see that, team, again, the DevOps is an agile IT operation delivery required to match the cadence of your agile IT development. So we are extending the agile into the operation, and that's called as DevOps in simple words. And extending will simply does not make sense, team. So it says that DevOps is the philosophy again of unifying development and operation at culture. So the culture need to be brought in first of all, team. Without the culture, there is nothing can be done. Means people should understand, or people set their mindset that we are all part of a single team. The mindset need to be changed first of all. That is what is the major thing. The DevOps engineer, if you want to be called yourself as a DevOps engineer, change your mindset first of all, that you are no more working in a silo environment. Means you are not just the developer anymore, you have to extend a little bit knowledge on the infrastructure also, right? How the infrastructure being operated, how many servers do you have in the production. Means I'm not asking you to implement, team, have an idea. That's it. That is what all we're telling it. Okay, so that's what the mindset need to be changed, team, that everybody on both the directions, it's vice versa, developer to the infrastructure, or infrastructure teams to the development side. Everybody should have some fair understanding of what's happening across the project life cycle, right? So that's what it is. So again, just to repeat the definition here, DevOps is the philosophy of unifying development and operations at culture, practice, and the tools level to achieve accelerated and more frequent deployment of changes to the production, basically, right? Now, this is the goal, team. Think about it. If you simply ask about the goals of the DevOps again for me, the goal of the development team is to deliver the features into the hands of customer as quickly as possible. So their goal is always speed only, right? But if you talk about the the operation side, right, the goal of the operation team is to maintain the stability of the system and minimize the downtime, right? So which means that a stability and a speed of delivery is nothing but the goal of your DevOps. You need to achieve the speed, you need to achieve the stability as well. You need more frequent deployments without any downtime to the end user. That's the main goal. Time to market need to be increased as compared to the current market, right? And no production failures. Doesn't make any sense. We can fail, definitely. We can fail, definitely. Failing is accepted, but how quickly you can recover from that failover or failure, you call it, right? So you need to have a robust automation that brings you back to the previous state immediately in case there is a failure. So we need look for more automation that can bring me back to the previous stage immediately whenever there is a failure. Of course, the failures, we cannot control them, right? Because they are all computers and everything, we cannot control them for sure 100% perfectly. So there could be a possibility of recovering from the failure easily. That's what we're looking for. Now, finally, team, there is no wall in DevOps culture. There is no wall in DevOps culture, which need to be set in your mind again, which means that as a developer, you have a right to go and ask what's or how the production is. And as a production support or a middleware team, he has a right to talk about the development a little bit if you are interested, right? Again, we are not forcing, or people are not forcing you to do it, but they're asking you to know it, talk to them, right? Build a culture, first of all, know everybody in the project so that you get a good results always. Like teamwork is always given to the better results for you. Treat that everyone, different areas like development team and all those teams are nothing but the team members of your project itself. So you get a better scope of understanding more things, you get a better delivery model, and everything can be achieved accordingly. Now, team, adopting just the DevOps model, just changing your mindset and culture does not help us move faster again, because we know that we are still a little fat here. The applications are little still fat. We want to make them more lighter weight. See, the only motto is that to make it faster delivery or more faster delivery. You want more faster delivery, you need to be more lightweight, right? The more the fat you have it, the more bigger applications you have it, it cannot be delivered fast. So we want to go for more lightweight architectures. Now that's where you discuss about microservices. Micro, the name itself is that it's very little or a little piece of code, we can say that. And the containers are lightweight. Hope everybody know about the containers. And we want a robust infrastructure to run our applications, which can be created on demand basis. Now the cloud gives you on demand, like everybody knows about, right? So if I want to increase my infrastructure on demand, then I can cloud is the best option for me. Now let me talk about the difference between, right? Difference between a cloud versus, let's say that a cloud, what is it, hosted versus the cloud. So when you talk about the hosted team earlier days, right? Hosted just gives me something called as infrastructure as a service, which means that it can just rent servers. That is what it is, which means that again, you need to place a request first of all. That's a third-party organization. You do not have anything in your fingertips here. You just need to place a request and the team will take at least a couple of weeks of time. See that they will need certain time after you place the request. They create the infrastructure, they give you or build a network and everything. Then finally they give you the servers on rent. And you have to pay for whatever the number of servers you requested, no matter what, the requested payment, right? Pay for all you requested. Whether you use them 100% efficiently or not, we don't worry about it. Since you requested 100 servers, you pay for 100 servers accordingly at once, or maybe in installment chases. You can do that. That is what is nothing but just a simply hosted, right? But when you come to the cloud team, right? When you come to the cloud is just not about infrastructure as a service, right? Right? It's also rent servers, of course, I agree, but it is not just about the infrastructure as a service. They had an extension of platform as a service or a software as a service. They offer many services at your fingertip. Can I say that? Can I say that? Now you don't need to go to them and then place a request. Now you can open at your laptop, open a service portal, right? Right? Just go for it. Just open a browser and then just place a request. They will create it, right? Now whatever you create it here also will be ready for you in a matter of seconds or minutes. It does not even take times, hours of time. It just takes a minutes basically to create your entire infrastructure. Maybe 100 servers or 200 servers, doesn't matter. So now the second advantage is that it also gets you something called as a pay as you go model. Pay as you go, which means that if I use 100 servers for 100 hours, I'll just pay for 100 hours only, right? Nothing else apart from that. So the pay as you go model will give you a lot of cost saving again, whereas that was not very with the hosted basically. So that's a simple difference, team, that you need to have in India, idea in your mind, the difference between the cloud. So I can say that a cloud is an extension of a hosted. We had it earlier basically. Okay. The cloud is nothing but an extension of a hosted. We had it earlier basically. That's what you need to understand. Hoping that this is clear now for you. What is the difference between a simple hosted versus the cloud basically? Right, so here it is. Coming back here to the containers, how many, or can you define me a container? Anybody? Who can define me a container? Okay, so let me tell you that, team, in a simple words. Now, in the earlier stages, or still we are doing it something called before the containers, as I said, like we are delivering this application code into every environment, every release, right? Let's say that every 15 years or whenever there is a release, you are carrying this application into all the environments. But think about this one, team. Think about this one. We are failing to run successfully every time in production because application does not run alone. It needs the dependence of your web server, Java, and something, right? So we are just carrying only the application code, but these whatever the dependencies to run your application are being pre-configured once in your server. Every server, you mean to say that even if I have 1,000 servers in my production, every server is independent and unique. So I have it like that. So every server is constructed. Every server is being built and maintained separately. Now that's why you are facing a lot of time issues that you are not able to run it in production successfully. It's just that you are just delivering only the application, but not the dependencies to run it. Now, why are you doing this approach still? Now, the container model is that team, or a container tells you that, hey, now if I'm having the delivery model process with that, I'm facing the issues a lot. Now, why can't I think about something, putting an application, nothing but your application file plus all of its dependencies, right, into a single bundle, right, into a single package, right, into a single package like this, and deliver this whole application plus its runtime, right? Deliver whole application plus its runtime every time here like this. If I deliver it here, if this is working fine, I'll deliver it here. If this is working fine, I deliver it here. If this is working here, and deliver it here. Now, can I guarantee that? If I use this approach, I can guarantee the application will work exactly the same thing in development and production? Application built it along with dependencies, we call. When you build a simple application, web application is built along with the source code, and dependencies of your web applications are built together into a single module called as var. That is nothing but your installer package, I call it. Here the installer package is only your var file, I can say it. Earlier days we did not have this option. Now the container says that you have to bundle the runtime dependencies along with your application and its dependencies. Everything need to be bundled together. This is what is called as now the container. Docker is a containerization tool, I call it. When I discuss about the Docker section, you will get to know that why they are not fat and everything, you will understand it. Runtime dependency is nothing but your Tomcat and Java, right? Tomcat is a runtime server, right? Just Bibin. Tomcat is your runtime for your web application. So this is what it is. The OS libraries and everything is a runtime dependency, I call it. Okay. Now this is the approach basically, which is called as a container. The container will help us deliver it accordingly, and the containers are lightweight by nature. Though you bundle everything together, that has become still lightweight a little bit, including the OS here, I'm telling it, including the OS required to run your application. Everything will be bundled in a single package. Now this package, we call it as a container. Now again, let me tell you the simple definition. Application plus all of its dependencies together bundled in a single unit called as a container, basically. Right, that's what is something called as a container. We'll talk about more on it in a section called as containerization of an application, or application containerization, that we can discuss later. But just have that idea in the mind that how it will be done there. Okay, the containers are lightweight now again, so they can be easily transferred out and easily run when compared to the other servers, basically. Okay, fine. So that's about a team and the microservices, right? So what is a microservice? I know that most of you not sure if you are working on it, but let me tell you in a simple words here. Now it is about team. We want to make more lightweight for sure. So here team, think about when I say a banking application, right? This banking application is built as a single application here. Now this bank application comes with a default functionalities, right? Different services within the bank or internet banking. Starting from the login is a service, I call it, and debit card services or a credit card services, or you have a loan service, or you have a mutual fund service, and so on, right? All these different services are tightly bundled in a single application module. Can I say that, everybody? A single var file or a single executable file giving me all these functionalities. Yes. Assume that there is a scenario which I'm giving it, right? Assume that there is a scenario here. There are 100 customers who logged into my internet banking right now. 100 customers who logged into my internet banking application right now. Out of 100 customers, 90 customers are using a debit card, means they are performing some debit card related operation on my application. So 10 customers are using the credit card section. Okay. Now, all of a sudden, the credit card statement got stopped loading, means that they will not able to, a credit card users, they are not able to download or use the credit card statement section. Now that's a bug in my application that is being reported to the bank, and the bank went to the development and they fixed it. They fixed in development. Now they want to deliver it to the user, which means they want to deliver it to the production. Now, will the bank give a downtime for the 100 users or only for the credit card users? Who will get the downtime here? Yes, team. We now discuss that. We get a discussion. You get all or you get 10. Yes, everybody. What do you think? Because it's a single module team, how it can be only for the credit card, Fanindra? It is because it's a single application. Because if I want to deploy the credit card, I have to redeploy the whole application. It's a single service. That's what I told you, right? It's a single application bundle which is having all these services. Then downtime for all the users basically, right? It's a downtime for all. So think about team, my application is unavailable for my 90 customers who doesn't even have any problem in using application. So everyone is affecting here, definitely. So the customer satisfaction is going to go, right? As the customer satisfaction is going to go that one. That is why team, people thought about it and then they want to make it more no downtime applications, make it a simpler services than hosting them together. All right. Now that's where people started, right? More loosely coupled, right? Loosely coupled architecture, or it is also known as your microservices. What do you mean by loosely coupled here? So instead of building that whole modules in a single application right now, I'll go for separately building out login application, debit application, credit application, right? And you have a loan application and you have a mutual fund application running in a different servers, maybe something. Now in the backend alone team, in the backend only, you are breaking them into the different services. The end user, the front end, the UI will be same again. There will be no change for the front end user. The front end user will still have a login page. When he logs in, he will see debit, credit, everything he will see in the same application. But earlier we hosted that as a single piece. Now we are hosting all of them as a separate pieces, separate services in a different servers for me. Now in this case, basically I have a flexibility of, if I have an issue with a credit card, I can simply bring down only the credit card application. It's a part of application, right? The whole application will be still functioning. The whole application will be still functioning. People will be able to log in, but only the users who wants the credit card service will not be able to access it, right? While I bring it down, while I can bring it up, right? So that will be like, you know, it will be easy for me to deploy only the credit without giving any downtime for the 90 customers. Now I can still deploy my application. Now that's how team, it's like giving out more no downtime applications to the end users basically. Now that's the advantage with the microservices. The other advantage is that microservices are now lightweight. Earlier, if my WAR file was 100 MB, because now if I split into multiple applications, now different code, now it will become 10 MB or 20 MB each. Now 20 MB application, I can install it much faster than a 100 MB application. So the deployment becomes faster, right? The deployment becomes faster, right? The second thing is that the troubleshooting becomes also faster, because I just need to debug the code of only the 20 MB, which is maybe 10,000 lines for me, right? So it will be like, you know, troubleshooting becomes easier where the problem is exactly. So the troubleshooting becomes easy, the deployment becomes easy. I can move it faster into different environments. You get all the benefits, and you also can give no downtime for the other users of the applications basically. So this is the advantage with the microservices system. This is just a general way of telling it. There are many things if you go into the deep dive of microservices architectures that will be not discussed in deep dive later, but this is just an idea like how the microservices are helping us to move the application faster into the environments basically.
So going forward, now let's discuss how the DevOps lifecycle actually works, right? So if you were to that infinity sign that we had it, if you were to condense it, or if you want to expand it, so that DevOps lifecycle diagram that we had, the infinity diagram that we had, if you were to expand it, it would look something like this, right? So you have something called as planning, you have something called as coding, building, and testing. Now this used to happen on the developers side, right? And then we go on to the ops side, where we have release, we have deploy, you have operate, and then you have monitor, right? So in between this, we have to integrate this part of the developers side to this side of the operator side, and this is done using continuous integration. Now what is continuous integration, we'll discuss in a while, but for integrating the developer and the operations guys, we use continuous integration, right? Now before moving on to what is continuous integration, let's pay attention to what we have over here as well, right? So the planning and coding phase, we contribute, or we collectively call it as continuous development. What is continuous development? I'll explain you in a little while. Building and testing, we call it continuous testing, okay? Releasing and deploying, we call it continuous deployment. Operation and monitoring, we call it continuous monitoring, okay? So you start with planning, you do coding, you build it, you test it, you then release it to the ops team, then you deploy it, then you operate it, and then you monitor it. And this gives rise to 5 stages, that is continuous development, continuous testing, continuous integration, continuous deployment, continuous monitoring, which again goes back to continuous development.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What are the key components of DevOps? A. Continuous integration. B. Continuous testing. C. Continuous delivery and monitoring. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now let's understand these terms. Let's understand what is continuous development, testing, deployment, monitoring, and integration. Okay, so this is the life cycle, guys. Now, why are we calling it continuous? Continuous basically means it goes on and on, right? It never stops. So like I told you in the diagram for DevOps, that the cycle goes on and on. It never stops. The product is always being developed, right? It is always in some part of the life cycle. So if you were to explain continuous development and continuous integration, continuous testing, this is the best way to learn it. Okay, so we have a developer who basically will be pushing his code to a version control system. Okay, and this version control system will basically, any changes in this version control system will be taken up by a continuous integration tool. Okay, so what is a continuous integration tool? A continuous integration tool does nothing but it joins each of these stages to each other. For example, if I have to go from continuous development to continuous testing, and if this happens in separate softwares, continuous integration will join these and this, right? Continuous integration will join testing and then deployment. Continuous integration will join monitoring and then again coming back to development. And how does this happen? It happens like this. So there is a software which basically does continuous integration. Okay, let's understand just this as a black box. This is a software which does continuous integration, and the function for this particular software is the moment you push your code to a version control system. This version control system is nothing but a software which takes care of storing your code. Okay, so the moment you push your code to a version control system, or you change your code in the version control system, the continuous integration tool automatically identifies, okay, so there's a change in the version control system. So what it does is it takes this code and it builds it on the testing server. It first builds it and tests it on the on the testing server, and this is called continuous testing. Reason being, every developer who does this, continuous integration does the job similarly, right? So if there are 100 developers in the team, so for every developer, if we configure a version control system, that for every developer it has to test the code, it will always do that. Okay, so every developer who's doing a version control, who's pushing his code to version control system, continuous integration software is going to test their code on the testing server, right? And this is the reason it's called continuous, right? Because it happens continuously. Okay. So continuous development, we push our code to version control system. It is identified by the continuous integration tool. So the first job that continuous integration tool does is it pushes onto the testing server the code where it is built and tested. And if the test succeeds, continuous integration tool pushes it on the production server. Okay. Now, either if it's on the production server or if it's on the testing server. Now, if on the testing server there are some bugs which are identified, the feedback is given through continuous monitoring to the developer. Or if the production server, if there are some problems on the production server, or like I said, when you deploy your code on the production server, it basically gets available to the world and it gets continuously monitored, right? For any kind of problems which are occurring, it gets continuously monitored and the logs are generated, and these logs are being stored somewhere using continuous monitoring. So your production server is continuously monitored for any kind of activity which is happening on it, and the logs are being generated. Now, the developers, the team, now when I go back to the developer, why am I coming back over here? Because this identifies, or this tells us basically now that now when the development team is done with the release and now they have to see what other work I have to do, all they have to do is check the logs from the continuous monitoring tool, right? And they'll be able to identify, so okay, so this and this is causing a problem, this and this is causing a problem. And also the users are saying that, we should have this feature. The client also came in, he also wants some features. So they plan a release. Right? And once they plan a release, they again start coding, and again once they're done with the code, they'll push the code to version control system, which will be identified by the continuous integration tool, which will then automatically test it. Once it's been tested, if it's successful, it will push to the production server. Again, the logs will be identified by the continuous monitoring stage. Again, it will go to the developer after planning, and then he'll code his way into version control system, and the life cycle goes on and on, right? So this is exactly how DevOps work, right? Now let's look at each of these stages independently to understand what exactly happens in continuous development, what exactly happens in continuous integration. Okay, so in continuous development, you basically push your code to a version control system. The version control system could be a software like Git or a software like SVN. Right now, the moment you push your code to the version control system, it basically creates a new version of your code. For example, if you wrote ABC on a text file, right? Now that ABC you wrote and you upload it on the version control system. So this was the first version. The version control system automatically makes it version 1. The moment you make some changes and again push it to the version control system, what happens is it creates, the version 1 was the text file having ABC. Now the new version that you have pushed, it becomes version 2 and the file would be ABC and probably whatever changes you have made to the file. Okay, so it creates a new version, and at the same time it also holds on to the previous version, so that in any case, in any problems that you might have in the future, if you want to revert back to the previous version, you can easily do that, right? And that is why we have version control systems like Git and SVN, and continuous development is an integral part of pushing code to your version control system. Okay, now this was continuous development. Then you have continuous integration. Now what is continuous integration? This is nothing but integrating your life cycles with each other, right? For example, once you push the code to your version control system, it obviously has to be picked up and pushed onto the testing server for testing, where it could be built and tested, right? So all these life cycles are integrated, or there is someone who is doing the manual job of a person of taking code from one stage and pushing it onto another, then taking the results from there, pushing it onto another, then taking the results from there, pushing onto another. And that manual effort is being done by a tool which is called the continuous integration tool. Okay, then you have continuous deployment. Continuous deployment basically means you will deploy your code onto a particular server. It could be a testing server, it could be a production server, and deployment basically involves putting the right kind of software on it and then pushing the build onto your server so that it has the right software environment where it will function, right? And again, installing softwares on system and everything is also automated using a tool which is used in continuous development lifecycle. Okay, then we move to continuous testing. Now continuous testing is again a lifecycle stage wherein you continuously test your software. So like I told you guys, in this what happens is you continuously build and then test your code. So your code is pulled from the version control system. It is built. So when I say built, it basically is converted to an executable file, and this executable file is then run, right? Now the continuous testing, how it happens is you create testing suites which are basically pre-installed in the testing server, and the moment it gets a new executable, all those test suites are executed on this particular executable file to check if all the tests are passed or not, right? And if all the tests are passed, it is then again picked up by the continuous integration tool and then pushed onto the production server. Once it reaches the production server, again it gets monitored, right? It gets monitored for user activity, it gets monitored for any errors, it gets monitored for any user comments on version upgrades, right? On version upgrades, or you can say any feature requests. So all those feature requests, all those errors, all those logs are then visualized or then are then stored inside a monitoring tool, right? And this monitoring tool helps us in sorting these logs based on what we want. It'll basically sort it on the basis of general logs, it'll sort it on the basis of error logs, it'll sort it on the basis of feature requests, right? So it becomes a one destination stop for you where you can check and plan your day ahead or plan your team's work for the near future. Okay, so this is continuous monitoring. So these were all the life cycle stages of DevOps, guys, and this life cycle stages basically make it possible for us to have shorter release cycles because all these stages are automated, right?
Before we know what Maven is, we need to know why do we even need to learn about Maven in the first place. Now imagine that you work for a small company and they have tasked you to create an app for them. This company acts as a mediator between restaurants and customers. It's basically a food delivery app that you have to make. How will you plan to build the app? You would look at the requirements and then decide what kind of features it will have, right? Since it's a food delivery app, we'll need a basket, we'll need a payments option, we'll need a support option, we'll need an account settings option, we'll need a search options. Now that you have decided what will be needed in your app, you will move forward to see what kind of structure you will use to build this app. You can go two ways with this. You can either have a single build code or you can have multiple modules for the app. It's easy to go back and check for any bugs or errors if they can be easily located, but inside a singular build code file, it would be difficult to do the same. It's much easier to add and handle features if they're divided up into smaller multiple modules. Now, having multiple modules is great and all, but it comes with its own problems. Since we have so many modules, like thousands of features in each module, we will have to go and execute each module one by one, and that will take a lot of time. Then we have to see which all dependencies each module will require. You will need to keep track of all the dependencies all the modules will require. And to download each of those dependencies, you will need to go online and download them manually. This will also take a lot of time. You will also need to keep track of which files call which. A module may be dependent on a previous module, so you will need to know about those kind of metadata too. To solve all these issues, we will use Maven. Since Maven is a build tool, it can help in building an application that has several different modules. It helps doing so by downloading dependencies instead of us doing it manually. What Maven does is it scans the project and sees which all requirements or dependencies are needed, and it then goes online and downloads them for us, and then it manages them also. It also enforces a directory structure. Now, in an organization, data needs to be organized. After you're done working on the project, someone else needs to work on it too. So for that purpose, it will enforce a clean directory structure where only specified things will be stored in specified folders, and ultimately it helps in maintaining the application. Now that we know why we need Maven, we can move on to what Maven actually is. Maven is commonly referred to as a build tool. It is used to manage the entire life cycle of a project, generate reports, and store documents with its POM repository. It's a successor to an older tool called Apache Ant tool, which was developed in the 1990s to do the same thing. But it's old and obsolete now. People use Maven in the industry because it's a lot more automated and it's a lot more standardized. Also, it's mostly used for Java-based applications. So what Maven basically does is it takes all the modules and scans through them. It scans them for dependencies and requirements. It then goes online and downloads those dependencies and then injects them into the project. And after it's done doing that, it takes all the modules and then compiles them or builds them into a single executable file. This file is then reviewed and then rigorously tested. And after it's been successfully reviewed and rigorously tested, it can be deployed as the application. What does Maven do? It enforces a directory structure and manages and downloads project dependencies, enforcing directory structure. For Maven to work properly, a standard directory structure needs to be created and be used for storing all the code and its related resources. Every folder has its own reason for existence. As we can see that inside the project home, there are three things: src, target, and pom.xml file. And all these folders serve their own purpose. Inside src, the main folder stores all the source code for the application logic. And then inside the Java folder, all the transactional code is stored. Inside the resources folder, all the text files that are needed by a code are stored, like the .cfg file or the .xml file. And the test folder stores all the unit test case code. And beyond this, all organizations have their own folders for their own purposes.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
So let us get introduced to Git, but before that, let us understand why are we only learning Git? Why not some other tool, right? Like I told you guys, there are a lot of distributed version control systems out there. Why are we only learning about Git, right? So let me just compare it on Google Trends, and this is the result that I get. Right? So if I search for Git, Perforce, and Mercurial, which are actually the top 3 distributed version control systems out there, you can see that the Git tool is the most famous among them all, right? So that basically means that if you learn Git, you have a high chance that you might land up in a DevOps job more if you know Git than Mercurial or Perforce. Because Mercurial and Perforce, because the popularity is low, we can easily conclude that not much of the companies are using these two tools, right? So most of the companies are using Git. In my experience also, I've seen most of the companies do use Git, right? And that is the only reason we have included Git in our course. And that is the reason we are learning Git also today, all right? So moving forward, now let us see what Git is exactly. Right? So Git is a version control system. It's basically a software which falls under the architecture of distributed version control system, right? And it does the same things which any other version control system does. That is, it tracks changes, it keeps your files versioned, right? And because it's distributed, you have a local repository as well, and then you also have a remote repository. Now, in case of remote repository, you get a lot of options, guys. But in our course, what we are going to do is we're going to opt for a free option, which is GitHub, right? So you might know GitHub. GitHub is famous for all the open source tools which it hosts, right? So we are also going to work with GitHub. But for now, we are going to just focus on Git. First, we're going to understand what Git is. And then probably later, we'll see how we can use GitHub in conjunction with Git. All right. Our next session actually is going to talk about the life cycle of Git. So we have understood, why are we actually learning Git? We understand what Git is exactly, but we do not know how it exactly works, right? We know the architecture, but we do not know how it works. So basically, we've divided all the commands that you could be used frequently or you will be using frequently among these 4 domains, right? The first domain is about creating a repository. So we'll be discussing some commands which will help you create a repository in Git. Then we'll be dealing with commands which can help you make some changes in Git. Then we'll be dealing with commands which will help you do parallel development in Git. And then towards the end, we'll also be learning commands which will help you in syncing your repositories. Okay. So let's discuss each of these domains one by one. So let's talk about how to create repositories. Let's start from the scratch, right? So our first whenever you start a project, the first thing that you have to do is you have to go to your working directory and you have to do some code or make some code, right? So the first thing that I'm going to do is, let me just switch to my terminal. All right, so this is my terminal and I'm logged into an Ubuntu server. So what I'm going to do is I'm going to create a directory which is say called DevOps. Okay, so let me create a directory called DevOps and let me just cd into this directory. Okay, so I'm into this directory now. Let me just clear the screen. Now let us add some files. Say I add a file called nano. Let me add a file called 1.txt. Okay, and let us say hello world in it. So this is our first file. Okay, now let me add one more file. Let us add a file called nano2.txt. Let's say hello from Intellipaat. Okay, so this is a file that we have added now. Let's save this file. Okay, so now we have two files which are there inside a folder DevOps. Okay, so this is not being tracked by Git as of now, right? But it is still our working directory. Now, for making it a Git initialized working directory, all I have to do is type in git init and hit enter. Okay, and now we have an initialized Git repository in front of us. Okay, so this is how you can initialize a directory in Git. So now you have created a repository in which you have your code, which will now be tracked by Git. Let's come back to our slides. So this is exactly what we wanted to do. We wanted to initialize a Git repository and we have done that. We have added some files in that directory. Now let's go ahead and see what our next command is. So our next command is about knowing the status of what are the files doing in that directory. Are those files saved in Git? What is the status of that directory? And the command for seeing the status of directory or the files inside it is the command git status. So let us quickly jump back to our terminal. Let me just clear the screen. And now if I want to see like if my files are being if my files are saved in Git, what exactly is happening with my files. So what I do is I just type in git status and I can clearly see that my files are right now untracked. Okay, why are they untracked? Because I've not staged them yet. These are just files which the Git is seeing that they exist in the directory, but they have not been added to my file system yet. So this is what Git is telling me right now. Okay, and it is also telling me if I want to track these files, all I have to do is git add and then the file name. So I don't want to do that right now. So let us go back to our slide. So this is what git status does. It basically gives you a status of your repository or of your directory. What are the files which are in the directory? I mean, what is the status of those files? Okay, so we got the status. Our next command is about adding, right? So basically we have made some changes to our file and now we want to add it into a repository. And for doing that, all I have to do is just go back to my terminal and I'll say git add. I can either type in the name of the files. So say I want to track both the files. So I'll just type in 1.txt or 2.txt. You type this, or what you can do is you can just type in git add and then a dot. Dot means track all the files which are present in this directory. So I'll hit enter. And now if I do a git status, let me just clear the screen. If I now do a git status, I can see that my files are now being tracked. Okay, so my files are now being tracked. They are staged, right? So if you think about the life cycle, you were in the working directory. Now you are in the staging area. You have staged your files. You want these files to be saved in the Git file system. They're still not saved. They're still in the staging area. The next step is saving these files in the Git file system. And for doing that, the command is git commit. Okay, so how do you type in the git commit? You type in git commit, then you give a space -m flag, which basically means the message, and then you type in the message that basically will point to what you are basically doing in that commit. For example, in this case, since this is our first commit, we can simply type, let me just clear the screen, git commit -m. We can say this is our first commit, adding 1.txt and 2.txt. Okay, so this is what we do. We just hit enter and now you can see that my files have been committed to Git. Okay, and now if I do a git status, now you can see it says on branch master there is nothing to commit, working tree is clean. That basically means all the files which are there in this directory right now are clean. They are all saved in the Git file system, and there's nothing to worry about right now, right? So now let's do a little experiment. What I'll do is I'll add one more file. Let me just create one more file, and let us name this file as 3.txt and type in test file inside it, right? So now what happens? So if I do git status, you can see it will say that 3.txt is a file which is untracked in Git. Rest all the files which are there, it is not listing that because those are already saved in Git, and they are there's nothing changed to those files. Also, let us try by changing the 2.txt file, which is not listing over here, right? So what we'll do, we'll just do a little change to it. Let me just add 1 2 over here. Let us save it, and let me do a git status now. Let's see what happens. So if I do a git status now, it can see there is a modified 2.txt file, and there is an untracked file which is 3.txt. Okay, so this is something what you get. So any changes that you do to a file, it will be reflected in the status of Git. Now if I want the 2.txt file to be saved, I have to stage it again, and then I'll have to commit it. Okay, that is the only way I can modify the 2.txt file. Okay, so let's come back to our PPT now, and let us go ahead and see what is our next command. So our next command is about syncing repositories. So now we have committed the files to our local system, but how do we make it available to the world, right? So for making it available to the world, the first thing that you have to do is you should have a Git repository. Okay, so let me just jump on to my browser, and then I'll show you how you can create a Git repository. So just give me a second. Okay, so guys, you just have to sign up on GitHub, and once you sign up, this is how your page would look like. Now what I want to do is I want to create a new repository. So on your left hand side, you will see a button called new repository. Just click on that, right? And now let's name our repository something. So let us name it as DevOps and hyphen course. Okay, so our repository name is DevOps course, and the type of this repository is public, and let us just now click on create repository. Okay, so our direct repository has now been created, and now what I have to do is I have to copy this link. This is a HTTPS link, guys, so I have to copy this link. Let us copy this link, and now let's come back to our PPT to see what exactly we have to do. Okay, so now to add files to this repository, or to push files to this particular repository, first I have to add it in my command line. Now for adding this repository in my command line, I have to type in the command git remote add origin. Okay, this is the command git remote add origin, and then the URL to the repository. So let us do that in our terminal. So I'm here. So right now when I'll commit, basically my 1.txt and 2.txt will be saved. My modified 2.txt file and my 3.txt will not be pushed. Okay, so let us see if that happens. So now what I'll do is I'll type in git remote add origin, and then the URL of my repository. So the URL is this. Let me copy that. This is the URL, and I'll hit enter. So now my files or my origin URL has been added in my command line, right? It has been saved in this Git repository, my command line that is working on my Git repository. Okay, so now let's come back to our slide. So we have executed this command. Let's see what our next command is. So our next command tells us how to push files to my URL, right? So the command is git push origin master, and see guys, this is the output for your command. Now when you type in this command git push origin master, it will ask you for your username and it will ask you for your password. So let us do that. So let me come here and let me type in the command. So the command is git push origin master. Okay, I typed in this command. It is asking my username. Let me enter my username. It is asking my password. Let me enter my password. I'll hit enter, and as you can see, it is pushing the files, and now my files have been successfully pushed to my repository. Let us check that. Let us come back to our browser. Okay, and let us refresh the page. So as you can see, it just says 6 minutes ago the files were committed to the repository, and now they have been pushed, right? And over here you can see the message of my commit, which was first commit adding 1.txt and 2.txt. So you get the message over here. here are the files. So you can see the changes, or you can see the content of the files as well. If you click on 1.txt, my 1.txt had the content hello world, so it's being reflected here. Similarly, if I want to see my 2.txt, I can see that it says hello from Intellipaat, right? So everything is here, everything seems to work fine. And again, what I can do is, now if I do a git status, you can see that there are two files which have not been added. So what I'll do is, let me first let me add first the 2.txt file, that is a modified 2.txt file, into my git repository. So what I'll do is, I'll type in the command git add 2.txt. Let me hit enter. So now this file has been staged, right? So if I do a git status now, I can see that this file is now staged. Okay, but this is still untracked, so we'll deal with this later. Okay, so now I have a modified 2.txt file, and all I have to do is git commit, and now I'll specify the message as modified 2.txt. Okay, so this is the message that I'm passing. I'll hit enter, and now my file has been changed, but these changes have now been done to my local repository, not to my remote repository. So if I come back to my browser and if I refresh, you can still see the file which was added to 2.txt. It still says hello from Intellipaat, and it was committed 8 minutes ago, right? So it still is not added to my remote repository. Now to add it to my remote repository, all I have to do is git push origin master. Okay, I'll hit enter. It will ask me my username. I'll provide the username and the password. And now my files are being pushed to GitHub. It has successfully done that. And now if I do a refresh over here, you can see that it says that 2.txt was committed a minute ago, right? And you can see the message over here. It says modified 2.txt, right? And this is exactly what we did. So we have added the second file as well to our remote repository. Let's add the third repository file as well, which is the 3.txt over here. So we'll do a git add dot git commit -m adding 3.txt, and now we'll do a git push origin master. We'll give the username, we'll give the password, and now my file has been pushed. And now if I do a refresh here, I can see even 3.txt has been added with the commit message adding 3.txt. Okay, so guys, this is how you can push your files, or you can sync your remote repository to your local repository.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the cloud platforms are not used for DevOps implementation? A. Google Cloud. B. IBM. C. Microsoft Azure. D. Amazon Web Services. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
What is ELK or Elastic Stack? Elastic Stack refers to a set of open source products that have been developed by Elastic to help its users collect data from different types of sources and then analyze the collected data and represent it in an easy to understand and aesthetic visualization. This is done so that meaningful observations can be made. What we have here is that we have a couple of multiple tools that have been developed by a company called Elastic that allows us to collect data from multiple sources and then use that data to make wonderful visualizations through which we can come up with meaningful observations about how that particular source is working. For example, if we had a code pipeline and if we wanted to see how the requests are being made into it or how well the code pipeline is functioning, we need to monitor how well it's working. So we would use the couple of tools that ELK is providing us. First, we will collect the data from the code pipeline and then we will store it in a place, and then we will use that stored data and create meaningful visualizations. Whoever is managing the code pipeline can understand where the problems are coming from and how well the code pipeline is functioning. Now, this is just an example. Now, these tools can be used for multiple purposes and many places, and we will see where they will be used in the next videos. Learning how to use all the components of Elastic Stack takes some time, but the payoff is great and grants a deeper understanding of software's underlying structure. Now, understanding how to use all of these softwares combined is a little bit tough, but once you know how to use them properly, it gives a great payoff. You can have a great knowledge about how to use it. And if you have a great knowledge about how to use the software, you can make much more complicated and yet simple to understand dashboards, visualizations that will give us clear idea of how a particular product or how a particular service is functioning. So some of the pros for using Elk are: first, it's highly scalable, and second, it does all the processing in real time. Being highly scalable means that when you want to expand a business or when you expand the limits of your service that you're providing people, you want to make sure that you're doing a good job. So you want to make sure that you're getting a perfect result. So for that, you would use a monitoring tool to see how well your service or your product is doing. So if you suppose expanded and added multiple servers for your application or for the service you're providing, you want to see how well those servers are performing. So you could use Elk for that purpose. And Elk can be used even with single server or a small application, and it can be used with multiple servers or a bigger application. And it being real-time processing means that it can be attached to an application that is working at the current time. If suppose your application is right now in production and it is being used by customers, even then Elk can be used by attaching itself to the product and then monitoring how well it is working. All the logs of how people are accessing it, from where they're accessing, what browser they're using, where they're using it from, all those details will be stored in some log file. And that log file will be given to your Elk, where it will process it and analyze it so that a good visualization could be created when the person who is responsible to see how well the app is working can figure out where he needs to put his attention more. If suppose the app is not getting a lot of attention from a particular area, then he can focus on that particular area of the world. Or if there are some issues in the app, if there's a lot of memory usage, but you do not see as many as users on your app, that means there might be some kind of security issue. So the person who's monitoring it can figure this out using this product. Now, Elk is an open source software, but even though it's open source, there is a paid version which has some extra features, but these features aren't deal breakers. You can satisfactorily use the open source version for most of your needs. What are the components of Elk? Now that we have understood what Elk is, let's see which all tools are used inside Elk. Now remember, Elk is a set of tools. There are multiple tools used inside of Elk. So that is why we call it Elastic Stack. It used to be called Elk before because in the starting, when the company started, they had only one software, that was Elasticsearch. And after they started to expand, they got two new softwares, that was Logstash and Kibana. When they had these three tools, they made all of them together and they made it into Elk, that is Elasticsearch, Logstash and Kibana. But after that, they added one more component, one more tool called Beats. So they did not want to keep this precedent of adding more letters to their name. They decided to change it and they made it into Elastic Stack instead of Elk. Saying Elk or Elastic Stack, both are right. It depends on what you want to say. So let's see what are the components of Elk. First, it's Elasticsearch. It is used for storing and searching collected data. Second is Logstash, used for collecting and filtering the input data. Now you would use Logstash to collect all the data that you need, all the raw data, and then you would filter the raw data. And after you're done filtering the raw data, you would send it to Elasticsearch, where the filtered data will be stored and indexed. The third tool is Kibana. Kibana provides a graphical user interface. After your Logstash has collected all the data and it has filtered it according to our needs and sent it to Elasticsearch for storing and indexing, then you can use Kibana to use that data from Elasticsearch and make meaningful visualizations. You would use Kibana as your main user interface after you've installed all of these tools. And inside Kibana, you can make a dashboard according to your need. If you want a heat map of wherever your requests are coming from all over the world, or your world map, or a coordinate map, or a bar chart, or a pie chart, etc. Any kind of visualizations you wish to. And the fourth and the final tool is Beats. Now, Beats are itself multiple lightweight data collectors. Now, Beats is just like Logstash, but it differs in the fact that it doesn't filter the data and it can much more easily collect data than Logstash since they're lightweight, small tools. Now Logstash is one tool, but Beats have multiple small tools inside it, which can attach them to their particular source and collect data from there, which we will see further. Elasticsearch. Elasticsearch is a NoSQL database that was developed based on Apache Lucene search engine. It can be used to index and store multiple different types of documents and data. It provides a function to search the data that is stored in real time as it's being fed. Elasticsearch is where all the data would be stored. It is the NoSQL database where multiple different formats of data can be stored and indexed. Logstash. Logstash is a collection agent and is used to collect both heterogeneous and non-heterogeneous data from various sources. It has the capability to screen, break down, and make string alterations in the data it collects. After it has collected and filtered the data, it then sends it to Elasticsearch for storage. What Logstash does it, as I said before, it collects the data and then it filters it and then breaks it down according to our need and then sends it to Elasticsearch so that it can be stored over there. Kibana. Kibana is a graphical user interface that is used to display the data that was collected and stored in Elasticsearch. It displays them with appealing visuals so that the data could be easily understood, analyzed. It does so using multiple different types of visuals like bar charts, pie charts, world map, heat maps, coordinate maps, etc. After Logstash has collected the data and filtered it and then sent it to Elasticsearch for storage, then only then can Kibana take that data and create a graphical interface, and using that the users can create visuals using the data we collected. Basically, Kibana gives us a UI during data access in Elasticsearch. So now let's see what are the features of Kibana. Since it's the main interface users will be using to access anything or control anything inside Elk. So the first feature, discover the data by exploring it. This basically means that whenever you collect data, you're exploring that data about your service or product. It means you understand your data by exploring it, by understanding how it is being produced. Second feature, analyze the data by applying different metrics. Now, Kibana allows us to analyze the data we have collected by applying different metrics. If you wanted to use a timestamp or use geolocation or use the number of days that have been spent on that particular product or see which kind of browser is being used, all those different kinds of metrics can be used. Basically applying different filters on the raw data. Visualize the data by creating different types of charts. We can have different types of dashboards with different types of graphs and different types of charts. If you wanted to create a dashboard customized for one of your specific applications, then you can do that and then you can save that dashboard. Anytime you want to monitor how well your application is doing or the data that is coming from that application, you can use that dashboard. Apply machine learning on the data to get data anomaly. Basically, you can use machine data to study the data you're collecting. And based on your study, you can figure out if there are any anomalies in that data or not. Also, again, this is a feature of the pro version of Elk, not the open source version. Manage users and roles. Basically, it allows you to create users in your Kibana and manage what kind of roles or what kind of access those users will have. A console to run Elasticsearch expressions. Basically, it allows you to run queries. Like, for example, if you wanted to access something through in Elasticsearch, you can use queries to do so. Play with time series data using timeline. Basically, it allows you to study your timeline and apply time series functionalities to see basic trends or here and there. Monitor Elastic Stack using monitoring, which is basically monitor how well everything is doing in the end. So let's see which is the fourth tool, that is Beats. Beats is similar to Logstash in the matter of fact that they both collect the data that will be later stored and analyzed. But Beats differs in the method of collection. Here, Beats are multiple software installed on different servers from where they can collect the data and send it to Elasticsearch. Like I said earlier, Beats is not a single tool. It is a group of multiple tools which perform the same action as Logstash, except that they don't filter the data. But what they do is they attach themselves to the particular source and collect the data in real time and feed it back to Elasticsearch. They can either directly ship that data to Elasticsearch, or they could send it to Logstash, where the collected data will be filtered by using Logstash's filtering ability. Now, if we look at the different beats we have, they are file beat, which is used to collect information on logs or log file. Then we have metric beat, which gathers metrics like RAM, CPU usage, input, output, application runtime to check if the app is running or not. Then we have packet beat. Packet beat is used for checking networking, analysis on networking data. It helps in figuring out discrepancies in data that may be being trafficked on the network, the actual data that being sent and received. It helps in making sure no one else is maybe using the network and stealing any of the sensitive information that is being trafficked over the network. Then we have audit beat, which is used for collecting audit events. Basically, audit messages contain details like if there was an unauthorized access to the system, it will record it based on the criteria that is set by the organization. Anytime you're accessing the admin or anytime you're accessing the user, then those kind of data will be stored in audit logs, and audit beat will collect all those logs. Then we have WinLog beat. It's exactly like how audit beat works, only difference being it works on Windows based systems. It keeps track of events like hardware, security and applications on Windows systems. And then we have Heartbeat. It's for uptime. Whether you are alive or not, it will record ping statistics. It will see if the remote server is reachable or not. That's its only job, to see whether there are any keep alives being pinged from one server to another, and will record all those. Elk flow. Now let us see step by step how the data flows from one software tool to another inside Elk. First, the beats are attached to remote servers from where the beats collect information from various sources. After collecting all the data needed, they either ship the data to Logstash for filtration or directly send the data to Elasticsearch. The data is then stored in Elasticsearch. From here, it will not be directly sent to Kibana. Kibana first needs to check where Elasticsearch is and then go and get the data itself, so that it can later use it for any visualizations. If we see here, the data is first collected from the servers onto the beats, and then the beats take all the collected data and then ship it to Logstash or directly to Elasticsearch. After they ship it, Logstash will take the data, it will process it, and then it will filter it. And after it's done doing that, it will send the data ahead to Elasticsearch, where the data will be stored and indexed. And then finally, Kibana will take all the data from Elastic and it will analyze it and create visualizations based on the data. And suppose if there are any errors in the whole process, then notifications will be sent to whoever's responsible using either Slack or whatever email notifier you have attached to it or configured to it. Features of Elk. System performance monitoring. So basically, it captures all the CPU usage, memory usage, input outputs, network performance, load averages, and etc. It has something called log management also, which basically means that it acts as a centralized logging storage. Now, every time a software works, it stores some kind of log data. Basically, all the metadata, like what kind of access was made to it, what kind of dependencies did it download, where was it accessed from, what was it accessed using, things like those will be stored in some log files. And Elk can manage those log files and can act as a logging manager. Application performance monitoring. Now we can install an application performance management agent and integrate with Elk. So basically what would happen is, if you wanted to monitor the performance of your application, how much memory it's using or how many requests it has or something like that, then you can use a third-party tool for application performance monitoring. Now Elastic itself provides its own APM, that is Application Performance Monitoring Manager. That itself is developed, but it is not open source. It can also be integrated with your Slack or email so that it will be able to send you emails or notify you anytime something goes wrong. Application data analysis. It's pretty self-explanatory. What it means is that it analyzes all the data you have collected, and based on that, it creates predictions or analysis. Security monitoring and alerting. Basically, if there are ever any security issues in your application or your service or your pipeline, it will inform you about it. And the last one, data visualization. As we talked a lot about. Kibana is used for this particular feature where all the data collected will be visualized in a meaningful manner so that we can understand how much or how well something is performing. Guys, now that we have understood what ELK is or Elastic Stack is, and now that we have understood what are the components of ELK like Elasticsearch, Logstash, Kibana or Beats, we can go ahead with its installation. Now let's go ahead and look at what are the prerequisites for it. So the prerequisites are have at least 2 GB of RAM and have at least 20 GB of storage. And third, Java. So let's go ahead and configure all of these into our AWS instance. So we will come to our AWS website and go into the AWS console and launch the EEC2 dashboard. Now let's go ahead and click on launch instance. Now in this case, we will not be using CentOS 7 from AWS Marketplace. We will go ahead and use our Ubuntu server that is inside our free tier eligible quick start itself. Just scroll down, click on Ubuntu server 18.04, click on t2.medium since that's the one we'll be using. Click on configure next, add storage, we'll need at least 20 gigs of RAM, 20 gigs of space. Configure the security group, we'll make it all traffic. Review and launch, choose the existing key pair, acknowledge and launch instances. Go ahead and view your instances and give it a name. I'll give it L. While it's being initialized, I'm going to go ahead and launch my putty tool and paste my IP address, increase the font size, change the color, green, connection, keep some seconds alive so it doesn't switch off, authorization, use the key, and now we'll wait for it to get initialized. Now that's running, we can go ahead and click on open. Click on yes and log in as Ubuntu since we're using Ubuntu instance. We have started our instance. We have configured it as with at least 4 GB of RAM and 20 GB of space. Now let's go ahead and install Java. So let's look at the step for that. First command we'll be using is sudo apt-get update. So we'll update it before getting Java. Let's update it. Please sudo apt-get update. Okay, now that we have updated our instance, let's go ahead and install Java. So for that, the command is sudo apt-get install -y openjdk 8jdk. So let's clear the screen. Sudo apt-get install -y openjdk 8jdk and press enter. This will install Java for us. And since Java is a dependency for using one of the ELK tools, it will help us install the other tools. Now that we've installed Java, let's look at the next step. Next step will be installing Nginx on the instance. So for that, we will first update it, that we have already done, and then we'll use the command sudo apt-get -y install Nginx, and then we'll enable. Come back to our instance, type in the command sudo apt-get install -y Nginx. Now we are installing Nginx because we'll be using this as a web server to access our Kibana. Since Kibana cannot be accessed from the outside, so we'll be using Nginx to access the Kibana from our current host, our user host, instead of our instance. So now we have installed our Nginx. Let's go ahead and enable it. Sudo systemctl enable Nginx. We have enabled it. Now let's look at the next step. That is downloading and installing Elasticsearch. So we'll be installing our Elasticsearch. So for that, the command we'll be using is wget and this link address. Paste it. And this is where our Elasticsearch is there. You can go and get this directly also from the website, but I'm just going to go ahead and paste this and press enter. Before that, I'm going to use sudo. Press enter. Then we'll use the command sudo dpkg -i Elasticsearch, and this will install our Elasticsearch, this command. Okay, now that we've downloaded the package for Elasticsearch. Let's go ahead and install it. Sudo dpkg -i Elasticsearch, the version of it, and amd64.deb. Now press enter. Okay, now that we've downloaded a package Elasticsearch and installed it, we can go ahead and do the same thing with Kibana and Logstash. So the command for that is, first we'll get the package sudo wget, and this is the link of Kibana. You can get this from the website again in the same place. We'll download the package and then we'll download it, and then we'll install it using the dpkg command. Sudo dpkg -i is for the install, Kibana, and the name of the package we've installed. Let's go ahead and do the same thing for Logstash. Wait, before Logstash, we'll need to download one more dependency before we can install a Logstash. For installing that dependency, the command is sudo apt get install -y apt transport https. Press enter. Now we installed another dependency also. We can go ahead and install Logstash. So let's go ahead and get the link for Logstash. This is the link. Let's copy it. Again, you can get it from the website. Sudo wget and the link of Logstash package. We'll download the package and then we'll install it using the dpkg -i command. Now that we have installed Elasticsearch, we have installed Kibana, Logstash, we can go ahead and install our file B. Now, as I told you earlier, Beats is one of the tools, and Beats itself consists of multiple tools inside. So the one we'll be using today is FileBeat inside Beats. So let's go ahead and install our FileBeat. So let's look at the command for that. It's going to be the same thing as our previous ones. We'll be using wget to get the link of FileBeat, and we're using dpkg to install the package. Now for the last one, I'll show you how to get it from the website itself. We'll go back to our browser, open another tab. In the browser, we will type Elastic, that's the name of the company, and FileBeat, and we'll be using the 7.2 version. Now since that is the version we need, all the other versions of the tools we downloaded was 7.2 if you notice. So this is the one we'll be downloading, even though the latest version may be something else. Now I'm doing this only because of consistency, but you can go ahead and install the latest version if you wish to. This is the version I'll be selecting. This is click on the first link and then use the DEB 64-bit version. So right click on it, copy the link address, come back to your instance, use the command sudo wget to get the link, paste the link address and press enter. This will download a package for us. As you can see, the package is downloaded now. Now we will go ahead and install FileBeat. So we will use the command sudo dpkg -i for install and the name of the package FileBeat, and go ahead and click enter. This will install our FileBeat. Okay guys, we have installed all of our packages that we needed. We installed first Elasticsearch, then second Kibana, then third Logstash, then fourth FileBeat. Now we have all of these. We can go ahead with the practice. Now let's look at what are the steps we'll be taking during our hands-on or practice. Elk hands-on. So let's look at what are the steps we'll be taking. First, collecting static Apache logs using Logstash and analyzing them using Kibana. Second, collecting static .csv files using Logstash and analyzing them using Kibana. And the third, collecting and configuring real-time web logs and injecting them into Elasticsearch and analyzing them using Kibana. So what's happening here is that in the first two steps, we'll be analyzing two different types of static data, where the data is static, where we already have the sample data and we're not collecting it real-time from one source. And in the third step, we'll be collecting the data from a real source, and we'll be doing it in real time. We'll be feeding the data continuously from our source into our Elasticsearch, and then we'll be using Kibana to analyze it. Suppose if we saw any changes, suppose there were any changes in the data that was being collected, we'll be able to see that on Kibana. Let's go ahead and do all of these steps. We'll come back to our instance. Okay guys, before moving on towards the steps, we'll go ahead and configure our Elasticsearch and Kibana. So let's go ahead and configure our Elasticsearch. For that, we will need to go inside etc Elasticsearch and Elasticsearch dot, let's use the nano editing tool. And once you go inside this .yaml file, you can see that all the configurations can be made inside this. So the configuration we need to make is, we just need to take out the comments. We need to make sure cluster name is not a comment. We need to make sure that node.name is not a comment. And we need to make sure that the network host is not a comment. And inside the network host, replace whatever IP address is there with local host. And come down, and the HTTP port, leave it at 9200. The 4 things we have to configure inside the Elasticsearch.yaml file is, we have to set the network host as localhost, and you have to uncomment HTTP port, and you have to uncomment the cluster name and the node name. After you're done with that, go ahead and press Ctrl O, press enter, and Ctrl X. Now we have made changes to our Elasticsearch.yaml. So we can go ahead and start it. Sudo system ctl start Elasticsearch. If we check out the status, it says that it's active and running. Great. So let's go ahead and do the same thing with Kibana. We'll type in sudo nano /etc/kibana/kibana.yaml file. Now let's go inside this, and the 2 things we have to uncomment are the server port. We'll leave it at 5601, and the second thing we have to configure is, we have to remove the comment over here and make sure that server.host is localhost.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What are the key components of DevOps? A. Continuous integration. B. Continuous testing. C. Continuous delivery and monitoring. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
After you uncomment server port and server host, just go ahead and save it and exit out of that. Now we have configured our Kibana and we have configured our Elastics. Okay, let's go ahead and start our Kibana. For that, the command is sudo systemctl start Kibana. Let's check out the status. It's active and running. Great. Clear the screen. Guys, now let's go ahead and configure Kibana so it can have a username and password when we access it using Nginx. So for that, we would need to use something called htpassword. Now, htpassword is a part of Apache 2 utils. So we need to install that. So we'll go ahead and type sudo apt get install -y Apache 2 utils. Now that we've installed that, we can go ahead and use that command. So the command is htpassword. This will help us generate a hashed password for our user. Let's add sudo before this. Sudo htpassword -c space etc/nginx/htpassword.users. This is where we'll store all the user and passwords. And let's go ahead and type the username now. So the username we'll be using is kibadmin. Keep admin. Press enter. It will prompt you for a password. Enter a simple password since we are just practicing. It will say that adding password for the user kibadmin. Now if you want to see if a password is added or not, we can go ahead and check it inside. Sudo nano. Let's go ahead and take this and paste it and press enter. We can see that inside the full file we have kibadmin and the hashed password. Let's go ahead and save it and exit. Now that we have a password, we can go ahead and configure our Nginx default file where we will connect our Nginx to our Kibana. For that, we will type in sudo nano /etc /nginx /sites available and default. Inside this file, we'll be storing the code which will configure our Nginx to be connected to Kibana. So the code will be, this is the code we'll be using. Server listen at 80, server name, instance private IP. Let's go ahead and write that. It's basically going to be the IP address of the instance we launched using AWS.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
So to get this, we'll have to go to the browser. Let's go to the browser, come to our AWS console, copy the IP address of the instance we launched, come back, paste it. Great. Now that we've configured it to connect to our instance also, make sure that the basic user file is going to be the place where you stored the username and the password for Kibana. And the proxy pass you use at the port, localhost port 5601. When we access this IP address at the port 80, it will indirectly connect us to localhost at port 5601 where we have our Kibana. So we can access a Kibana indirectly using Nginx anywhere from outside. So let's go ahead and save this. Ctrl O, enter, Ctrl X. Now that we have configured our Nginx, we can go ahead and start Nginx. Sudo systemctl start Nginx. Now let's go ahead and check out the status. It is active and running. Let's go to our browser and launch it. So we'll copy the IP address, paste it, and press enter. Now it will ask us the username and password. The username and password we use will KIB admin, and password would be the one you entered. As you can see now that your Kibana has started. We'll just explore on our own. That was the step to start Kibana by connecting it to Nginx. What we did was we created a password and username using HT password. This is the command sudo HT password -c etc nginx HT password.users kiba admin. So we use this to create a username, and as it will prompt us the password, we enter the password and we stored it inside this file HT password. And when we were configuring Nginx inside the default file, we mentioned the path to this for authorization. That's why when we access this, it gave us the prompt to ask our username and password. And it also connected the Kibana to internet. Normally, Kibana would not be able to be accessed by anyone from outside. We could only have access it from the instance, but we want everyone else also to access it. So we connected to Nginx, which acted as a web server, which connected to the Kibana on the port 5601 and made it available on the port 80. Clear? Using Kibana, we'll be creating some customized dashboards and visualizations. So let's go ahead and ingest some static data so that we can visualize it. Come back to our instance. So to start the whole process, our first step, we would first need to download a static sample data set. To do that, we will use the wget command and we will get a sample data set. So let me tell you what the link would be. The link would be https://logs.io/sample data -o. Wait, okay. This is the thing we'd be needing. Sudo wget https logs.io sample data. So this will download some Apache logs. These are just sample logs which somebody posted online, and we're just downloading them for our practice. One second. It's logs with a Z. Now if we ls, we have our sample data. Now let's name it much more appropriately. Let's go and use the command sudo cp to copy the sample data file, and we will push it into apache.log. More appropriately named now. So if we ls it, we'll see the Apache log is here. Now, if we cat the apache.log file, we can see all the data has been stored. This is the sample data we downloaded. Now let's go ahead and inject this so that we can visualize it using Kibana. For that, we would first need to go inside logstash. We will go inside cd etc log stash. Now you would have noticed most of the packages we download and install are inside etc. Mostly they'll be inside etc only. etc logstash and inside conf.t. Now inside this we will have a file apache.log.conf. We'll open it up. And this is a new file, and inside this file we'll create a pipeline. Normally, maybe the users or the support engineers or the middleware engineers would tell us how the data will be injected in Elasticsearch. For that, we would need to write a pipeline. A pipeline mainly consists of three things: input, that is the source of data; filter, what kind of data is not to be sent; and output, where do we have to send the data to. Let's go ahead and write our pipeline inside the logstash. We come back to our notepad. This is the code we'll need. Let's get out of here. Use nano. Alright, let's go ahead and paste the code. We use nano because nano is a bit better editor. Gives us a little bit more options to work with. As you can see, as I said, this is the pipeline. Normally you would code it, but I've already written it. I'm just going to go ahead and paste it, and I've pasted it here. Now in the path you would mention where the file is located. Your sample data set is located. Right now my sample data set is located inside home Ubuntu in apache.log. We'll go ahead and make sure this is correct after we go through the whole code. This is where the log will be located. And the second thing we'll be configuring is starting position, that is the beginning. If you want, you can change it to middle or end. And since we don't have any database directly where we can extract the data, we're not going to put anything, we're just going to leave it null. And this is the filter. And grok is a filter. Here the timestamp and the GeoIP, the date, and these are the ones that are going to be filtered using these keywords. Okay. And in the end, the last thing, that is the output. That output will be stored inside our Elasticsearch. The host at localhost at the port 9200. And this index is important. Right now, whenever you would go to your Kibana, you would first have to create a new index. You would have to create a new index, only then can you access the data. For that, we are writing over here, example pet clinic prd1. We will be easily able to identify what our data is stored as inside the Elasticsearch. Right now our data is only stored inside our system now, and we are going to be outputting it to Elasticsearch. So we will index it under the title pet clinic prd1. Now I'll explain to you why I've written 1 over there bit. So let's go ahead and save this, press enter and come out. Now that we configured our apache log.conf, we can go ahead and start our logstash. Use the command sudo systemctl space start logstash. Now we can go ahead and check the status of our logstash. Okay, it says it's active and running. Now let's go to our browser. We can check where our data is. We can access the data in the Elasticstash. Right now what must have happened? Logstash must have taken the data from our instance and sent it to the Elasticsearch, where Elasticsearch would have indexed it under the title we had given it. So if we go to our browser, now that we're inside our browser, we will go to the first icon over here called Discover. Inside Discover, our first job would be to create an index pattern. You would go under Kibana, click on Index Patterns, and there'll be an option here to click on Create Index Pattern. We will go ahead and type the index name here. Remember what index name we had given before? That was pet clinic. If we type pet clinic over here, we should be able to get a, yes, as you can see, we were able to find our sample data that we had stored in our Elasticsearch. Now we have pet clinic. Let's just The thing is, why we type to 1 over here is because sometimes we might have multiple different logs or multiple different sets of data. If you want to select all of those data, if I had like a pet clinic, PRD 2, 3, 4, 5, and I want to select all of them, I could go ahead and use this star, pet star. But if I only wanted only one of them, I could go ahead and type pet clinic, PRD, and 1. This would only select one of these. But if I had multiple of them and I want to select all of them, I could go ahead and use my star. Next step. And we'll use the timestamp. This is for configuring settings. Go ahead and create an index pattern. To visualize and explore data in Kibana, you must create an index pattern. An index pattern tells Kibana which Elasticsearch indices contain the data you want to work with. An index pattern can match a single index, multiple indices, and a roll-up index. The one we selected was single index. Just because we added data to Logstash, it doesn't mean the data will show up. That's why we needed to create our index pattern to see which data would be indexed. Basically, it's like categorizing the data that you receive. And that's how we did it. We wrote pet clinic PRD 1 star. We got our index over here. Our index pattern can match multiple Elasticsearch indices, but we only had one. It only worked with this one. Now we can see that these are all the keywords over here. If we wanted to check if we click on discover, you'll see that we can go through our data, whatever data we have stored in Elasticsearch, and you can use many things over here. First thing we'll see is filter. We can go ahead and write something. So I'm gonna go ahead and type one of the keywords, GUIP city name dot keyword. And I want to search for particular city, so I want to search for Taipei. So if I click on Taipei and I'll click on update, it will give me only the data for Taipei, with the keyword, with filtered keyword Taipei. So it will only give me all the data that was accessed through Taipei and give me a graph also. Now you can go ahead and use KQL, that is Kibana query language. It offers a simplified query syntax and support for scripted fields. It's like basic queries in simple language. Now if we go to our search and type A, we'll find agent.keyword. These, whatever keywords we type, right? Like we typed A and we found agent.keyword. Whatever fields we typed are generated based on whatever data we have. These keywords are always related to the data and they can be filtered if you want them to be filtered. If we click on agent.keyword and click on Mozilla, it will show us all the Mozilla Firefox accessed requests. And one more thing we could do is you could go ahead and change the time. You click on the calendar icon over here. You can change whenever you want. It will give you 1 hour detail. But since this is static data, it doesn't really matter over here. If you go last 1 year, it will show you the data for a whole year. And all of this happens in real time. And if you want to add a filter, since we have created this filter, we can go ahead and add this. Or we can add a filter. You want to add timestamp or you want to add index, whatever. So you can go ahead and add your filters over here. Okay guys, now that we've learned how to upload Apache logs or logs in general.
Just a quick info guys. Test your knowledge of DevOps by answering this question. Which of the cloud platform are not used for DevOps implementation? A. Google Cloud. B. IBM. C. Microsoft Azure. D. Amazon Web Services. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
Now let's get started. What is an artifact and what is an artifact repository? The files that contain both the compiled code and the resources that are used to compile them are known as artifacts. Basically, whenever a developer writes his source code, he gives it to a build tool so that the build tool can compile that source code into binary code. This is because whenever a developer writes source code, he writes it in the language that humans can understand, a human language. But machines can't understand that language. To make it understandable for machines, the build tool compiles it so that it's converted into a binary code, that is ones and zeros, that can be easily understood by machines. When these binary codes are taken together with the dependencies and resources that are required to run it and put together into one file or packaged into one file, that one file is known as an artifact. Basically, these are readily deployable files, like an executable. In Java, an artifact would be a .jar file or a .var file or a .ear file. .jar files are basic Java applications and .var files are for web applications, and .ear files are for enterprise applications that can be contained in EGB containers. In NPM, the artifact file would be a .tar.gz file, and in .NET, the artifact file would be a .dll file. Now let's go ahead and understand what an artifact repository is. What is an artifact repository? An artifact repository is a repository which can store multiple different versions of artifacts. Each time the var file or the tar.gz file is created, it is stored in a server dedicated for the artifacts. Now, how we normally go ahead with software development is that we write the source code and then we compile it, and then the code is tested and then reviewed, and then if successful, then the code is sent for deployment. But with the agile tech in use, there'll be a lot of different builds being made every day, even within a single team. And each time we change the code, we need to compile the code and then deploy the build in the server. But there might be a scenario where the testing team or the QA team will find an error in the code, and now there would be a need for a rollback. For this rollback to happen, we would have to go back to our Git or whichever VCS we were using and then remove the first commit and go back to the previous commit, because we wouldn't be sure of what kind of error there might be in the latest version. So we need to go back to the previous version and deploy that one again. Instead of doing all that, what we could have done is we could have stored our artifacts in a repository and we could have deployed the latest version using that artifact of the latest code. And if there was any error, we could roll back easily by just going back to the repository and deploying the artifact that was previously used. For example, here, if you see that there's an artifact version 1 and that has been stored inside the artifact repository, and then it goes for deployment. And then artifact 2 is stored in the artifact repository, and then it goes for deployment. And same with artifact 3, which also goes for deployment. Now, I suppose there was a need for a rollback because artifact version 3 has some error in it that can't be identified at the moment. But the customers still need to use the app, the application that is being used. So for that purpose, what we can do is, instead of going back to our source code in our version control system and going back to the previous commit, what we can do here is we can go back to the artifact repository and just use version 2 instead of version 3. So we could use artifact version 2 and then go ahead and deploy it. It's as easy as that, just going to a repository and selecting the previous version, so that the customer is still satisfied and we can look for errors in our new version 3. Sources versus binaries. Now let's understand the difference between source codes and binary codes. Source codes are stored as text, whereas binaries are stored as blob files. Source codes are diffable, whereas binaries are not diffable. What this means is that we can compare two different source codes as they're stored as text form, whereas we cannot compare two binary codes. Source codes are versioned by content and binary codes are versioned by name. Since we can compare the different source code, we can version them based on their content. But this is not possible in binaries, and therefore binaries are versioned by their name. Source codes are stored by override, but binaries are not stored through override. So what this basically means is that while using source code, when there is a need for an update, the current file is updated by replacing the previous file. Whereas in binary, while binary code is being used, the current file will never be rewritten. All the files are stored together. So when there is a need for an update, the current binary code will be pulled and the latest one will be pushed. Now that we have understood what an artifact is, what an artifact repository is, and the difference between source code and binary code, we can finally go ahead and learn what JFrog Artifactory actually does and what it is. JFrog Artifactory is a tool used in DevOps methodology for multiple purposes. One of its main purposes is to store artifacts that have been created in the code pipeline. Another one of its purposes is to act as a sort of a buffer for downloading dependencies for build tools and languages. So what basically JFrog does is it acts as a Google Drive for our artifacts. We can store whichever artifact we want in that and then pull whichever we want. Now, JFrog can be easily integrated in a code pipeline. As you can see here, what happens is First, the version control will give the source code, the latest source code, to the build tool, and the build tool will build it and then produce a resulting artifact, which will then be stored in JFrog Artifactory. And if deemed worthy, then JFrog will send it to the deployment. This is all done with the help of the continuous integration tool, which could be your Jenkins, TeamCity, Bamboo, Excel Deploy, which is software tool you are using for continuous integration. Now, the first thing JFrog helps in is that it helps in storing readily deployable code. So basically, whichever artifact we create or whichever artifact is the result of the latest source code that has been compiled will be stored in the JFrog Artifactory. So like how we talked about an artifact repository, this is the same function that JFrog Artifactory performs. The first artifact version will be stored in JFrog, which will then send for deployment. Then the second one will be stored and that will be sent for deployment. And the third one will be stored, which also would be sent for deployment. And suppose there's a need for rollback because there's an error in version 3 that causes the application to crash, then we can pull back version 3 and then go ahead and deploy our version 2 again. It's a simple process of just selecting it. So this is one of the first responsibilities of JFrog, that is to store all the artifacts, which can then go ahead for deployment. And the second responsibility of JFrog is to help in downloading and managing dependencies. Since JFrog will be connected to the build tool, what happens is that whenever a build tool requires a dependency based on the source code, usually the build tool will download the dependencies. But in this case, JFrog acts as a buffer or a proxy for downloading and managing these dependencies. So if a build tool asks for dependency to JFrog will get the dependency from a remote repository and then will store it in a local server, which will be then used by the build tool to build the source code. So those are the two responsibilities of JFrog. First, it helps in managing and storing artifacts. And the second responsibility is it acts as a buffer for build tools to download and manage dependencies.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Now that we've learned what JFrog Artifactory is, why should we use JFrog for DevOps? So the first quality that sets JFrog on the stage for using in DevOps methodology is its high availability, system stability and reliability with Artifactory high availability. The binaries needed are always available on JFrog once they are cached with it, and there is a certain assurance for their availability provided by the company. But the same can't be said about open source software, which doesn't provide the same assurance. So what basically high availability means is that whenever we are storing our artifact inside JFrog, we have a certain assurance by the company that has created JFrog Artifactory, that is JFrog, that our artifacts will be available all the time. And since we would be paying them if we are using the Pro feature or the Pro version of JFrog, then they absolutely have to give you the guarantee that all the artifacts that you need at the moment will be available through the repository. But the same can't be said with open case repositories, which do the same thing, because you can't ask them for an assurance for whether you will be able to pull the artifacts that you have stored in using their software at any time of point, because their website may crash or their servers may crash and you will not be able to pull it. And you can't even blame them for this because you're using their software for free. But since you're paying for the application, that is JFrog Artifactory, you can have an assurance that is provided by the company that your artifacts will be available at all times. And if they aren't, then you can hold them responsible. Then the next quality is managing binaries across different environments. As the number of projects in a company grow, it becomes harder and harder to maintain the number of binaries each of them use. To avoid chaos, JFrog manages environments and the binaries, which means is that if you have different teams working using different environments and storing different artifacts, there's a probability that there might be some chaos involved, that you might mix up some artifacts here and there. But JFrog assures that this will not happen. It has the ability to store different artifacts for different projects, for different teams in different places. So that such a thing does not happen. The next quality is security, access control, and traceability. Since JFrog works on caching assets important to the company, that is the source code of the software, it keeps the system secure and keeps track of metadata like which person logged in at which time and what kind of changes or activity did they perform. Since a company's source code is its asset, it's its most important thing, it's important to keep it safe. And JFrog helps in keeping your source code secure. It keeps track of metadata like which person logged in at which time and what kind of activities and changes did they perform. Having such kind of metadata in storage means that if there is any sort of conflict in future, then the party responsible for the conflict can be found out using this feature. Another quality is full support for Docker. JFrog provides support for storing and distributing Docker images through its repository, which is simple enough in the terms that it means that you can easily store your images for Docker inside JFrog, and then you can distribute it using JFrog. So basically, it has a seamless integration for Docker. Another quality is quickly replicating remote repos in local area. JFrog is very efficient in replicating and storing remote repositories in short amount of time using check-based storage system. If one of the tools in your code pipeline wanted a remote repository for functioning, then you can easily ask JFrog for it, and JFrog can easily replicate that repository and store it in a local server for further or future use. It has support for Chef. JFrog has comprehensive support for Chef. This allows for creation of targeted configuration scripts that make sure only permitted dependencies are used for particular projects or environments. Since JFrog has a lot of support for Chef, it means that it would be easy to make targeted configuration scripts to make sure that only permitted dependencies are used for a particular project or an environment that is being used. Use cases for JFrog Artifactory. So there are many use cases, and let's see what are they. First, it's binary repository manager. As we have seen, it manages our binaries or artifacts. It's a place where you can store all your artifacts. So other than managing our binaries, it can also store all our artifacts. It's a proxy for remote repository, which means is that it acts as a proxy for getting those remote repositories. If a tool inside our code pipeline wanted to use a repository that is not inside the intranet of the company or of the team, then JFrog can act as a proxy and get the remote repository for the tool. Dependency manager working again, which means is that your dependency manager, whichever one you're using, will work against it when you download a dependency and will ask JFrog for the files, and when it does so, JFrog will get those files from internet. It's a place where we can store all our Docker images so that anyone who's working within the code pipeline can easily pull those Docker images without actually having to go outside. Artifactory integration, which basically means is that it has support for integration with multiple DevOps tools. If you wanted to use some DevOps tools that are not standard, it also supports the integration with them. It provides a faster release and business continuity, which means that you can install JFrog in multiple servers. It can be scalable. It has disaster recovery options and replication options, which are only available in the enterprise version, not in the open source version, since this is the feature that will be provided by the company. Orchestration tools. It provides support for different orchestration tools like Docker, Kubernetes, and Helm that can be easily integrated with JFrog. And it is storage ready, which means that it has the ability to store data in multiple areas like S3 object storage, which is a typical web service that lets you store and retrieve data in an object store via an API reachable over HTTPS. The service offers unlimited storage space and stores your data in a highly available and durable way. Now that we've understood what an artifact is, an Artifactory repository, using that knowledge to understand what JFrog Artifactory is and why do we need it in DevOps, and learning some of its use cases, we can go ahead and install our JFrog Artifactory. So let's look at some of the prerequisites of it. So before installing JFrog, we will need to have OpenJDK in our instance and have at least 2 GB of RAM, which means we'll have to use the marketplace CentOS. Now let's go ahead and create our CentOS. So we will go to our AWS console, click on launch instance and go to our AWS marketplace, type CentOS and then click on the first one that you get, CentOS 7. Continue. We will need to use tt.micro since it has the required amount of memory that we need, that is at least 4. let's review and launch it. But before that, let's add a inbound rule for all TCP anywhere. Review and launch. Use an existing key pair. Click on I acknowledge and launch the instance. Your instance will be running now. View instance. Name it appropriately. We will name this JFrog Artifactory. Okay. Now we'll wait for it to get initialized so we can copy our IP address and launch it using our putty tool. Paste the IP address here. Let's make it a little more visually appealing so you guys can see it properly. 180 seconds between authorization, and so we'll go ahead and put our key in. Browse key. Okay, open it. Click on yes. Login as CentOS. Okay, clear the screen and let's make it full screen. Our first prerequisite was OpenJDK. So let's install OpenJDK. Let's sudo su so we don't have to keep typing sudo. Clear. And the command for installing OpenJDK is yum install java 1.8.0 OpenJDK dev. Yes, please. Yes. Okay, our Java is installed and we have an instance with space of at least 4 GB RAM. Okay, now let's go ahead and install JFrog. Now we can go with two ways with this. We can directly install the tar.gz file, or we can use Docker to install it. Docker to pull the image and then launch it as a container. So for that, first we'll need to install Docker inside our CentOS instance. So for that, the commands are sudo yum install, yum utilis, device mapper persistent data, and lvm2. These are the packages that we'll need for Docker. And press enter. This will install the packages that we need for Docker. Okay. Now that we've installed the packages, we can go ahead and set up a stable repository for Docker. So let's copy this command. This is the command we'll need. And come over here to instance, paste the command and press enter. It says that the repo has been saved. Okay, let's clear the screen and go ahead and install Docker. This is the command for installing Docker in CentOS 7. Go ahead, paste it, yum install docker c client container.io. Enter. Yes, please. This will install Docker for us in our instance. Clear screen. Now that we've installed Docker, let's go ahead and start it. systemctl start Docker. This is the command to start Docker. Okay, let's make sure it's started. Systemctl status Docker. This should check the status of Docker. As we can see, Docker is active. So let's go ahead and clear the screen. And now that Docker is active, let's go and get the command for pulling JFrog from the website. So go ahead to the browser, type JFrog open source. This will take us to their open source website where we can download all the open source softwares. So we'll click on Artifactory, and Artifactory OSS is the Artifactory open source software, and you'll have the option to pull the latest Artifactory Docker image. So if you click on it, if you copy the command and paste it to your clipboard, so you can come back here and paste that command. So the command will be docker pull docker.bintray.io JFrog Artifactory OSS, and press this enter. This will start pulling the latest image for JFrog Artifactory OSS and store it inside your instance. Now we're using Docker to pull an image and launch JFrog Artifactory because it's much easier to do so rather than directly downloading it and installing it in your instance. Okay, now let's use the command docker images to check if the image has been downloaded. Yes, it's been downloaded. Okay, now that we've downloaded our Docker and downloaded the image for JFrog, let's see what the next command is. The next command is to start JFrog Artifactory, get the name of the image, pull, and run it as Docker container. So we'll be running a Docker container on the port 8081. Know the name. Docker images. Okay, so Docker run -it -t -p port number 8081 name Artifactory and then the name of the image, and paste this name, and then press enter. Now this has launched the container that has Artifactory in it. Clear the screen, docker ps to see which all containers are running, and we can see that the container is running at the port 8081 TCP. Alright, to access this we'll need to head to the browser and open another tab, copy the IP address, paste it, go to 8081, press enter, and this will start your JFrog Artifactory. And with this, we have completed the installation of JFrog. Now that we have installed JFrog, we can go ahead and practice. Now let's see what are the steps we'll be taking during our practice session. So the first step is running JFrog Artifactory and setting up the admin. That we've already done. And the second is using Git to get the sample code. And this is the sample code we'll be using to see how versioning works in JFrog. And the third step is to install Maven to compile and package the sample code. And the fourth step is to connect Maven to JFrog. And fifth is check how versioning works in JFrog. Now let's go ahead and set up the admin. We'll go here, come over here, and we'll enter the password and username. The username is admin, and the default password is password. Now this is a generic one. We can go ahead and create a proper user later, but this is just for practice. Okay, now that we're inside JFrog, we can see that this is the dashboard, and before the dashboard there's a pop-up telling us welcome to JFrog Artifactory. Click on next. It'll ask us to configure a proxy server, but we do not need to configure a proxy server right now as we're just practicing. But when do we need to configure a proxy server? We will need to do so in case we don't have access to internet from the current server or system that we're using. Suppose you're working inside a company and the only access you have is to intranet on your particular system or server. So that time you can always configure a proxy so that you can access internet through the proxy instead of directly accessing it. But let's go ahead and click on skip, and then it'll ask you to create repositories. So the repository we'll be creating today is the Maven repository, because Maven is the build tool that is used to build Java-based applications. So click on Maven and press create. So it has created 5 directories: libs snapshot local, libs release local, jcenter, libs snapshot, and libs release. So the libs release local will store the war file, the snapshot will store the snapshots of the versions, and the libs release will store the dependencies. I can go ahead and click on finish, and then it will show us the dashboard of JFrog Artifactory. Now before we move on to our next steps, let's familiarize ourselves with JFrog a little bit. So if you come up over here, it'll tell you welcome admin or welcome username. If you click on it, it will show you a quick setup. It will show you local repository. If you want to create a new local repository, you can create it from here, or you can go ahead and create a remote repository using whichever package you want. And you can do a virtual repository, distribution repository. You can go ahead and do administrative tasks like add a user, in which you can add a user, or you can add a group, or you can add permissions to particular groups or users. Now these are the administrative tools, and this is for setting up repositories for storing your artifacts. Now if you want to see administration tools in more advanced situations or more advanced tools, you can go ahead and click over here. This will show you many more things to configure: general configure, proxies, mail, SSH server, security services, import and export, and log analytics, system logs, system info, maintenance, and etc. And if we come back to our home, this will just be our home page, show basic things like quick search and the features of JFrog, and etc. And show you the last deployed builds, most downloaded artifacts, and etc. Now you can click over here and it'll show you artifact repository browser, where it will show us all the directories that we have created for our Maven. Or if you want to search for an artifact in particular, you can come over here and click on this. You can search the artifact based on the criteria and filter by artifact. So now that we're familiarized with ourselves with Artifactory, we can go ahead and complete the next steps. That is to use Git to get the sample code, install Maven, connect Maven to JFrog, and check how versioning works. So let's go to our instance. Okay, and let's go ahead and install Git in this. So we'll do yum install and git, and let us also install wget. We'll be using that to get Maven. Okay, now we install git and wget. Now let us get our sample code. So for that, we'll need to get the repository URL. For that, we'll need to go over here. You'll need this link, github.com, gkdevops, and pet clinic. This is where our sample code is located in GitHub. We'll go to our web browser, paste the link on the navigation, press enter, and this is our sample code with the pom.xml file. We can click on clone and download, copy the URL for the repository, come back to our instance, type in the commands git clone. This will clone in the pet clinic repository and paste the URL for it, and click enter. Okay, now that we've cloned the sample project, let's go ahead and install Maven also. Clear the screen, go back to our browser, type Apache Maven. We'll go to the Maven website, click on download, and come down and get the latest version and copy the link address of the tar.gz file. This is the one we'll be using. Copy the link address, come back to your instance, use the wget command and paste the link and press enter. This would have downloaded your tar file for Apache Maven. Let's go untar it. So tar zxf apache maven bin.tar.gz. Now that we have untarred it, we can go inside Apache Maven, inside bin, and see if it's working or not. So for that, command is maven version. This will check which version it's using. So we'll see if Maven is installed properly or not. And this will show us Maven, Apache Maven 3.6.2. Great. Now we have a Maven installed, and we can use Maven to compile and package our sample project. But before that, we will go ahead and make sure that Maven is available to all of the OS. So for that, we'll be using the command export, and we're using the environment variable path and setting it so that all of the OS $ will be able to use Maven, not just from this position. So the command will be export path equals $path :/opt Apache Maven, wherever your Maven is stored, and then bin, and press enter. We'll come out of the Apache Maven folder, and now we will see if Maven is compiling our project or not. I'll type Maven compile, and as you can see, it's downloading the repositories from the central server, but this is without the help of JFrog Artifactory. Let's just quit. We just wanted to see if it's compiling it or not. We don't actually need it to compile. So we clear the screen, and now we need to connect our Maven with our JFrog Artifactory. For that, let's head to the browser, and when you come to the browser, make sure you're in the dashboard, and in the dashboard, go ahead and click on lib snapshot local. Now after you click on that, click on Maven generate settings. But before you click on Maven generate settings, you need to enter your password. This is how it will be for you, and enter the password you use to enter JFrog. Okay, after you've entered the credentials, go ahead and click on generate Maven settings and set up, and leave the default configurations be, and come down and click on generate settings. And this is the XML file that will create for you. Now this is the file we will need to connect our Maven to JFrog. So let's go ahead and copy that. Or instead of doing that, we can go ahead and download the snippet and check it out in the folder, open it up with Notepad, and just Control A, Control copy. Now we have the settings. We can come back to our instance. So the place where we need to enter these details is inside the root folder. And now that we've had let's see which all folders are there inside. We'll do ls-a because this will show all the folder, even the hidden folder, and the folder we need to go inside is .m2, which is a hidden folder. So now we see that .m2 inside root folder. We'll go inside it, so cd .m2. Now we're inside .m2 folder. Now we will open the file settings.xml. Okay, since it's a new file, we'll go ahead and paste whatever content we copied from here. Okay, as you can see, we've pasted the content, and what this basically means is that Maven will be asking JFrog for the dependencies anytime it wants any dependencies. So anytime a dependency needs to be downloaded, it will be done through JFrog, and this will also connect Maven with JFrog. So the only updates we need to make over here are under username and password. Just enter the username and password that you used to get inside, that is admin and password. Now let's enter Maven compile. And now that we've made the settings, we can go ahead and try Maven compile again. And if we try Maven compile this time, we can see that it is getting the dependency using JFrog. We'll wait for it to get compiled, then I'll show it to you guys. As you can see, it's using Artifactory. It's not using Maven as for getting the dependencies. It's using Artifactory to get the dependencies. So now that we have connected Maven with our Artifactory, this will happen every time that Maven builds a project. Every time Maven builds a project, it will ask those dependencies that it scanned from the pom.xml file to the JFrog Artifactory, and JFrog Artifactory will go and get those dependencies and download them into the local server so that Maven can use those repositories to build the file. As you can see now that our Maven has been compiled our project, and we can go forward and set up the distribution system. Now to set up the distribution system, we go back to our browser and come to our JFrog dashboard. Now click on libs snapshot local again, and we'll come down and we'll copy this part of the code. It will be used to deploy the war file or the jar file, whichever artifact you have created, onto the JFrog Artifactory. So let's come back to our instance. Let's clear the screen, and we need to paste this code inside our pom.xml file. Come down. Okay, we need to paste this code after the dependencies are over. So we'll need to keep going down. A lot down. Okay, so as we can see, this is the closing tag for the dependencies. We have to paste it after this tag. And now we will type the command maven deploy. This will upload the package file onto JFrog. Press enter. And now that our build is successful, to see whether the file was uploaded or not, we'll head over to the go to JFrog, click on the Artifactory browser, home, Artifactory repository browser, and in that, under libs snapshot local, if you click on it, you can see the artifact count. If it shows you, you can see how now there is 4 MB or 40 MB in artifact count. Now if you click on lib snapshot, if you open it, you can see that there is a folder created there. That is org spring framework samples spring pet clinic. And if you will open for 4.2.5 snapshot, you can see that we have our executable over here. That is the WAR file. So with this, we know that JFrog can store artifacts that are connected with Maven and that have been deployed using Maven or any other build tool. We just use Maven in our case. If you see JCenter is where all the third-party dependencies will be stored. As you can see, this is where all the third-party dependencies are stored. Now that we've seen that JFrog can store artifact, let's see how the versioning works in JFrog. So let's come back to our instance, clear the screen. To simulate a change in the code, what we'll do is we'll go inside our pom.xml file and we will go and change the version. We will change the version from 4.2.5 to 4.2.6, and we will go ahead and write and save it, and we'll type mv deploy again. Press enter, and we can see that Maven is compiling the project again, running the test cases, compiling all the resources and all the binary code into one WAR file, then uploading it to the JFrog. But the only difference here being that we've changed the version from 4.2.5 to 4.2.6, and that change should reflect on our JFrog in the browser. Okay, now let's go and check it in our browser. Now click on lib snapshot again, open it, and open the org file. And now you can see that there's a 4.2.6 snapshot. So we have simulated a change, and now we can see that it stores the artifacts for different versions. This is for 4.2.6 Lua file, and this is for 4.2.5. Now suppose if we had an error in this application and we couldn't figure it out, or if we wanted to do a rollback, we can just easily come over here and use this file. As easy as that. No need to go back and change the commits and everything. So we've seen how JFrog works in combination with Maven, building a Java file and uploading the artifact. But JFrog can work with a lot of other build tools also. If you come and see here, if you keep on going to the side, you can see that it works with NuGet or NPM or PHP Composer or Bower and etc. So basically what we learned today in the video was that JFrog is an artifact repository, that it manages all the artifacts that have been uploaded to it, and it can have an easy rollback. And the second thing that JFrog does is it manages and downloads dependencies for your build tool. So guys, that's it for today. So what is MS Build? MS Build, as the name implies, is a build tool, which is also called Microsoft Build Engine. It is the main build tool that is used when working with the .NET framework. It is the standard tool for managing and building the source code when any Microsoft made tool is being used. Everything that is to be configured for the build is done so in an XML file. Just like how Maven works as a build tool, it's exactly how MS Build also works. What MS Build does is, it takes all the modules together, injects all the dependencies that are required, and then builds it into an executable. Then the executable, if deemed worthy, goes for deployment as an application. And because of this, MS Build is somewhat comparable to Maven. The only difference being that Maven is used for Java and MS Build is used for .NET code. MS Build comes pre-packaged with Visual Studio as its build tool. Visual Studio is very dependent on MS Build for the task of building and managing its code, though it's not the same other way around, as MS Build can be downloaded as a separate tool without needing Visual Studio. What this basically means is that whenever you download Visual Studio from the website, MS Build comes pre-packaged with it. It comes pre-bundled. You do not need to install it again. But the same is not true other way around. You can separately download MS Build without needing Visual Studio. Now let's learn what MS Build project files are. This can be useful in a scenario where Visual Studio is not involved, but we still need to compile .NET code. Then we just need to install MS Build and then compile our code. MS Build project file. What is an MS Build project file? MS Build uses an XML-based configuration file that's easy and simple to use and is extensible. So whenever you need to configure MS Build, you need to use an XML-based file, which will be easy to understand and which is also easy to use. And the extensions for it are .csproj, .vbproj, and .vcxproj. .csproj or .csproj is used for chash, and .vbproj is used for Visual Basic. Though the configuration files will be in the XML format, they will be stored as either of the above extensions, depending on what kind of language you're using. These files lets the developer configure items that have to be built and also how they would be built depending on the type of environment. Inside an MS Build project file, there are 4 different types of details that can be configured. They are properties, items, targets, and tasks. Properties. Properties helps in deciding what has to be done with the project, whether the project must be built or it must be cleaned. So if you had a project which you wanted to either build or clean, you can decide that in the element of properties. You can either go with cleaning or you can either go with building, and you'll get whatever you need. And then the next element is items. Items helps in deciding which of all the files have to be either included or excluded from the project. Only those files that have been configured to compile will be scheduled for compilation. Now suppose you had file 1 and it's been scheduled for configuration and compilation, it can go ahead to the build queue. And you have file 2, which also has been scheduled for compilation. Then it also can go ahead to the build queue. But our file 3 is not configured for compilation. So we can go ahead with only the file 1 and file 2 in our build queue. The next element is targets. Targets helps in deciding in which order the chosen files are to be compiled using MS Build. That is, it is used to decide the build order of the files. Now using targets, you can choose which file you want to execute first. Like suppose you want to execute file 1 first and file 3 second. You can decide using that over here. Tasks. Using tasks, additional jobs that are not a part of the project can be performed. These jobs can either be extra coding logic or build activity. Example, if there is a need for the creation of a new directory or deletion of an older directory, then this property will be used to do so. Now, if you want to clear out a directory before you start your build process, then you can use tasks to write an additional piece of code so that before your building starts, this directory will be cleared of any other miscellaneous properties or miscellaneous files that would have been there previously. So this is a sample XML configuration file, basically the MS-build project file. As you can see, the target here is build. This is the target that we have to acquire, that is build. And we can add comments like make a directory called outpath, which is where we will keep our executable if the condition there does not exist in outpath. So if there is not a directory with this name, only then this command will be executed. As we said earlier, inside the item group, you will include all the items that have to be compiled. So here we are only compiling hello world.cs. That's why this is the only file that has been included. And you can also mention the outpath, that is the place where your executable will be stored. And in this case, it will be stored under bin. MS-build hands-on. So the steps we have to take is first create a sample project and a sample project file, then build the project and then run the project file. Now let's go ahead and create a sample project and a sample project file. So we'll go back to our Windows Explorer. We'll go inside a C drive and we'll create a new folder. We'll name it my code. And after you name it, go inside and create a new text file. Open the text file. And this is where we will paste our sample code. So the sample code we'll be pasting is this one. Class hello world static void main if debug config console.writeline, we are in debug configuration, and if console.writeline ms build is working just fine. Take this code and come back to our text editor, we'll paste it, and then we'll go ahead and save as hello world.cs. Head to a folder and this is the file. So let's go ahead and delete this text file since we don't need it. Okay, now that we've created a sample project, let's go ahead and create a project file. So right click, create another text file, open it up, and we'll have to paste the configuration code. And this is the configuration code where the assembly name is MS-build sample, the outpath where the resulting file will be stored is bin. Then the item group to be executed is hello world.cs. This is the one we've made, and the target name is building. And if there is no directory called outpath, the condition, then it will create the directory out. So let's copy this and go ahead and paste it. Now that we have pasted our code over here, we can go and save it. Now while saving, you can give any name, but it's always preferred to have a name that is related to your project. MS-build sample.cs proj, because even though this is written in .xml format, we'll be saving it as c#project.cs proj. Okay, let's go ahead and save it. Back to our folder. Now we have our sample code and we have our build file. Let's go ahead and remove that extra text file. And now we can go ahead and execute our code. How do we go to CMD as fast as we can? There's a simple way. Just go to your navigation bar and type CMD. And CMD will open in that directory itself. It's as easy as that. And if you want to go back, you can type start and space dot. And this will open up the directory in which you are. Let's close that, and now let's go ahead and start our. Okay, now that I'm in my location, the first command I'll be typing is dir. This will give all the directories inside our current directory. It's sort of like ls in Linux. So we can see that our project build file is here and our project sample code is also here. Now let us type in the command to build this code. For that, the command is msbuild. Then the name of the project file, that is msbuild sample.cs proj space -d space not space colon and build. Okay, so before we head to build our sample project, let's go back to the file explorer. We have some changes that we have to make. So open this with Notepad and make sure that there are no spaces inside the tags. No spaces, because that will give us an error. Save it, close, open hello world, and make sure to add using system, because we'll need console to run these commands, right line, and for that we'll need using system. So make sure you have this command using system, semicolon, and save it. Then we'll come back to our console and then we'll press enter. Then we'll press enter. And as we can see that our project file has been built without any warnings or errors. Done building the project at the target. And if you come back to your folder, you can see there's a bin folder created over here. Since we had put a condition that if there is no out path, then create that directory. So now we have bin and you have ms build sample. Now if you type dir again, you can see that there's a new directory created, that is the bin directory. And if you go inside bin, you can see that there is a .exe file created. That is your build file. Now you can go ahead and execute this. Simply write the name and .exe and press enter. And now you can see that ms build is working just fine. Okay, now that we have our output, now let's see what we did hands-on again. Let's just go through it again. First we created our sample project, and then we created a sample project file, that is sample ms project file, ms build, and we ran that file using ms build command. We built the file and then we ran the executable. Now if we wanted to actually work with this, we will be integrating this into our Jenkins. So that's how we would work with it.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What are the key components of DevOps? A. Continuous integration. B. Continuous testing. C. Continuous delivery and monitoring. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Let's understand what an artifact actually is. The files that contain both the compiled code and the resources that are used to compile them are known as artifacts. Basically, whenever a developer writes his source code, he gives it to a build tool so that the build tool can compile that source code into binary code. This is because whenever a developer writes source code, he writes it in the language that humans can understand, a human language. But machines can't understand that language. To make it understandable for machines, the build tool compiles it so that it's converted into a binary code, that is ones and zeros, that can be easily understood by machines. When these binary codes are taken together with the dependencies and resources that are required to run it and put together into one file or packaged into one file, that one file is known as an artifact. Basically, these are readily deployable files, like an executable. In Java, an artifact would be a .jar file, or a .var file, or a .ear file. .jar files are basic Java applications, and .var files are for web applications, and .ear files are for enterprise applications that can be contained in EGB containers. In NPM, the artifact file would be a .tar.gz file, and in .NET, the artifact file would be a .dll file. Now let's see what an artifact repository is. An artifact repository is a repository which can store multiple different versions of artifacts. Each time the var file or tar.gz file is created, it is stored in a server dedicated for the artifacts. Suppose you have compiled your source code and you have taken all the resources and dependencies with that source code and packaged into one artifact. This will be your application. After you create your artifact for the version 1, you store it in your artifact repository. And if the artifact is deemed worthy, it can go ahead for deployment. And then later when you create a version 2 for the same thing, you can go ahead with the deployment again. And same with the version 3 where you can go with the deployment again. An artifact repository will store all these artifacts so that we can use them whenever we want. Now suppose in a case where artifact 3 or artifact version 3 has an error after deployment. So we need to do a rollback now. Now, unlike the normal method where we have to go back to our VCS, example git, and then remove latest commit and go back to the previous commit and then compile the whole code again, what we can do in this case is that we can just roll back the artifact itself. We don't have to compile it again. We don't have to build all the files again. We just have to pull the artifact or pull the deployment file back and then just launch the previous artifact. Guys, now that we have understood what an artifact is and what an Artifactory repository is, we can go ahead and see what a Nexus repository is. Nexus repository is a tool used in DevOps methodology for multiple purposes. One of its main purpose is to store artifacts that are readily deployable code, which we learned before, that have been created in the code pipeline. Another one of its purpose is to act as a sort of buffer for downloading dependencies for the build tool and languages. Basically, Nexus is a repository manager. It's an artifact repository manager. It does what a normal artifact repository would do. It stores artifacts and then it deploys them based on need. Now, it also has one more feature where it manages and downloads dependencies for the build tool. Like how we learned about Maven, where Maven downloads and manages the dependencies. If we use a Nexus repository, in this case, Nexus would be connected to a build tool and it would understand the needs and requirements through the build tool. In this case, the build tool won't be managing and downloading the dependencies. Here, Nexus repository manager would be doing that. And since it performs so many tasks, it is very easily integrated into the code pipeline. First, your code will be created in your version control, and then it will be sent to the build tool for being converted into a source code, for being converted into binary code, and then it will be compiled with the dependencies which are gotten from the Nexus repository manager and compiled into one big artifact, which will be again stored in the Nexus. And it is also connected to the continuous integration tool, which could be your TeamCity or Jenkins or Bamboo, depending on what your company is using. And it also connects to the containers and the deployment tool so that it can easily deploy the artifacts that have been stored in the Nexus. What are the Nexus repository responsibilities? Like we learned earlier, first, it helps in storing readily deployable code, which are the artifacts. What are the Nexus repository's responsibilities? Like we looked earlier, the first responsibility is it helps in storing readily deployable code. That is your artifact. If you have created an artifact for your version 1 of your application, you go ahead and push it to your Nexus repository. And if it is deemed worthy, then it can go ahead for deployment. And same with the version 2 of the artifact. You can go ahead for deployment, and same with artifact version 3, we can go for deployment. Now, in case there needs to be a rollback, it's as easy as pulling the version 3 back and pushing the version 2 of the artifact for deployment.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
It is not the same as a version control system for source code, where the latest code is always replaced by the next code. Whereas in a Nexus or in an artifact repository, artifacts are always stored, they're not replaced. So there's no overriding done over here. So the next responsibility of Nexus is it helps in downloading and managing dependencies. Now, after your build tool reads through the configuration file, that is your configuration file for building your source code, it understands what the dependencies are, and then it tells those requirements to the Nexus. It asks the Nexus for dependencies. Nexus reads them, it goes to the remote repository and gets those dependencies. And it stores them inside a local server so that it can be used by the build tool to build the source code. Now that we've understood what Nexus repository is, we can go ahead and see what are the features of Nexus repository. Altation crowd support, staging and build promotion, tagging, and user token support. Now let's see all of them one by one. Altation crowd support. Nexus provides support for Altation Crowd, which is a security software that is used to manage and track user accounts and application accesses. It comes inbuilt with Nexus Repository Management Pro and can be easily configured according to an organization's needs. Basically, whenever you need to manage a lot of artifacts, you're handling a lot of sensitive data. You're handling the asset of a company. So if there is ever an error or there's a conflict in future, you need to keep track of who made that mistake or who was the person who pushed that code or deployed that code or deployed that artifact, etc. So for that, Nexus has third-party software called Altation Crowd Support that is built into it, which helps in managing and tracking all of these things. Staging and build promotion. Nexus provides a staging feature that can be easily integrated with an organization's software development lifecycle. It helps in staging all the release candidates that are the components of the software that are tested meticulously before being isolated for release onto production stage. So what this basically means is that Nexus provides us a platform where we can have candidates, and these candidates are then tested meticulously before they're isolated for a release onto the production stage. That is, before they're sent for actual production and actual deployment as an application. So it allows us to keep multiple candidates instead of just having one candidate. So you can manage different projects and have different artifacts for different applications on one stage before they're isolated for deployment. Since the feature allows for multiple candidates to be staged at the same time, then based on requirements, the candidates can be discarded or promoted. Once all these different candidates for the applications are pushed to the platform, they can be discarded. That means they can be removed if they don't meet the requirements of that application. Or they could be promoted. If they meet all the requirements, then it's all good and they can be sent for deployment as the application. Nexus provides the ability to tag components so they can be associated with each other. The usage of this feature is entirely up to the user, as it has no specific use case, but it's mostly used in life cycles to keep track of different builds or for differentiating between multiple projects during mergers. What this basically means is that Nexus gives us the ability to tag different components of a particular application so that they can be associated with each other. But what is being said is that this feature is mostly used for keeping track of different builds or different projects during mergers. Suppose you have different projects which are now to be merged into a single big project. So to keep track of that, we need to use the tagging feature. Or if you have different builds on the same platform, you need to make sure which build is associated with which build, or which build is going to be pushed for deployment next. So for that reason, Nexus provides us with the ability of tagging. For example, a release manager provides approval for a test phase and promotion phase, and only then will they be sent to the Nexus manager to be stored. User token support. Nexus uses a two-part token system to overcome the limited security of the build tools and removes the need to store sensitive information in text format. What this basically means is that whenever you connect your Maven to your Nexus, you're storing essential information, like you're storing your username, you're storing your password inside a settings.xml file, because you need this file to connect your build tool to your Nexus. Example of Maven, you'll be storing the username and the password that you need to use to connect to Nexus inside a text file. And it is written in plain text, which is a security liability. If anyone acquires this file, they can know what your password and your username is and cause a lot of trouble. So to avoid such a problem, Nexus uses the feature of two-part token system, which eliminates the need of having credentials at all. Basically, whoever has the tokens can access Nexus. There are some other features also for Nexus, like high availability, repository health check, enterprise support, and group blob stores. High availability. Nexus has a feature called high availability clustering that keeps multiple redundant nodes inside the data center to increase the availability of the artifacts and dependencies in case any one of the node crashes or becomes unavailable due to some reason. So what this basically means is that whenever Nexus stores any artifacts, it does so in a high availability clustering. That means it stores it on multiple nodes. In case one of those nodes crashes or becomes unavailable due to some reason, then you can still access those artifacts using one of the other nodes. Now this is very important in case you need to run your artifacts, in case you need to deploy artifacts, and you don't have the availability, then it's a big problem. You have a deadline and you have to finish it, but you can't because your node's down. In case of Nexus, there are multiple nodes, so that if one node crashes, you can still use other nodes. Repository health check. Nexus can recognize security risks in the code at an early stage. The features that it uses for the particular purpose does mainly three things. First, it provides guidance on what has to be upgraded and what has to be reworked and replaced. Basically, repository health check tells you what component of your code is old and needs to be upgraded. Otherwise, there might be a security risk, or it might not be very efficient and it might slow down your whole process. So repository health check tells you about it. This is the feature of Nexus. The second thing it does is it lists down components of the software based on their susceptibility, and also lists the number of times the component has been downloaded. Basically, it lists all the components down in a rank-based system where the highest ranked component would be the one that is most vulnerable, and it also lists the number of times each component has been downloaded. So the third thing it does is it gives monthly summarized reports on the health of the code pipeline, revealing any dangerous trends or vulnerabilities. Basically what it does is it goes through your code pipeline and it lets you know at the end of every month with a summarized report whether there is an issue with the code pipeline or not, whether there are any vulnerabilities, and whether it is inefficient or not. Enterprise support. Nexus also provides a full-time support of a skill team focused on resolving issues. Now, when you're working with open source softwares, you don't have any guarantee when you have errors. Suppose you're using an open source software and you have deployed your application, but now it crashes and you have to figure out what the error is. And when you read the error and you can't solve it, there's no one you can depend on. But since you will be paying for Nexus Pro, you can have an assurance that there is a full-time support team that will help you resolve those issues. That's another feature of Nexus Pro. Group blob stores. Nexus provides a group blob store, which is a combination of multiple blob stores acting as one. Fill policies are used to select which blob store is used, and this allows users to have a choice in choosing and using their storage. Basically, whenever you download any binary assets via proxy repository or publish to hosted repository, they are stored in blob stores. Blob stores basically store any binary asset that you might need to use. When you have different blob stores, what Nexus does is it groups all of those blob stores into a singular blob store. That helps in accessing any binary asset that you may need. Now, fill policies are basically execution policy. That means an order can be executed only in a specific volume. If you want to execute order in one particular volume, then you can use a fill policy to execute that. Basically, fill policies are used to select which blob store is used, and this allows users to have a choice in choosing and using their storage. Now let's see what are the difference between Nexus repository and a JFrog Artifactory. So the first difference is Nexus uses a file system for storage and Artifactory uses a Derby database for storage by default. But in Artifactory, you can change that setting. Nexus cannot generate and save a settings.xml file, whereas in Artifactory, you can generate and save a settings.xml file. In Nexus, you would have to do that manually, whereas in Artifactory, it helps you do it. Nexus is limited in replicating repositories, whereas Artifactory can easily replicate your repositories to other Artifactory instances. So basically what is being said is that Artifactory can much more seamlessly replicate any repository that you may need to use and then store it in an Artifactory instance, whereas Nexus cannot do the same thing. Nexus has limited build time when it builds an artifact, whereas Artifactory has a faster build time. So it can access all its artifactories much more faster than a Nexus can. Now you still may be wondering why to use Nexus instead of Artifactory. Now that I've told you that Artifactory can be much better in certain scenarios. But the thing is, certain companies may need Nexus because they may have been using Nexus for a long time. And now that they have been using it for such a long time, it would be very hard to migrate from using one tool to another tool. And they may also be using certain other tools in conjunction with Nexus, which requires Nexus to be run. In that case, you would need to use Nexus. Now that we've understood what an artifact is and what an artifact repository is, and then we understood what Nexus repository is as a tool, we can go ahead and see the installation for Nexus. So the prerequisites for installing Nexus are having OpenJDK and having 2 GB of RAM and 15 GB of hard drive space. These are the at least requirements. For this, we'll have to open a marketplace CentOS again and launch a T2.medium. So let's go ahead and do it. But also in the end, it totally depends on your preference. Maybe you are more comfortable with using Nexus, or maybe you're more comfortable with using Artifactory. And there is no harm in knowing how both work. So guys, now that we have understood what an artifact is and what an artifact repository is, and consequently understanding what Nexus repository is, we can go ahead with the installation for it. Now let's look at what the prerequisites we need before we can go with the installation. So the prerequisites are have OpenJDK, that's Java, and second is have 2 GB of RAM and 15 GB of hard drive space. So for this reason, we will go ahead and launch a marketplace CentOS instance. So let's head to our browser and come to our EC2 dashboard and click on launch instance. We'll go to our AWS marketplace, type in CentOS, click on the first AMI we get, continue. We need t2.medium, so we'll click over here, configure some details. We'll add storage of at least 20 gigs. Since we need 15, we'll go ahead and write 20 over here. We'll add a security rule, all TCP links, and source anywhere. Go ahead and launch it. Acknowledge, launch instance. If you go view your instances, it will be initializing. But since I've already created one before, I can go ahead and launch this one. I use my putty tool for that. Paste my IP address, go to the appearance, make it 16. Colors, default background, make it green, okay. Connection, seconds between keep alive, 180. Authorization for my key, and then open. So it will ask for login as. I will type CentOS. Let's go full screen, clear the screen. Sudo su, so we don't have to keep typing sudo every time. And we'll go ahead and install Java. That is, the command for that is yum install Java 1.8.0 open JDK dev. Yes. Okay, now that we've installed Java, clear the screen. We have all our particulars that we need, all our prerequisites. We have Java installed and we have an instance with at least 2 GB of RAM and at least 15 GB of space. So we can go ahead with the installation of Nexus repository. Now there are two ways we can go with this. We can go either directly to their website and download the file from there, or we can use Docker to launch a container with Nexus in it. Since launching Docker instance is much more easier, we're just gonna use Docker. So let's go ahead and install Docker. For that, we will need to install some packages. For CentOS, there is a particular step. There are particular steps that we need to follow while installing Docker. So let's go ahead and see what are the steps. So first, we need to install the required packages. So for that, I'm going to copy this command, yum install -y yum utilist device mapper persistent data lvm2. Come back here and paste the command and press enter. Now the next command is to set up a stable repository. I'm going to copy this command, come back here, paste the command, and it will say that repo is saved. And finally, we'll come back and we'll use this command. That is, clear the screen, yum install docker ce client and container.io. This will install our Docker. So let's go ahead and click on enter. Yes, please. Now that we've installed a Docker, let's make sure it is installed. For that, the command is systemctl status docker. This would tell us that Docker is loaded, but it is inactive. So let's go ahead and make it active. So for that, we'll type systemctl start docker. And if we see the status again, it will show us that it is active and running. Now that we have Docker running, we can go ahead and pull the image for Nexus. So for that, the command is docker pull sonatype /nexus. Now we'll press enter. It will start pulling the image for Nexus 3 and save it in your instance. And after it's done that, you can check for it using the command docker images. So we have our image sonatype nexus pulled. Now let's go ahead and run the container so that we can launch the application. So for that, the command is docker run -d -p. We will run the application at 8081 port 8081. The name we'll put for it is Nexus itself, and we'll copy the image ID and press enter. Now we launch the Docker container. So type docker ps to cr container. Now we can see that the container is running at 8081 and it's launched Nexus. So now let's go ahead and access it using our web browser. Go to our web browser, copy the IP address of the instance you're using. Go ahead and paste it. Type the port number, that is 8081, after 1 colon, and press enter. This should start your Nexus repository manager, and after it's started, you can see the dashboard for it. That is get started, repository formats, GitHub Actions, software composition analysis, etc. Let's go ahead and set up the admin. But before that, we have now completed our installation for Nexus repository. So we can move on with the practice, that is hands-on for Nexus repository. So let's see what are the steps we have to take. Nexus repository hands-on. So the steps we have to take are: the first step, run Nexus repository and set up the admin. Second, install the Git to get the sample code. And third, install Maven to compile and package the sample code. And fourth, connect Maven to Nexus. And fifth, check how the artifact versioning works in Nexus. So the first step, that is run Nexus repository, we have completed that. And after that, we have to set up the admin. So let's go ahead and set up the admin. So you come over here, click on sign in, and we'll ask for your username and password. So the username will be admin itself, but the password is located in Nexus data admin.password. Now this says that it will be located on the server that you're using, but since we used a Docker container, it will be inside our Docker container. So let's go back to our instance and let's go inside our Docker container. So for that, the command would be docker exec -it, the container ID of the container, and bash. Enter. And if you type ls, you can see that Nexus data is there inside our container. So let's go inside it. Nexus, since that's where our password is stored. Okay, inside Nexus data, if you type this, you can see that admin.password is here. So type cat admin.password. And this is the generated password that we will be using. So just copy it, come back to your browser, paste it as the password, and sign it. And then the setup wizard will come up. Click on next, and it will ask you for a new password so that you don't have to keep on typing that long hexadecimal password. Then we click on next, and we'll ask you to configure an anonymous access. If you want to, you can go ahead, but it's not advisable to do it as it allows unauthenticated downloads and browsing. So let's go ahead and click on next and complete finish. Now that we have set up our admin, we can go ahead with the next step, that is to install Git and get the sample code. Now before we go ahead and get our code, let's go back to our browser and let's familiarize ourselves with the software a little bit. Now if you'll see a gear icon over here, click on that. It will have server administration and configuration, and you can see that you have all your repositories over here, the public repository, and this is where your artifacts will be stored. You can go ahead and create a repository if you want. Then you have your blob stores where your binary assets, the ones you want, you can access them here. And then you have your security details, like what roles you want to set, what users you want to give access to, and etc. You can come over here and see support tools, and then there are system tools and etc. That's it for familiarizing. Let's go ahead and install our sample project. For that, we'll come back to our instance, come out of the container and clear the screen. And we'll need to access the repository from our GitHub. So we'll go ahead and so the project we'll need is in this link, https://github.com/ sample Maven project. Copy this link, come back to our browser and paste it. So this is the one we'll need. Go ahead and click on clone download, copy the URL, come back to your instance, cd into opt, and type git clone and the link. If you ls, you can see that your sample Maven project has been installed. Now to compile this, that is the next step, we'll need to compile and package this. For that, we'll need Apache Maven. So if you remember the process for that, we have to go back to our web browser, we'll close this, and type Apache Maven. We need to get the tar.gz link for this. This is the first link over here. Copy the link address, come back to your instance. Let's first install wget. So for that, yum install -y wget. Install wget for us, clear the screen, use the command wget and paste the link address of Apache Maven and press enter. And after your Apache Maven tar file has been downloaded, go ahead and untar it using the command tar zxf Apache Maven. Now if we see, we have a folder Apache Maven, it's installed, so we can go inside it and we can go inside the bin folder clear the screen. So if we type Maven version, we can see if it's downloaded properly or not. Yes, it is. Now Apache Maven is only available from this position in this directory, so we need to make sure that it's available to all of the OS. So for that, we'll need to type export, and we'll need to use an environment variable that is path, and we'll set this path so that Apache Maven can be set in such a way that it can be accessed from all over the OS. So the command for that is export path equal $path : /opt/ / Apache Maven, wherever your Apache Maven is, and bin. Press enter. Okay, now we're done with that. Okay, now that we're done with installing Maven, we can go ahead and configure our Maven so that it can be connected to our Nexus. So let's come out of the bin folder. Let's come out of the Maven folder. We'll have to create a new settings.xml file, like how we did in JFrog Artifactory. For that purpose, what we're gonna do is we're gonna find out what our home directory is. For that, we need to check which kind of user we logged in as. To check that, the command is id, and it will show you root over here. And if you want, you can just look at this part. That also tells you which user you logged in as. But you can type id and you can get more detailed answer. We are inside this instance as a root user. We can go ahead and go to the root folder. This is the folder we need to go to, where we will create a folder, a directory called .m2. It's a hidden directory. Since it says that .m2 file already exists, if we type ls minus, if we type ls, we can't see it. But if we type ls minus a, we can see .m2, since it's a hidden directory. Now let's go inside .m2. Inside .m2, we will create text file called settings.xml. So I'm going to use nano settings.xml. If you do not have nano, you can go ahead and type v, or you can just install nano using yum install nano. So nano settings.xml, if I go inside, it says it's a new file. And here is where we're going to put our configurations for setting up Maven with Nexus repository. So let me take out the command for that. These are the commands. These are the configurations. We'll set our ID to Nexus, put a username and password, whichever we have set over here, and we'll create a mirror to get our dependencies, to download dependencies using Nexus. So let's just copy this, come back and paste. Now make sure the URL you're using is the one with your IP address with 8081 repository and Maven public. If you want this, you can go ahead to your browser, click on the settings button, come to repositories, and this is your Maven public. You can copy the link for this. That is this one if you want, or you can just look from here. And make sure that your username and password are the same as the ones you entered while you were setting up the admin. Now we've made these configurations, we can go ahead and exit out of here. We'll save it using Control O, enter, Control X. Now let's clear the screen. And now let's go back to our OPT folder where we have saved our sample project. Let's go inside our sample project. And inside our sample project, we have a pond.xml file. We'll open the pond.xml file right now. Now that we have set Maven to be connected to Nexus, we need to make sure that the artifacts that are produced from Maven will be uploaded to Nexus. The first thing we did in settings.xml was connecting Maven to our Nexus. But in this, we're going to make the settings such that Maven uploads the artifacts that are produced after packaging the sample project, after reading through the code, onto the Nexus. So Nexus can act as an artifact repository. In settings.xml, what we did was we connected our Maven to Nexus. So in that case, we were making Nexus the dependency manager and the one that downloaded the dependencies. So let's go inside nanopom.xml. And if you come down after dependencies, you'll find this folder. You'll find these configurations, distribution management, repository, central, and all these details. So the ones we need to enter are different than these. So let's remove this. Now that we remove them, we can go ahead and copy our repositories that we'll need to connect. That are the Maven releases. We will store our released Maven artifacts, and Maven snapshot. We'll just store the snapshot artifacts. Let's go ahead and copy these and come back and paste them.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the cloud platform are not used for DevOps implementation? A. Google Cloud, B. IBM, C. Microsoft Azure, D. Amazon Web Services. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
Now go ahead, Control O, enter, Control X to exit. Now we have a pom.xml file also configured, and we have a settings.xml file also configured. Now we can go ahead and see if it works or not using this command, mvn compile. As you can see, it's using Nexus to download the dependencies it needs instead of using Maven directly. Now if you want a different directory you want to access, you can use whichever you want. You can use NuGet group also, NuGet hosted also, and etc. We come back, we'll wait for this to download all the dependencies and compile the project. Now that we can see that the build is successful and the project is successfully compiled. Great, let's go ahead and clear the screen. Okay, now that we've compiled our project, now we can go ahead to the browser and see where the dependencies have been downloaded. If you go back to our browser, we are under settings. If we go back to browse server contents, click on browse, we will see a Maven public. That is the main repository. If we click on it, you can see that there are many dependencies that have been downloaded, like the JUnit, the one we needed, or log4j, and you have Apache, Sonatype, and Codehouse, and etc. So if you want to see which all dependencies you've downloaded and where, you can go ahead and click on browse and go under Maven public. Now that we've seen how Maven, when connected to Nexus downloads the repositories and manages it for Maven, we can go ahead and see how Nexus gets the artifacts. That is how Maven deploys and uploads the artifacts onto. Now before that, let me just show you one more thing. When you go back inside pom.xml file, you see that the version we are doing is 1.1 release. The difference between a normal release and a snapshot would be, whenever you mention this as snapshot, that means whenever you run the build using this pom.xml file, every time you build it, the same version gets updated on your Nexus. The same version would be updated. But if you make it release, each artifact would be stored separately. So sometimes if you just want to test something, you can go ahead and type a snapshot and you keep on testing that same release again and again. But if you want to make it a proper release, then go ahead and write over here release. And if you come down in the distribution management, this is where we will the links we will use to deploy our artifacts onto Nexus. We have typed the first repository as Maven releases. So every Maven release will be stored in libs release local. That every release that we deploy or every release that we send to Nexus. And in snapshot repository, only the snapshots, only the builds that we have created as snapshots, we have made them as snapshots, will be uploaded over here. All right, let me go back, clear the screen, and now let's go ahead and deploy our artifact. So see how it works. Okay, before this, there is one thing you have to make sure. Go inside your pom.xml file and go and make sure that the repository IDs that you're using are the same as the ones that you have put in your settings.xml file. In your settings.xml file, when you're writing the server, when you're writing under the server, the server ID is Nexus, the one we use. If you do not mention your ID over here as Nexus again, then you will get an error 401. So to avoid that, make sure that the ID you've been entering for the repositories is the same as the ID you entered for the server. Now let's come out, Control X, and we will use the command mvn deploy. They should download all the dependencies for your project, run the test cases, make the packages, and after it's done making the packages, and it should upload the artifact onto your Nexus. If we go to our Nexus on our web browser, and if we come under browse and look under Maven releases, since the version we entered was with a release instead of a snapshot. So if we come under release, then we can see that there is a new folder that is Flipkart offers and 1.1 release. If we want to simulate a change, we can go ahead, come back to our Maven project, open the pom.xml file, and inside then we can go ahead and make the version change. This will simulate a change that we have made in a project. Let's go ahead and save it. Control O, enter, Control X, clear the screen, use Maven deploy again. Now, if we go back to our browser, click under Maven releases again, you will see that there are two packages. There is 1.1 release and 1.2 release. We can go ahead and do the same thing with snapshot. If we go inside our pom.xml file again, and if we go ahead and make it from 1.2 release to 1.2 snapshot, and make sure that snapshot is in all capitals, and make sure that the URL you're using is the exact correct one. So we will go ahead and save this and exit, clear the screen, type mvn deploy, enter, and it will go ahead and deploy the snapshot artifact onto our Nexus. So if we come here, refresh, click on mvn snapshot, Maven snapshots, and you can see under Flipkart offers, there's 1.2 snapshot. So guys, we have correctly learned how to use Nexus. We have familiarized ourselves with Nexus. Now we know how to connect our Maven to the Nexus, and we know how to upload our artifacts from Maven to Nexus. And we also know that Nexus now acts as a dependency downloading manager for Maven. So let's go ahead and understand what Node.js is and what its relationship is with NPM. Node.js is an open source server-side platform that has been built on Google Chrome's V8 JavaScript engine. It is used for developing server-side and networking applications. All Node.js applications are written in JavaScript, can be run within the Node.js runtime on OS X, Microsoft, and Linux. Now what this basically means is that whenever you're loading a website on different browsers like Chrome or Firefox or Opera or Safari, whichever you want, it loads differently in each browser. Now the reason behind that is because each browser has its own rendering engine. Safari will have its own rendering engine, Opera will have its own rendering engine, Firefox will have its own thing, and even Google Chrome has its own thing. And the engine that Google Chrome uses is V8 JavaScript engine. And when Node.js was being conceptualized, it was decided that it would be based on Google Chrome's V8 JavaScript engine. And another thing that we understand here is that there's an advantage in using Node.js, because Node.js can be written independent of platform. Any code written anywhere can be run on any OS, be it OS X, be it Microsoft, be it Linux. You can run it anywhere. Node.js runs based on events and has a non-blocking model, which makes it seamless and lightweight, which is perfect for data-intensive real-time applications that run across distributed devices. What happens when a request is sent using Node.js? So whenever a user sends a request for an intensive operation that needs to be performed, an event loop is formed. And in this event loop, there is only a single thread, which is because JavaScript is a single-threaded and an asynchronous language. In this case, it guarantees us that while we use Node, the event loop is not blocked by a synchronous function, which means that if there are multiple requests, then those multiple requests would not be blocked for the first request that was asked. First request would be performed, then according to the first request, a response will be availed and it will trigger a callback back to the user, giving him all the details of the response or the results of the operation that he requested. But in this whole process, user 2's request will not be blocked. It will also go to the event loop. Being an asynchronous language means that it can handle multiple requests at a single time. How does Node.js work? One of the most common tasks for a web server can be to open a file on the server and return the content to the client. Now take an example. I need to get a contractor's details from his page. So the moment I hit the server to take the content, the server will take the content and then deliver it to my page. It will give it to me. So how does that work? How does it work with Node.js and how does it work with other platforms? Now, if we can use either PHP, Ruby on Rails, or ASP, or we can use Node.js. Now let's see how these different platforms work. Now let's see how either one of them handles this task of sending and receiving a file. First, it sends the task to the computer's file system. Second, it waits while the file system opens and reads the file. Third, then the content is returned to the client. Fourth, then it becomes ready to handle the next request. So what basically happens is a user would send his request to the local system, and then he will wait for the file to be read. And after it's been read, then the file will be returned and its contents will be shown to the user. And only then a second request can be sent to the system for another task. But now let's see how it happens in Node.js. First, it sends the task to the computer's file system. Second, it waits while the file system opens and reads this file. Third, it's already ready to handle the next request. Fourth, when the file system has finished input-output operations, the server returns the content to the client. The user would first send his first request to the file where it would be processed, and while that is happening, a second request can be sent. There is no need for a second request to be waited in an event loop while the first request is processing. Using Node.js, we can handle simultaneous requests while the processing of the first task or whichever task at the moment is happening. So suppose I sent my first request and it is processing, and then I send my second request while my first request was processing. I can do this in the case of Node.js, but in the previous case with PHP or .asp or Ruby on Rails, I could not do this. So while my first task is being processed, I have sent my second request. And after the process has been completed, a response is sent back to me. And then the second task starts to execute. This is how Node.js works. Node.js eliminates the waiting and simply continues with the next request. Node.js runs single-threaded, non-blocking, asynchronously programming, which is very memory efficient. There will not be an I/O waiting with Node.js. Therefore, it can handle a lot of requests on a server with high ease compared to traditional server languages. Node.js can handle memory-intensive apps, but it can't handle CPU-intensive apps. Now we understand that Node.js can handle those apps which are memory intensive, that requires some more memory, but it cannot handle those apps which need a lot of CPU power, a lot of processing power. Let us see what is NPM, or Node Package Manager. Originally, NPM was intended as a server environment for applications, but developers started using it to create small tools to aid them in local task automation. And since then, a whole new ecosystem of node-based tools such as Grunt, Gulp, or Webpack have evolved to transform the face of front-end development. Now, tools similar to these are now dubbed as packages, and NPM is used to register and store these packages. NPM is a package manager that is used for JavaScript programming languages. Node.js uses NPM as its default package managing system. It hosts the world's largest collection of software packages. All of these packages are hosted on site npmjs.com website. Suppose you were writing a code and you needed to use some kind of library or some kind of dependency. Where would you get that? Especially for JavaScript. If you were working with JavaScript as a programming language, you would first install Node, and after you're done installing Node, NPM would be installed with it. So you would ask NPM for those packages that you need. To get those packages, you will create a file called package.json, which will be scanned by NPM to see which all packages have to be downloaded. And according to what has been written in package.json, NPM will get those packages from remote repositories or from online and then store them inside the local system so that it can be used by your code, or it can be used in further application in future. So what NPM basically does is it manages all the tools and packages that we need or that are stored so that we can easily access all of those packages. So if you wish to use a package for your code, then you could use NPM and it would install the package for you, and it will give you a useful interface to work with them. You can even create your own packages and store them using NPM. Basically, NPM is kind of like Maven, but NPM provides many more features. What is a package? In context with NPM, a package is a file or a directory that is described by package.json file. It must contain a package.json file in order to be published to NPM registry. Now, if you took your code and you gave it to NPM and you asked it to store it as a package so that one of your colleagues or anyone in the world can use it, So NPM will take your source code and it will take all the dependencies that source code needs to run, and it will package it into a single package, and then will store it inside its repository so that anyone from anywhere can access it. A package in context to NPM contains any of the following: a folder containing a program described by package.json file. Basically, a folder that contains a package.json file here is a description of what all dependencies or packages are needed. NPM will define any folder that has a package.json file inside it as a package, or it can define a gzipped tarball containing the folder with package.json file. So basically the same thing as before, but right now it's inside a .tar.gz file. Package.json. All NPM packages are defined in files called package.json. The content of package.json must be written in JSON. At least two fields must be present in the definition file, that is name and version. Now let's understand what we went through just now. We understood that there is a need for something called a package.json file. Now, why do we need this? Imagine you're working as an individual on some piece of code and you think of something that you think that no one else has thought. You come up with a new algorithm or something. Now you want this algorithm to be available to your colleagues or to your friends or to anyone in the country or in the world. So you want it to be stored as a package in NPM's storage. To do that, what you would first do is you would create a directory, you would store your code inside that directory, and then you would write a descriptive file. What would this descriptive file be called? It would be called package.json. And inside that file, there were many things that you would explain about your project. You would write the name of the package, you would write the description about it, a version, what kind of scripts you'll be using inside it, what kind of repository it's targeting, keywords, your author name and the licenses you're using or any known bugs, etc. Inside this package.json file, you will write all the important metadata that is important. Now suppose for this algorithm that you've written, you need more packages, you need more libraries. You will write those dependencies or those requirements of those libraries inside this package.json file. And we will see how to do this inside our practice session. Now I hope you guys have understood what package.json is and what is NPM used for in the case with Node.js, which is basically you use Node.js as a platform to write your JavaScript code, and inside that platform you will be using a package manager, that is NPM, to gather all the packages you need and then use these packages you've gathered for your JavaScript code on the Node.js platform and then deploy your application or your package. Guys, now that we have understood what Node.js is and what NPM is, we can go ahead with the installation for NPM. Now let's look at what are the prerequisites for installing Node.js and NPM. So the only prerequisite here is node source yum repository. So what this basically means is that when we launch our CentOS instance, the yum package installer will not have the repository or the location of the repository from where we will be installing Node from. To get Node, we will need to give another location to yum so it can go ahead and install it from that location. Now let's see how we will do this on AWS instance. I will go ahead and launch my AWS instance. Let's go to a browser. We'll come to our EC2 dashboard, click on launch instance, and we will be launching an instance that is quite normal. We do not need a high performance instance this time because the tool we're using is very light. We do not need 4 GBs of RAM or a lot of space, but we still need to use the marketplace CentOS.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Go to AWS Marketplace and launch the CentOS 7. So we will be using CentOS 7 as our instance. Go ahead and click on select, continue. T2.micro is fine. We do not need T2.medium in this case. Let's go ahead and configure our details. We'll leave it such as, 8 GB is fine. We'll configure a security group. Let's add SSH, all TCP. I'll add a rule, all TCP, anywhere. Review and launch. Launch. and use the existing key pair, the one we always use. Acknowledge and launch the instance. Go ahead and view your instances. Now it will take some time to set up. Make sure it's properly set up and then launch your PuTTY or SSH to log in into this instance. Now while it's loading, I'm going to set up my PuTTY. I'm going to copy the IP address, come back, paste it, make it a little larger, the font, give it a bold green color. Make sure the seconds between keep alive are 180 so that it doesn't die off if we don't use it for a long time. Tell it the path to the private key file. And now we will wait for this to set up and initialize. Go ahead and click on open. It will ask us this. We'll click on yes. We will log in as the user sent to us. Press enter. Full screen. Go full screen. Alright. Now the first thing we would need to do is we would need to give it the location of the repository from where yum can go and get the node from. So for that the command is curl -s capital L space https://rpm dot node source dot com /setup underscore 10 dot x space sudo minus capital E bash and dash, and then press enter. Okay, now that we've given yum the location, we can go ahead and use this command to install our Node.js. Okay, before we install Node.js, we know that Node.js is written in C++. So if we wish to compile any of our programs, we will need to make use of C++ compiler, GCC C++. So first let's go ahead and install that. So for that we will do sudo space yum install -y for yes prompt, then GCC C++ make. This should install the C++ compiler for us so that if we wish to compile any of our Node.js written code, we can use this. In case you're a pure developer, you wouldn't need to install the C++ compiler for Node.js. But we will be compiling and performing other operations, and hence we need it. Now let's go ahead and get our command for installing Node.js. It was this sudo yum install -y Node.js. Alright, and go ahead, paste it. Click enter. As you can see, now it can install Node for us. If we hadn't added the repository location for our yum, then we wouldn't have been able to do this. Let's clear the screen. Okay, so basically what happened there was the command added a new location to which yum can go to and get packages from. Let's make sure we install Node. So we'll type which node for that. Yeah, it will show that it's been installed in user bin node. Okay, great. Now let's see which version of node we have installed. Node. For that the command is node -- version. So we will install 10.17.0 version of Node.js. Now let's test it out a little bit. So we will go inside the node command console and we will type a small sample command line. So type console.log parenthesis quotation welcome to node. Close the quotation, close the parentheses, add a semicolon and press enter. As you can see, it prints welcome to node over here. Now to exit this console mode, all we have to type is .exit. And to see if we need to use any other commands, you can always go and type .help. This will give us some commands that we can use inside the console mode. Right now we'll just exit .exit. Okay, let's clear the screen. Alright, so when we installed our node, we installed npm with it. Whenever you install node, it always comes pre-installed with an npm. If we type npm version, we can see that it says 6.11.3. That means our npm was installed with our node. Now we can update our npm independent of Node.js. For that, the command is npm update -g. Now this will update the npm independent of our node. Sorry, I forgot to type sudo npm update -g. As you can see, it's updated to 6.12.1 instead of the older version. It added 3 packages from 2 contributors and removed 3 packages and updated 17 packages. Now that we have updated our npm package, we'll go ahead and clear the screen. And now we have finished with our installation for our npm. We have written a web server, but it is still creating a web request because the port at which it is written is the starting one, that is require HTTP. There's a default package which helps you serve a request without needing anything else. Now we will see how to do all of this using express.js. For that, we will create another directory called mkdir. It will be called express hello. Enter. As we have our express hello. Let's go inside it. Okay. And we will initialize this. And we'll leave all of these details default. Yes. If we get our package.json, we can see that we have a new package.json with all the default values, with the name being express hello. Now we will be using the framework express.js to create a web server, to create a sample web server. So let's go ahead and install express.js. So for that, we will use npm. We will use the command npm install -- save express. It should do 2 things. First, it will get us express.js, that is a third-party framework that can be used for front end also. It will add 50 packages, and it also adds the ability for npm to find vulnerabilities in the code. So if we type ls, we can see that there is a new file, there's a new directory called node_modules. If we go inside node modules and type ls, we can see that we have installed many different packages over here when we typed npm install express. Why do we have so many packages? When we asked npm for express.js, it installed all its dependencies before installing express.js. So we don't have to get them separately. As you can see here, npm is very useful. Clear the screen. Now let's get out of it. Now what happened here was, when we installed express, we installed the dependencies express.js requires. And if you check out the package.json file, it will automatically have express and the version. It will automatically mention express inside our package.json file. This is because we installed our express inside this folder. When you install packages inside the folder that also has package.json, then those package.json will automatically have those packages configured in their description. Finally, what we did 2 things. We downloaded Express and we added the entry to package.json. Now let's go inside index.js. This is a new file. This is where we'll be writing a sample code. Let's get the sample code. This is the sample code we'll be writing.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What are the key components of DevOps? A. Continuous integration. B. Continuous testing. C. Continuous delivery and monitoring. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So unlike last time with HTTP, which is a default package, Express is not a default package, and hence we had to install it. Now let's get out of it. We will save it and quit. If we ls and if we cat our index, we can see that our sample code is here. Now let's go ahead and launch this. So for that we will type node index.js. So it will see, you can see that there's example app listening at HTTP at the port 8081. So let's go at this port. We'll take the IP address :8081. Now if we enter it, we have typed in the host IP and the port number at which we configured our index.js. That is this, and this is the message we wanted to send. So we can see that hello world is over here. Nice. So we close this. Now we've done two things. First, we created a sample web server code and we launched it using NPM, and then we downloaded the Express package from NPM, and using Express, that is a third party, and we launched a web server. Now what we will do is we will learn how to uninstall packages. For that we will use the command npm uninstall Express. This is the package we install. To uninstall it, we will simply type npm uninstall and the package name, and this has to be inside the folder where you had previously downloaded the package from npm. Okay, press enter. As you can see, it's removed all the packages, remove 50 packages. If we ls, if we go inside node modules, we can see that there is nothing inside node modules. If we ls, so we'll come out of it, clear the screen. And how do we know to check which packages are outdated and how to update those packages? To see which all packages have not been updated, we can use the command npm outdated, and this will give us a list of the packages that have to be updated. We press enter, it shows no files. That's because all of our packages have been updated. Now to update our packages, the command is npm update package name and then -g. So let's go ahead and install our Express again. Okay, and let's update it. So we will use the command npm update Express. Since there's nothing to update in, since we got the latest package, it will not update anything. Now let's clear this. Now that we've understood how to figure out which packages are outdated, if you find any packages that are outdated, you can go ahead and update them using this command npm update and the package name. And if you want to install a package, you will use the command npm install --save and the package name you want to install. Now how to look up packages. Let's see how to look up packages. So for that we will do npm search space and the package name. So for example, I will type mkdir because this is the package I want to search. So I'll press enter and it will show me all the packages that have the name mkdir in them or are related to it. We have our first package mkdir, mkdirp. It will give us description, the author, the date, the version, the keywords used. This is the way you can search your packages. Now let's go ahead and install one of these mkdir We'll install mkdirp. So mkdirp, at which version we want to install. We just want to install the latest one, so 0.5.1, and we'll download the packages. Forgot to write install. Now that we use the command, we have downloaded mkdirp, that is the version 0.5.1. So it added 2 packages from 1 contributor. Now that we installed mkdirp, we will check where it is installed. It is installed inside our node modules, but we already have Express also installed, so it will be kind of confusing. So first let's go ahead and uninstall our Express. So for that, the command is npm uninstall Express. Okay, this is removed npm Express. So we will go inside node modules and fls. We can see that mkdirp and minimalist. This must be a dependency for this package we have installed. Okay. Now that we've understood, clear the screen. Okay. If you wanted to know which all files are to be required for a particular code you have written, there's a command for that also. If I've written a code inside my folder and I want to know which all files will be required for it, I can use a command called npm install request. It will tell me what all dependencies or packages are supposed to be there, and it gets them. If I go back inside my node modules and files, you can see that it's read through my package.json file and it's downloaded whatever I've needed inside my package.json file. So suppose you do not want to install all the packages one by one. What you can do is inside your package.json file, you can write down whichever dependencies you need and then just type this command in. That is npm request npm install request, and this will read through your package.json file and then it will install all those files that you have requested inside your package.json file. Another useful command when we're using npm is npm cache clean force. This will clear the cache and make your memory more efficient. This is because npm installs a lot of packages and with that installs a lot of metadata. So if you want to clear a cache, you can go ahead and type this command. And if you want to see where the cache is located, you can go to the root folder, and inside the root, if you type ls -a, you can see there's a file, there's a directory called .npm. This is where the cache is stored. So let's go back and type in the command. That is npm cache clean force. It has cleared all the cache. And another command we can use is called npm audit. Whenever we download a remote package, we want to make sure that the package is fine and there are no security issues with that file. So if we use this command npm audit, it will go through all your packages that have been installed and then it will figure out if there are any vulnerabilities with those packages or not. Since in my case there are no vulnerabilities, it gave me a report, that is npm audit security report, found 0 vulnerabilities in 65 scanned packages. Now let's move on to the hands-on. Guys, now that we're finished with the installation for npm, we can go ahead and practice with it. That is hands-on. So let's look at the steps we will be taking today for practice. So the first thing we will do is we will create a directory and write a sample web server code. And the second thing we will do is we will use express.js to write a sample web server code and launch it. And third, we will create a node.js Docker images. Now let's go ahead and do all these steps. We'll go back to our instance. First, we will go to opt cd/opt, and here we will create a directory called hello world. For that, the command is mkdir and the directory name hello world. We use sudo su, so we don't have to keep typing sudo every time. Clear the screen and we will type mkdir hello world again. Okay, pls, we can see that we have created a directory hello world. Now let's go ahead and go inside this directory cd hello world. Okay, now here we will use the command called npm init. This will prompt us for a few questions and we will answer them for creating a sample JSON file. We're going to be creating the package.json that will initialize a project. Press enter. So the first thing it asks us is package name. We will let it be hello world itself. Then the version, we'll go ahead and type 0.1.0. It's not a release product, so that's why we have put this. Press enter. And it will ask us for a description. Right, just write anything. This is a sample code. Entry point. We will leave it at index.js itself because that's where most web servers have their entry point at. Then the test command. We have no test command to enter right now, so we will leave it empty. And we don't have any Git repository we want to connect to this right now, so we will leave this also empty. Now we can type any keywords, basic keywords like hello world or whatever describes your package the best. And author, I'm going to type Ram. And license, this is the same. Now after you've done entering all the details, it will give you how the package.json file will appear. It will show you the name, the version, the description, the main, the scripts that have to be run, keywords, an author name, and license. If you're okay with it, just type yes. Alright. Clear the screen. If we type ls, we can see that there's a package.json file there now. So if we go inside our package.json file, we can see all the details have been configured. Now using these keywords can be important if you want other people to find your package. So when they search your package using the npm package manager, these keywords will help. And this is only if you wish to put your package into npm. All right, let's control the shift Q. Let's exit this. All right. After entering the data, after creating the package.json file, we have initialized our project, our code. So now we will go ahead and type in the index.js, our web server, sample web server. All right. So we will type v index.js. Guys, so now we have written our package.json file. We can go ahead and write our web sample code. For that, we will write the code inside index.js, right? Let's open it up. It's a new file. And let's put some code over here. So I'll copy some sample code I already have over here. This is just a sample code, okay? It will copy it, paste it. Now we have written a sample code. We'll go ahead and save it. Cat index. Now this will create a web request at the port which we have mentioned. Now since we wrote require HTTP, that it is a default package. If we needed to use something else, we would need to install it separately using the npm, and we will see how to do it later. Now let's go ahead and launch this. So for that, the command is node index.js. Press enter. And as we can see that the server is running at the host name :port. The port we chose was 3000. Now let's go and check it out. Go to our browser, copy our IP address, that's the host name, paste it, : 3000, that's the port number we used. As you can see, it prints a message, welcome to node.js. Now that we've seen how a sample code will work, let's close this, Control C, clear. Now, if you remember, we had to do 3 things in our practice session. First, we will create a directory and run a sample web server code, and then we'll use Express.js to run another sample web server code. And now we will see how to create a Node.js Docker image. So for that, we will first go to our OPT folder and we will create another directory so that we don't create a lot of chaos. We need to be more clean and more organized. So we'll do cd express docker and we will type npm init. We'll initialize and write a package.json file. We will leave everything at default since this is how we need it. Let's have a package.json file now, and we will go ahead and install Express. So npm install save Express. Since we need this package, we'll go ahead and install it. Install the package over here. Okay, if we type ls, we can see that it's node modules is there where all the packages will be stored. And if we type v package.json, we can see that Express is now here. Now let's quit this. Clear the screen. Now we will write our index.js file over here. So we'll type v index.js file. Index.js file. And inside this, we will paste our sample code. So the sample code we will require is this sample code. I'll go ahead and save it. It will run at port 8080 and the host will be the local host. We'll write and save it. We cat our index.js. We can see that our code is here, our sample code. And this is the message we'll be sending, hello world. Alright, now that we've created a sample code, all we have to do is create a Docker file now. So let's go ahead and create a Docker file. Since we will be running this inside our Docker container. So for that, we will need to build a Docker image first. And then using that Docker image, we will be running the Docker container. So first, let's go ahead and create the Docker file. So this is the code we will need. This is the default image that is taken from Docker from Node 10. This is a default Docker image for Node.js. And we will be moving the working directory from the current directory to the one that is written over here. We will copy all the JSON file and we will install all the dependencies defined in the package.json. Then copy all the code and expose the container at 8080 port. And the last command will start npm. If you're clear, you can go ahead. Good. From Node 10, a default image, choosing a new working directory, copying all the details from package.json, running npm install, installing all the packages, copying all the files, exposing it at port 8080 and starting it. Save and quit. We have created our Docker file now. Now let's go ahead and create a file called docker ignore. So sometimes you don't want to include everything. You don't want your Docker to read everything and create an image. You want to skip some files. So for that reason, we will create a file called docker ignore, call it .docker. And inside this, we will write node modules, since we do not need it, and npm debug.log. It's a log file. We do not need to copy this. Let's write it and save it. What happens when we write these is that Docker will not touch the files that have been mentioned inside this file. Now that we have created a sample web server code and we have created a Docker file, we can go ahead and create a Docker container to run this web server inside the container. For that, we will need to install Docker into our CentOS first. There are particular commands for installing Docker, like how we did previously. So for that, first, the commands we will require are, the first one is yum install -y, yum utilis, device mapper persistent data, and lvm2. These are the packages we need for installing Docker. So let's go and copy it and paste it and press enter. After the packages that we require for Docker are installed, we can go ahead and set up a stable repository for Docker. So for that, this is the command: yum configure manager and repo https download.docker.com linux centers docker.ce repo. Okay, and this will have a repo saved to this place. We have a stable repo now. Let's clear the screen, and finally we can go ahead and install Docker. For that, the command is yum install docker ce cli and container d.io. Yes, please. Okay, now that we've installed Docker, we can go ahead and create our Docker image and then Docker container. So first, let's start our Docker systemctl start Docker. This should have started Docker. And now let's build the image. For that, the command is docker image build dot -t express docker / 1.0.0. Actually, you can enter anything here you want. This is just the name of the image we'll be creating. This part of the command, this is the name of the image we'll be creating. Now, suppose if you wanted to upload that image back onto your Docker cloud, your Docker hub, if you wanted to upload this back onto Docker hub so that everyone else can use it, you can go ahead and type your username over here instead. Username. And whatever file name you want to make it here, because this is the nomenclature we follow whenever we are uploading a Docker image onto our Docker hub. But in our case, we will not be doing any sort of that thing. So let's just make it 1.0. Okay. All right. Press enter. This will start building our Docker image. Now that all the details we had mentioned inside a Docker file have been finished, we can go ahead and see if our Docker image was properly created or not. If you type Docker images, it will show that 1.0.0 has been the latest image that has been created. Now that we have created Docker image, we can go ahead and run it in the container. Docker container run -d -p will expose it at port 8080 itself. The name will be Express Docker and the name of the image, that is 1.0.0. So if you press enter, you can see that your Docker container is now running. And to see if it's running or not, you would go back to your browser and you copy the IP address. Go ahead, paste the IP address, and it should be at 8080 itself, since that's the one we mentioned over here. Oh, it's at 3000, so let's mention 3000. And if you press enter, it will show you hello world. Guys, now that we have learned what Node.js is, what NPM is, how to install NPM, and how to practice with NPM, what are the commands you will use inside NPM, like initializing npm init to create a package.json file, then npm install to install a package, npm outdated to see which packages have been outdated, npm install request to request all the packages we have mentioned inside a package.json file to be installed, and npm clear cache. And then we learn how to create a Docker file and build a Docker image and run our web server inside the container. This will teach us, or at least give us, a basic idea of how npm works and a little bit idea about Node.js.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Jenkins. Now, Jenkins is an open source tool which is basically used for continuous integration. It is based on Java, and a lot of companies are working on Jenkins to get their day-to-day work in the DevOps lifecycle done. Right? So this is a brief introduction about Jenkins, and I already told you the features of continuous integration are all of them pertain to what Jenkins can do in your life, right? So without wasting any time, let's go ahead and start with Jenkins by first installing it on your system. So how can you set up Jenkins on your computer? Now, there are a set of commands that you would need to run on your Linux box that would set up Jenkins, but there are 2 or 3 ways you can install Jenkins with. If you have Docker installed on your system and you are just into testing, you can have Jenkins installed in a Docker container. So with that, you do not have to set up your environment with Java. You do not have to go through the process of downloading things. Just download that container, and that would have Jenkins up and running on your system, right? But this is a bare metal installation that I'm going to show you guys. So let me just switch back to my server that I've deployed on AWS to see how you can deploy a server on Jenkins. Alright guys, so this is how my AWS server looks like. So what I have to do is I have all the commands written over here in my notepad. So let me copy these commands. The first command will basically install OpenJDK 8 on my system. So let me do that. Okay, so it's unable to update. Reason is we haven't updated. So let me update the system first. Sudo apt-get update, and once that is done, I'll install OpenJDK 8. Alright, so now it's installing OpenJDK 8. Next step would be to copy this command. This will basically add the Jenkins key in the repository. So let us do that. Alright, so this is done. The next step would be to install this command. Alright. So this is our next command. This would basically add the binary of Jenkins to this list. And now we're going to update. So our repository links gets updated. And now let's install Jenkins. Alright guys, so Jenkins is installed. So first of all, let's check the status for our Jenkins service. So for that, we can check it using service Jenkins status. Alright, so the Jenkins service is active. So our next step would be to open the ports of the EC2 server. So let us do that. So the inbound connections. Let's open all traffic to be on the safer side. If you want to be more secure, kindly open port 8080 because that is what Jenkins operates on. Alright, and let me click on save. Alright, so this is done. So now what I'm going to do is I'm going to come back to my dashboard. This is my Jenkins master. Let me copy the IP address, and this IP address I'm going to use with the port 8080 to open Jenkins. So as you can see, the Jenkins dashboard is now visible. So the first time you install Jenkins, you'll have to enter the administrator password, which can be obtained from this path. So what I'm going to do is I'm going to go to this path and I'm going to cat over there. So this will basically, so let me do a sudo. So this will basically give me the password, and let's copy it and paste it over here. Continue. And now Jenkins is booting up. So the first screen that you would see is customize Jenkins. So let's install the suggested plugins. This would basically install all the plugins that we would require for today's session. So once you have clicked over there, your plugins will start to install. And we're going to wait a while till this finishes. Alright, our next screen is going to ask us for adding a user. So let us do that. Let's give the username as Intellipaat, password as Intellipaat. Once you've filled out all the details, let's click on save and finish. And this would bring you to your Jenkins dashboard. So you would get the Jenkins is ready page and just click on start using Jenkins. All right, so this is how your Jenkins dashboard looks like. And we're going to come back to this. But before that, let's just go back to our slides. All right, so guys, we've successfully installed Jenkins on our system. Our next topic would be to understand the Jenkins master slave architecture. All right, how does Jenkins work in the production environment is what we're going to discuss over here. So the Jenkins master slave architecture is basically important to accomplish continuous integration. Reason being, your testing will always happen on the testing server, and your production code will always be deployed on the production server, right? So you always have to deal with multiple machines when you're working in a DevOps environment, and that is exactly why you need Jenkins master slave. So for in this kind of situation where you have to deploy your code to the testing server, Jenkins becomes your master server and your testing server becomes your slave server for Jenkins, right? Similarly, your production server would become slave server for Jenkins, and the master Jenkins will only have the Jenkins installation. Jenkins will not have to be installed on any of the other systems which are serving as the slave of Jenkins, right? The third thing is, why do we need a master slave kind of scenario? So I've seen a lot of people basically just use Jenkins on the same computer where they have to deploy the code as well, and that is because they are not dealing with probably parallel jobs of deployment, or they're not dealing with complex builds, and that's the reason they have it on the same machine. But when you're working on the production environment, you have to have a master slave kind of an architecture wherein the testing and the production server would become slave for your Jenkins master. All right, so now what we're going to do is we are going to set up master slave on AWS, and let's see how we can do that. All right, so the first thing that we have to do is deploy two servers on AWS, that is slave 1 and slave 2, and then we connect it to Jenkins using the JNLP connection. So let's see how we can do that. So the first thing that I'm going to do is let me jump onto my EC2 management console and let me create two slaves.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the cloud platforms are not used for DevOps implementation? A. Google Cloud. B. IBM. C. Microsoft Azure. D. Amazon Web Services. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
By specifying the number over here, that is 2. So we're going to launch the instances. So our instances are launched. Let us rename them as slave 1.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stand for? A. Development and operations. B. Drive and operations. C. Digital and operations. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And we have our other, which is slave 2. Now, mind you guys, we will not be installing Jenkins on either slave 1 or slave 2. We will be controlling these slaves through the Jenkins master. Now, there are some settings that you'll have to do in your Jenkins master. Let us go through that. So the first thing, so this is your dashboard. So the first thing that you have to do is you'll have to go to click on Jenkins and go to manage Jenkins, go to configure global security. Once you're here, just scroll down and you will reach this section which talks about agents. Now over here we are talking about TCP port for JNLP agents. Just change this to random and click on save. Once you've clicked on saves, now we will go to manage nodes, and now we will add a new node. Let's name this node as slave 1, and now click on permanent agent and click on OK. Now over here you will have to add the launch method. You'll have to change it to launch agent via Java Web Start, and the current working directory path, specify that to /home/ubuntu and /jenkins. All right, just specify this and click on save. You will reach this screen. So I'll tell you what to do after this. For now, let's add one more new node. Let's name it as slave 2, and we'll copy everything from slave 1 and click on OK. All right, so everything is the same. So the remote root directory would be this /home/ubuntu and then Jenkins. All right, so slave 2 is also configured. Let us check what we can do now. All right, so the next thing that you have to do is now click on slave 1 and download the agent.jar by clicking over here. All right, so your agent.jar is now downloading. I had one before, so just ignore this thing. So this agent.jar is now downloading, and now I'll have to send this file to my slave 1 server, and I'll show you how you can do that. Right, for now, just click on show in folder, remove the older agent, rename this as agent. All right, and now we'll have to send this to our slave 1, and the way we can do that is by first selecting slave 1, take the IP address from over here. You'll have to download a client called FileZilla. Just open that. In FileZilla, paste the IP address over here. Username would be Ubuntu for the Ubuntu operating system. Port is 22. And in the settings, you'll have to click on edit and then click on settings. Go to SFTP and you'll have to add the key file over here. I've already added that. Just click on add key file. Just go to your key file, select that, click on open, and it'll be added over here. This is important to connect because when you're connecting to AWS, the only method that you can connect to is using your PEM file or your PPK file, and this is the way you can add it in your FileZilla browser. All right. So once you have added that, just click on Quick Connect, and now you will be connecting to your slave 1. So once you're connected, you will be given all the directories. So here are all the directories. Now I'll have to copy my agent.jar on my slave 1. So just click here and it'll copy your file to slave 1. Okay, so let us also verify that if our slave 1 has been copied or not. So let us connect to our slave 1. So we'll connect it using this IP address. Let us go to putty, click on new session, connect to slave 1. And let us give a special appearance to this. Let us decide a color on this. So let us decide the orange color. So the orange color is slave 1. So let's click on OK and let's click on open. All right, so login as Ubuntu. Great. So now if I do an ls, I can see that agent.jar has been successfully copied. All right, so slave 1 is done. Now we'll have to do the same thing for slave 2. So let us go to slave 2, download the agent.jar. While it's downloading, just copy the IP address for slave 2. Enter it in FileZilla so that we can connect to it. All right, click on Quick Connect. So you will have the directory listed over here. All right, now we'll go here and we'll rename our agent1.jar to agent.jar, and the way we can do that is like this. So we'll just go here, rename this. All right, remove the older agent file and rename this to agent.jar. Once that is done, just drag and drop it on the server. And now let's connect to slave 2 using putty. So let's click on new session, SSH, add the file, and let us keep the color for this slave as white itself. All right. So this is slave 2. And if I do an ls over here, it's the agent.jar file has been copied successfully. All right. So now the next step would be to basically go to your slave, and you'll have to execute this particular command at the place where your agent.jar is present. All right. But before executing this command, we'll have to install OpenJDK on both these servers, that is slave 2 and slave 1. So let us do that. So here's the OpenJDK command. Let us pass it over here. So we'll have to update the server first. So let us update it. All right. And now let's pass the command. All right. So while Java is being installed over here, let's do the same for our slave 1 as well. So let's update it first. So it's updated, and now let's install OpenJDK. All right. So while Java is being installed on this, I think we are almost done on our slave 2. All right. So slave 2, the Java is installed. So what I can do now is I can go to my Jenkins page and go to slave 2, and I can run this command over there now. And this is it. The moment you run this command, can you see it says connected? And the moment it says connected, just come back here, refresh the page, and your slave 2 is now connected. Let's do the same with our slave 1. Just copy this command, go to your slave 1, let's clear the screen, and paste this command. All right, so now both the slaves are connected to your AWS Jenkins server, and you're set. So if you see the nodes, you have a master now, you have slave 1, and you have slave 2. And this is what we were supposed to do. So let me come back to my slides. All right, so we have successfully set up Jenkins master slave on AWS. Our next task is to basically create a pipeline which would be triggered by Git webhook to deploy a project on Jenkins. So let us do that. So for that, these are the steps that we'll have to do. So basically we have a project. I've created a project on my GitHub repository. Now this project has a Docker file, and this Docker file can be built to basically deploy a website on Docker. All right, so we're going to deploy a website on our slave 1 first, which will basically act as our testing server. It will be pseudo testing kind of a thing, right? And if our website is successfully deployed on our test server, that is slave 1, it will then get deployed on slave 2, which will be our production server. So this is basically our job, and this should happen automatically. So a Git webhook basically means that the moment I commit on Git, it should automatically trigger a job on Jenkins. It should automatically deploy the website on my website on my testing server first. If it gets deployed successfully, then it should move forward and deploy the same on my production server. All right, so this is what we are going to do. So let us quickly go to our GitHub website to see how our code looks like. So basically this is my code, guys. I have the Docker file, I have the website in here. Docker Compose, please ignore it, we're not going to use it. So we're going to use the Docker file. The Docker file code looks something like this. So basically this is a container which it's going to pull, and after pulling the container it is going to add the DevOps IQ folder inside the var www html DevOps IQ directory. This is inside the container. All right, so this will get deployed inside my server once I trigger it from Jenkins. Now to do this, first we have to install Jenkins on both the slaves as it is mentioned in the steps. And like it says, like we'll have to configure it in a way that if the build on Jenkins slave 1 is successful, then it should be built on slave 2. Once it's done, we should finally trigger the job using get webhooks. All right, so let's do this, guys. Let's go ahead and start with the demo so that let's see how it can be done. All right, so the first thing that we're going to do is install Docker on both the slaves. So let us go to our putty terminal. Let's go to slave 1 first. Now remember, guys, you will have the connected state over here. Do not close this terminal, otherwise your connection will stop. So what I'll do is I'll just minimize it and I'll duplicate the session so that I can work in a different terminal. All right, so the first thing that we have to do is install Docker. So let's do that. Sudo apt get install docker.io. Okay. So Docker will start installing now. So while Docker is installing over here, let us do the same on slave 2. So just duplicate the session and go to Ubuntu. Now install Docker. All right, so Docker is being installed on slave 2. It has installed on slave 1. Let us check. So Docker -- version, if we can do that, that means Docker is installed. Yes, so Docker is installed on slave 1 and is installed on slave 2 as well. Let's check. So sudo apt sudo docker version. Okay, so Docker is installed on slave 2 as well. Awesome. So our first job is done. We had to install Docker. Now our next job is to configure Jenkins to build the project on slave 1. If successful, should be built on slave 2. So for this, we will have to go to Jenkins. So Jenkins is over here and we'll have to create a job. All right. Now you can check the status of your slaves over here. So you can see that master is idle, slave is also idle, and slave 2 is also idle. Now first let's create a job for our slave 1. So our slave 1 basically will have a pre-style project, and let us name slave 1's job as slave 1. So or let's name it as test. Okay. And then click on OK. All right, so the job has been created. Now the first thing that we had to do was to copy our code to the workspace. So let's just clone our repository or mention the repository link over here and by clicking GitHub project. Okay, and then go to source code management, click on Git and mention your repository over here as well. Now because this job has to run on slave 1, we'll have to restrict where this project can be run and select slave 1, right? So slave 1 is job, and slave 1, once you select slave 1, this job will only run on slave 1. Okay, once you've done with that, the next thing that you would have to do is come down and click on add build step. But before doing this, let us check if my job is being built or my workspace is being populated by the Git repository content if I build this job on slave 1, right? So this would basically test our connection as well. So let's do that. So let me click on build now, and this will basically start a build wherein it will copy the Git content on slave 1 ideally, right? So the blue ball basically tells us that the job has completed successfully. So let us click over here. And I can see that, it has been successfully been finished. So let us verify that. Let's go to slave 1. And if I do an ls over here, Great. So I can see the workspace is there. Let me go inside workspace. All right. So inside workspace, let us see what do we have. We have test. So this is the job name. Awesome. So if you go inside test, do we have the Git repositories content? Yes, we do. All right. So my Git repository was successfully cloned into the test job. That basically means from my master, I'm able to build a job on the slave one node, which is great. So that basically means our connection is working fine. Awesome. So let's go ahead and go back to configuring our job, right? So what we want to do is we want to deploy the website which is mentioned over here in this repository to my project. Now the way to do that is by running this Docker file, right? For running this Docker file, I'll have to check what is the present working directory. So my present working directory is this. So let us copy this. And once you come back to Jenkins, you'll have to scroll down and click on add build step. Once you click on add build step, click on execute shell. What will execute shell do? So execute shell is basically used to run any commands that you want to run on the terminal of the other machine that you're trying to build on Jenkins, right? For example, we are trying to build on slave one from Jenkins. So what commands do we want to run over there? So I want to run docker build command. So I say docker build and then docker build and then the repository where the docker file is, so it's over here, and then the name of the image that I want to give. So the name of the image would be, say I want to say it's test. Okay, so this is the image name. Once the image is built, I'll have to run it. So let's run it on port 80. No, so let's run it on port 82, and then let's run the image like this. So this is the command for running the Docker image that you have just built, right? Once it's built, the next step would be to check whether it's there or not. We can do that on the browser. And I forgot one thing, I'll have to add sudo. And because this job can be built time and again, what we'll have to do is we'll have to remove the older containers which are running on the system, right? So for doing that, I can say that sudo docker rm -f, and for removing all the containers which are running, I'll have to pass in sudo docker ps -a and -q. This should delete all the containers which are running inside my slave one. Now to check if my Docker file is building my containers or not, what we can do is we can simply copy the commands from over here. So the first thing that I want to do is I want to build it. Let's build my Docker file. So the file is now being built. Awesome. So it's been built. The next thing that I want to do is I want to check if I want to run this command, right? So for running it, the command is this. Let's copy it, paste it over here, hit enter, and my container is now running. So I'll have to check that if it's running or not. So I'll go to slave one, copy this, paste it over here. So, and port number is 82. So I can see the Apache page. That means the container is working. Let's check if our files are being showed or not. So if I go to DevOps IQ folder, yes, I can see the website. So means these commands are running fine. But what I have to do is I have to check if it's running through Docker or not. So I have configured the commands over here, and these commands work on the terminal. They should work over here as well, right? So let's go ahead and save this. Okay, so our job has been saved, and the next thing that I would do is let me remove all the containers which are running over here. So for that, I'll have to do sudo docker ps. Let me remove this container. So the container is removed. Now let's go ahead and run this container, run this job. All right, so now let's go ahead to our Jenkins dashboard. and let's build the project now to see if everything goes fine. So I've clicked on build now. All right, so it gives me a failed build. Let's see what the problem is. So the problem is over here. It says the first command sudo docker ps -a-q docker I'm require at least one argument. Okay, so I've got the problem. So the problem is there's no container running over here as of now, right? And that's why it is not able to remove any container, and that's why it is giving me this error. Okay, to solve this, what we can do is, for now, let's, in the configure part, let us just remove this line, or what we can do is we can start a container over there, right? So let's run any arbitrary container, docker run -it -d and then ubuntu. Let's run it so that there's a container running, because ideally there will be one container running at least on my system. So let's click on save, and now let's try to build the project. Okay, so the build has gone successful. Okay, for checking that, I'll say let's just refresh this, and yes, my website is being deployed over here. Awesome. So let me just do it one more time so I'm sure it's working. So let me just do a docker ps sudo docker ps, and let's remove this sudo docker rm-f, remove this, and now let's run our arbitrary container. Let's ensure that this website is now not working. So it's not working. Now let's build this project. All right, so now if I come here and I refresh this, yes, so the website is working successfully. Awesome. So it works on slave 1. Let us now configure the same thing in slave 2 as well, right? So let's come back to our dashboard. So the test job, this could be our arbitrary test job. So basically we are trying to deploy it on a server. If it gets deployed successfully, we are going to deploy it on the prod as well. So let's create a new job and let's name it as prod freestyle project. Click OK, and the GitHub project is going to be the same, this one. Let's paste the URL over here, and we have to restrict this to run on slave 2. Great. The source code management is this Git repository.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What are the key components of DevOps? A. Continuous integration. B. Continuous testing. C. Continuous delivery and monitoring. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And the build step also would be the same. So basically we want to delete all the containers which are running right now. So for that, it's sudo docker rm-f $docker ps -a and -q. Okay, next step is to build the file. So do sudo docker run -it -p, and we want to run it on port 80 because it's production, right? And the image name is test -d and test. And before this we forgot one command, which was sudo docker build, and then the directory, which is /home/ubuntu/workspace slash the job name, which is prod, and then over here the Docker file would be present, and I want to name it as say production. The container name would be production, and over here also the container name would be production. Awesome. So let's click on save, and let's now try to build it. But before that, we'll have to launch one container on test. So let's run an arbitrary container. All right. So container is ready. Now let's check by clicking on build now if this job is working fine. So I've clicked on build now, and if you want to see the console output, we can see it over here. Okay, so it says job failed, and the reason for that is got permission denied. Okay, so the problem is I forgot to add sudo. So let's add sudo. Let's add sudo over here, and that should be it. Let's click on save, and let's try it again. Okay, again we have a problem, but I think it's a new error, so let us try to resolve that. So it's unable to prepare context, and the path is /home/ubuntu workspace and prod not found. Okay, so let's check if this path exists. So if we do an ls, we have Jenkins. Okay, let's go inside Jenkins. If we do an ls, okay, so workspace is over here. So basically I'll have to change the path to /home/ubuntu/Jenkins/workspace/prod-t and then production. Click on save. Let me check if there is a container running on my slave 2. If there is no container running, then I'll have to run one. So sudo docker run -it-d ubuntu. Okay, container is running, and let us also ensure that we do not have any website running on our slave 2. Okay, so this is the command that we are getting right. This is the output that we're getting right now. All right, so let's click on build now, and let's see if our build is successful. All right, so it's getting built. Let's hope for the best. Let's hope it's successful. All right, so it gives us a blue sign. Blue means that build was successful. Let's try to refresh over here. And yes, it works. Now let's just go to DevOps IQ folder and see if our website is up and running. Yes, so our website is up and running. Awesome, guys. Now what I want to do is I want to trigger. So first I want to trigger prod job only when the test job is completed. Now let's see how we can do that. So we'll go to configure, and let's see if we can configure this. All right, so I'll have to go to test job actually. Let's go to the test job. Let's go to configure, and over here I'll have to go to add post build actions. Okay, let's click on that, and after this we'll say build other projects. Click on that, and which project to build? I want to build prod, and trigger it only if the build is stable. So if the build passes, only then it should start with prod. Okay, awesome, great. So let's click on save, and if my test gets succeeded, then my prod job will run. All right, so let us check this as well. So let me try running it. So we can run the test job using a pipeline view as well. So if you just have to come back to the dashboard, and over here you'll find both your jobs. Just click on the plus sign that you see over here. And once you click on the plus sign, you should be seeing a build pipeline view option over here. If you're not, so that means the plugin is not installed. So let's install that plugin. For that, you have to click here, go to manage Jenkins, and then click on manage plugins. Click on available, and then search for build pipeline.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Build pipeline, select it, and then install without restart. Just click on that. All right, and now your plugin will start to install on your Jenkins server. All right, so my build pipeline plugin is installed. Let us go back to our dashboard, click on the plus sign, and you can see there's an option now which says build pipeline view. Select that and name this view as CI/CD or anything that you want, right? Click on OK. All right.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the key component of DevOps? A. Continuous delivery. B. Continuous integration. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Everything seems fine over here. Build pipeline view title, let's name it as CI/CD. Okay, let's click on OK. All right, let's check. So in my CI/CD view, I just see the prod job. So let's see how we can fix that. So I want the test job to also be there. So let's see. So let's click on configure and build other projects after the test is done. Okay. Okay, so we forgot to choose the initial job. So the initial job will be test, right? And let's click on OK. Okay, so now it looks good. So the test job will be executed, and then we'll have the prod job executing. Okay, let's try running these jobs by clicking on run. All right, so as we can see, our test job started and then our prod job started and it completed. So this completed in 1.5 seconds and this completed in 1.5 seconds as well. And both of these have these websites. Awesome. Now what I want to do is I want the moment I commit on my GitHub, this should trigger my Jenkins job. So for doing that, let's go over here. That is my Jenkins dashboard. And let's try doing that with test. Okay, so we'll click on test and we'll click on configure. All right, and yes, so in the build triggers option, just go to GitHub hook trigger for Git SCM polling. All right, and just click on save. The moment that's done, just come back here on your GitHub. So for configuring your webhook, all you have to do is click on settings and click on settings, go to webhooks. Inside webhooks, click on add webhook. And now just copy the IP address and port number of your Jenkins dashboard or your Jenkins page and paste it over here /GitHub -webhook. Specify that and click on add webhook. If the response is received by Git and everything works fine, it will give you a tick, which means everything is working fine, right? And just go back to your dashboard and you can see that everything works out. Great. Now, what we have to do now is we'll have to push a commit on GitHub, and that will automatically trigger a build over here. So let us check that. So we'll just open this over here and we'll go on our master. Let us trigger a build. So this build can be triggered from anywhere. I'm just doing it on master for the sake of simplicity. So I'll just do a git clone of your repository. Git clone. All right, everything is done. Now I have something on my I have a website, right? So what I'll do is I'll change the contents of that website and let's see if that content is visible on our servers as well. So I'll just change the index file. The first thing that I'm going to change is the title. So I'll change this as Jenkins prod website. Okay. And let us change the image as well. So I have one more image over there. So let's name the image as 2jpeg. Great. So now let's push this on Docker Hub. So let's add it, commit it. All right. And let's push it now. Git push origin master, the username and the password. All right. So the push has been made. Let's check if anything is triggered over here. So as you can see, the test got triggered and now the prod also got triggered. So both the jobs have been successfully completed just on a push. Let's verify that. So this is my, so let me see which one is my slave one. So slave one is 108. So let us see. Okay, so this is my slave one. Let us refresh this and see which website is coming. As you can see, the background got changed and as well as the title also got changed. Similarly, if this job is successful, it should also be triggered over here. Let us check if the website is also pushed here, and yes. So the job is also pushed here. Awesome. So let us try this one more time. And with this, let us try to bring back the same background that we had, right? So let's do a nano on index.html and let's change the title to Jenkins final website, and let's change the image name to 1.jpg, which was the earlier image. Save it. Now let's push it on GitHub. So we'll add it, commit it, and now let's push it. All right, so our code is now being pushed. It's been pushed. Now let's come here and see what is happening. So our job should now be running. So test got completed. Prod is being completed. So prod is running right now. And prod also got completed successfully. Awesome. So let's check if our website got changed over here. So this is my testing server. So the title got changed and even the background. Let's see for our production. and even our production website got changed. So awesome, guys. We have successfully completed what was asked to us in the hands-on. So we were supposed to create a Jenkins pipeline, which would basically, if slave 1 job is complete, it should be built on slave 2, and the job should be triggered by a Git webhook, and that we have done successfully.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Docker was essentially a need which came out of the problem that we're going to discuss just now. So imagine yourself as a developer, and probably you're just creating a website on, say, PHP, right? So if you create a website on PHP, the first thing that you would do is write some code. Now, when you want to test that code, the kind of environment that you would be putting it in, let's see what all components would be there in that particular environment. So the first thing that you would need in this environment that is around the PHP file is an operating system, right? So an operating system which probably would have a browser or would have a text editor, right? So you need an operating system to work on. Now, secondly, because you are developing a PHP application, of course, you need the PHP software installed on that operating system so that your file can actually work. Right? Now, when you're developing a web application on a particular language, it's not just the language which will suffice with what you're doing. You also have to take into mind the third-party applications, the third-party libraries that you would be including in your code, right? So the third component that you would need when you're developing a website are libraries, right? For example, if your PHP website has to connect to a MySQL host, then it would need a PHP MySQL library for connecting to it, right? So these are the components that are basically required by a developer to run his program, right? So what he does is he writes a program, he configures the environment according to the program, and when everything goes fine, his program works well. Now, the problem occurred when this particular program had to be given to someone else. Right? So the developer finished his job. Now it was the job of the tester to check this program. So the developer would give the PHP file to the operations guy, and let's see what the operations guy would do. Now the operations guy in the same exact position that the developer was when he was starting to develop his code. Right? So, but the difference over here is now the PHP file is running. It is just that he has to run this file on the system, on his system. Right? So the first thing that the ops guy would do is replicate the environment that the developer is having, right? So he would get the same OS, the same software, and the same libraries to run that PHP program. Now, there are a lot of versions for a particular software. For example, for PHP, you have PHP 7, which is currently running, but there are companies which are still, they're still working on PHP 5.6 because of, probably legacy problems or because the commands have changed. And if they want to move on to 7, they'll have to change all the commands in the code base, etc. There are a lot of reasons, right? So there is a particular version that this company is also following, right? So this ops guy has to have the exact same version so as to make the file work of the developer, right? Now he tried his best possible judgment in it and he installed the PHP software. He installed the libraries, he installed the OS, but still the problem was the ops guy couldn't make the file run. And he came to a conclusion that the code is faulty. But the developer says it ran fine on my system. It's your system which has the problem, so fix it by yourself. So these were some of the statements which were exchanged between developers and operations guy. If you think about it, it was actually nobody's fault, right? The operations guy did what he could in argue that why don't we use VMs in this case. Probably the developer could work in a particular VM and then just give that VM to the ops guy, and then he can work on the same VM and probably run the file, right? That is a viable solution, but the problem is the size of VMs is too large to give to the ops guy and give to the testing guy on every feature that a developer adds, right? For in that case, every developer has to have a VM that he's working on, has to have his own version of the VM, because if you are adding, say, feature A, and feature A requires 3 or 4 more libraries that you have included into your particular VM, it'll become inconsistent with what other developers have. Now imagine the ops guy having several versions of VMs and he not knowing what kind of VM he has to impose on the production server or on the testing server, which basically will act as the final version of the image on which all the features of all the developers will work. Now it's a very hectic situation. So the problem was that VMs were very large and they were complex as well to handle when we are talking about staging area or the deployment area, the production area. They were a little difficult to handle. Now, this was the problem that was there before Docker. So what did we need? We basically needed a wrapper. Like in the case of what we just discussed, the wrapper was a VM wherein it basically contained all the operating system files, all the software, all the code, and all the libraries together, and could be basically lifted and shifted to a different system where it would execute, right? But we needed something more portable. We needed something more smaller that could easily be given to some other person for testing, right? We needed something like that. We needed a wrapper around our files. And the answer to this was this particular scenario, that now if we get a wrapper which will basically contain all the files, in that case each and every environment of ours will become the same. The developer environment is going to be the same, and the moment it gets passed on to the ops guy, he will again deploy the same wrapper, and his problem is also solved because the ops guy does not have to match the versions of the OS, the software, the libraries, because everything is there inside that wrapper, or everything is there inside that container, right? He just has to run that container and he can just see if the code is working properly according to what has been specified or not. Right? So the answer was that all the environments, the developer environment, the staging or testing environment, the production environment, all of these environments are now going to be the same, right? And this was possible using Docker. So what is Docker? Docker is basically a software which helps us creating this wrapper around the files of a code, the operating system, and the libraries that we mentioned that are required for a particular code to work, right? But the awesome thing about Docker is that you do not need the environment to be in GBs, right? You do not need it to be somewhere around 900 MB or 800 MB or 1 GB or 1.5 GB. A container could be as low as 50 MB. That is the size of a container called Alpine. It's as low as 50 MB. So it becomes very easy to basically give it to other people to test your code with all the environment set up in that particular container, right? So Docker is a software which helps us enable that. Docker is basically a tool which helps us in containerizing an application, right? And now let's see how basically Docker is doing this. How is it so portable? How is it so low in size? So basically this is the architecture of Docker. So at the base level you have the hardware. That basically means that you'd have a computer, and on that computer you would have an operating system present, right? So this is your operating system. So it's as simple as you have a laptop, and on that laptop you have Windows or Linux installed, right? Now once you have the operating system installed, the next thing is the container engine that you would install. So the container engine is nothing but the Docker software that you would install on top of your operating system, and that is it. Once you've installed the container engine, you can run any type of container that is there in the repository on the or on the web, which is available. For example, if your code needs an Ubuntu container, right? All you have to do is write Docker run Ubuntu, and what would it do? It would basically download the Ubuntu container. Then you can add your code files inside that Ubuntu container and start working, right? But how is it low in size? How is it not in GBs. When we compare it to the Ubuntu operating system, it's around 800 or 900 MB, right? The Ubuntu desktop version. But how come this container is so small? So the answer for that is the container does not contain all the operating system files, right? So as you can see, the container engine actually shares its space with the operating system. So a container is void, or a container does not have a kernel in place, right? It shares the underlying kernel of the operating system on which the container engine is installed. So if I talk about, say, you have an Ubuntu operating system or you have a Windows operating system, and basically what you do is you download the container for CentOS. So CentOS is basically a Linux distribution, right? So you download the container for CentOS, and now when you're working in that container, you feel as if you're in CentOS. But the point is that the CentOS operating system is actually not installed. What is basically happening is your container is sharing the resources from the operating system, but your container has the minimum binaries and libraries that are required to run the CentOS commands, right? For example, for installing anything on CentOS, you pass the command yum install and then the package name, right? So it would have the yum package in there in the container, right? It would have all the repository URLs there in the container, and that's how it behaves like a CentOS operating system, although the container is nothing but a set of binaries and libraries which are important for the CentOS commands to work, right? That is all what a container is. But with the underlying virtualization of the kernel or the BIOS of the operating system, your container seems to be like an operating system, although it is not. And because of this very reason, that it virtualizes the underlying kernel or BIOS to make it as if it's running on its own, it is its own kernel or BIOS, is the reason that the containers are very lightweight, because they don't need to have all the files required for an operating system. They just need the bare minimum binaries or libraries required for that particular environment to work. Okay, so if you again come back to see this architecture, you have the hardware. On top of the hardware, you have the operating system. On top of operating system, you install the Docker software, and on top of Docker software, you run containers. So all these containers have the minimum binaries or libraries, and on these you basically just put your code. In my case, I will put my PHP code on top of the container, and that would be app1. And there could be multiple containers running on my system. For example, one code file is running in Ubuntu, the other code file could be running in CentOS container, the third could be running in some other operating system or some other flavor of Linux container, and all this is possible using the Docker software. Okay, so this is the architecture for a Docker container or a container in general. And now let us compare it with a VM, right? So I gave you the example of VM when I said that VMs are heavy in nature. So let us understand how containers are different from VMs. All right, so on the right side, you can see the architecture of VM, guys. So on the VMs, you have the hardware, which is the same as the Docker architecture that we saw. Then on top of hardware, you have the host operating system, which is the same as the Docker container that we saw. Now, on top of the host operating system, you have a hypervisor or a VirtualBox kind of software, which will basically virtualize the hardware from the operating system and give it to the VMs running on top of it, right? So you have a hypervisor software in case of VM architecture, and then you have the container engine software in case of a Docker architecture. Then on top of the hypervisor, you have the guest operating system. And this is where the all of the difference is, right? So in case of containers, you just have the bare minimum binaries or libraries which are present. But in case of your VMs, you have the whole operating system, which is basically installed on top of the hypervisor. Alright, so because you have the whole of the operating system installed, your size of the VM is quite bigger than what you have in the container, right? Now, the VMs could be multiple in nature. When we talk about how many VMs can we run on a machine, it totally depends on the specs of the machine, right? What are the specifications of the machine? So in VMs also, you can run multiple VMs on a single machine. And also, one thing to notice over here is that there could be or there could not be a host operating system in case of VMs, right? So in case of virtualization technologies, it has advanced this much that the hypervisor itself, it does not require a host operating system. It could directly work on the hardware level as well. But usually when we guys work in R&D, or when we have the kind of laptops that we have, right, the kind of specification that we go ahead with this kind of an architecture where we have an existing operating system. On top of that, we install tools like VMware or VirtualBox, and on top of that, we install the VMs. All right. So guys, this was the basic difference between a Docker architecture and a virtual machine architecture. Moving forward, now let's just discuss. So we have understood why do we need Docker, and we have understood that what Docker is exactly. Right now, let's go ahead and see how we can install Docker on our machines. Now, when it comes to installation, there could be basically three kind of installations that you might come across. You could either have an Apple or a Mac system that you're working on, you could have a Windows system that you're working on, and you could have a Linux distribution that you're working on. So let me walk you through all the three domains in basically installation, so that we are on the same page once we come out of installations and when we are doing hands-on. I hope you guys all will be able to, go along with the video as we are performing the hands-on. All right. So if you're on Mac, guys, all you have to do is go to this link. So this link is basically going to download the Docker toolbox for Mac. And once you have the Docker toolbox, it'll basically install everything. It'll install Compose, it'll install the Docker software, it'll install the other components of Docker. So you don't have to worry about what component is what. But basically just go to this particular link, download the Docker software. And once you have the Docker software, just come back to this CLI and just pass the command Docker version. And if you get the reply as the version of the Docker which is running on your system, it's your software is basically successfully installed, right? So this is the installation for Mac. If you talk about the installation on Windows, just go to this link, download the Docker toolbox, and everything is going to be set up automatically for you, right? When we talk about Ubuntu, things are a little simple on the Ubuntu side. All you have to do is pass these commands and your Docker would be up and ready, right? So for our sake, we will be basically doing all our hands-on today on the Ubuntu distribution of Linux. So what I'm going to do is I'm going to just go back to my terminal so that we can use the PuTTY software to basically connect to our Ubuntu distribution. So just give me 1 second.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the cloud platforms are not used for DevOps implementation? A. Google Cloud. B. IBM. C. Microsoft Azure. D. Amazon Web Services. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Alright guys, so this is basically my Ubuntu distribution, right? So what I'm gonna do is I'm gonna install Docker in it. So the first thing that I would pass is the command sudo apt get update. So the first command that I'm gonna pass is sudo apt get update. Once I've done that, the next command that I'm gonna pass is sudo apt get install docker.io. Alright, and then you'll be prompted for a yes or no. Just type in Y, which will mean yes, and this will install all the packages required for Docker to work on this particular system. Right, so if your internet is fast, it will hardly take a minute to install Docker, and once Docker is all installed and set up, we can go ahead and check whether Docker is working on our system or not by typing in sudo docker version. So just give it a minute and this will all be over soon. Alright, so Docker is installed now, and all we have to do now is check the version. So it's docker -- version.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stands for? A. Development and operations. B. Drive and operations. C. Digital and operations. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
And as you can see that the Docker version is 18.061 CE, and the build is this. So this basically confirms that Docker has been installed on our system. So I've successfully installed Docker. So now let's go ahead and see what is in store for us on our next slide. All right. So we have installed Docker on our system, guys, and I hope you guys have also, if depending on the kind of OS that you're working on, I hope you guys have also installed Docker on your system. If not, you can pause this video, do that first, and come back, because I would want you guys to learn as much as you can from this session, and I would want you to follow me while I'm doing the hands-on, so that you get the maximum knowledge possible from this session. Alright, so the next thing that we're going to do in this session is get acquainted with the Docker container lifecycle. Alright, so basically this is how this is the whole lifecycle of what a container goes through when we talk about the Docker ecosystem. Now, if you guys know what GitHub is, or if you guys have worked on GitHub, you guys might know that there is a central repository. Whenever you start or whenever you have to start working on a particular code base, the first thing that you have to do is pull the code base from the central repository. Right, so that central repository is nothing but something on the cloud or something on the internet which holds all the code base for your organization or for your team that everyone is working on, right? So that is basically a central place where you can download everything from. And similarly, in Docker, we have something called as Docker Hub. Now, Docker Hub would contain all the container images that are present, that are open source images that are present. For example, I told you that you could run a container on Ubuntu, you could run a container on CentOS, you can run a container on Alpine, you can run a container on some other operating system. So all of that is present on Docker Hub. Right, so the first thing that you do is pull an image from Docker Hub onto your system, and this is your system where Docker engine is installed. And basically what you download from Docker Hub is an image of a container. Okay, so you get the image, and the next step that you do is you run that image, and the moment you run an image, it becomes a container. Right, so you can run that image, and that would basically be the normal way or the normal state of a container that it is running. Once you want to stop a container, that is again a lifecycle state, that when you're done with working on the container, you can stop it. And once you are done with everything, you don't need it on your system anymore, you can remove it. So this is the lifecycle of a container. The first thing that you do is you pull it from Docker Hub, it becomes an image, then you run that image, and it becomes a container. And the containers can either be in a running state, in the stop state, or in the deleted state. So this is the life cycle of, this is basically I would say a summary of what happens inside Docker, but of course there is more to it, and we'll see as we move along in the session. Okay, so we've understood the common the common ecosystem of Docker. We've understood what Docker is. We have understood how the containers work inside the Docker ecosystem. You first download them, they become an image, then you run that image, and then they become containers, right? So with this knowledge now, and with Docker installed on our systems, let's go ahead and perform some common Docker operations that you would be doing when you are working on Docker in your day-to-day life. All right, so this is the first command that we can try out when we are working on Docker. Alright, so whenever you want to find out what version of Docker that you're working on, you can simply pass this command, docker version, and then you can basically get the version that you're getting on. Let me quickly change the color of the terminal, because I feel that this color is a little dull, so that it becomes better for us to see. Just give me 1 second. All right, much better. So when we pass this command docker version, you get the docker version, the current docker version that installed on your system along with the build name. And this is exactly what this command does. All right. The second command that you can go ahead and try is docker pull. So we saw the container lifecycle. The first thing that you do is pull the image from Docker Hub. All right, so and the syntax for pulling the image is docker pull and then the image name. So as you can see in the screenshot, we passed the command docker pull ubuntu, and what it did was it downloaded a container from Docker Hub automatically. So what we can do is we can also try that out. So let me just clear the screen. All right. Okay. So we'll type in docker pull and then the image name. So this is the image name and we'll hit enter. All right. So sorry about that. I forgot to use sudo. All right. So sudo docker pull ubuntu, hit enter, and this would download the latest Ubuntu image on your system. Now remember guys, we have just downloaded the image. We have not run the container yet, right? So our next command would be docker images. So now if you want to check what image did you download and is it existing on your system to verify, all you have to do is type in docker space images. So about that. So sudo docker images, and then you would be able to see the image that you just downloaded. Okay. So this is the image that we just downloaded, and you can see the size. It's 86.2 MB. 86.2, that's too low to be an operating system, right? Imagine the beauty, guys. So an Ubuntu operating system, a VM that you're working on is, I think, around 1.5 or 2 GB. But when we talk about this container, it's hardly 86.2 MB. Awesome, right? So once you have seen the images, the next step would be to run this image, right? Now to run this image, the command is called docker run and along with the image name, right? So you use some flags as well when you're using docker run. So let me explain you while I'm executing this command. So sudo docker run, this is the syntax. The next flag that you add is -it, which basically means make the terminal interactive. -d, which means run the container as a daemon, run the container in the background. So whenever I run the container, make it running in the background till basically I stop the container. So that is what -d does, right? So the command would be sudo docker -it. It means make the container interactive in the terminal so that I can also pass in commands. -d, which basically means make the container a daemon that it should be running in the background even though I'm not working on it. And then you pass in the image name. So the image name is Ubuntu, and then you hit enter. So can you see you just got an ID of the container? So basically this, if you get something like this, this means that your container has just started. And then to view all the running containers, all you have to do is pass the command docker ps, and that would list down all the containers which are currently running in your system. So let us do that as well. So let me just clear the screen. So just pass in sudo docker ps, and this would basically show you the container which you have just started. So as you can see, I started the Ubuntu container 29 seconds ago, and this is the container ID for that particular container. All right, so my container is running. So what's next? Next step would be to see docker ps would basically show you the containers which are in the running state. But what if you want to see all the containers which are there in your system? For example, what I can do is I can do a sudo docker stop, and I can stop this container, right? So this container is now stopped, and what I can do is I can run one more container, which would be sudo docker run -it -d and then Ubuntu. sorry about that. So if I do a docker ps, I would only be able to see the container which is currently running. So you can see it is up 7 seconds ago. But if I want to see all the containers which are there on my system that could either be in the start state or the stop state, all I have to do is type in the command sudo docker ps and then -a. And with this, I can see the containers which are running. So this is container which is running, which was made around 27 seconds ago. And this is the container which has exited, which we manually stopped. And we can see that also by passing the command sudo docker ps -a. Okay. Now the next step would be to work with the container. So we have started the containers, but the next step would be to start working on them. And how can we do that? We can basically do that using the command docker exec. So what we'll do, we'll just first get the container ID. So that container ID is docker ps. All right, so this is the container ID. This is where this is the container which is currently running. Now if I want to get inside this container, the command for that would be docker sudo docker exec, so exec, then -it, make it interactive, give the container ID, and then bash. Bash would be that I want to run this container in the current terminal space that I'm working in, and the current terminal space is bash, and I'll hit enter. So let me just clear the screen. So can you see that you are now inside the container, right? So this is the container ID and this is the user of the container. So we are basically acting as root of the container ID. That is, we are inside the container and we are acting as root. So this is basically the environment. This is the environment that I was talking about that the developer will start working in, right? And this is basically an Ubuntu container. So all the Ubuntu commands are gonna work inside this particular container. So once we are inside the container, we can do whatever like. So for example, if I have to update the container, I can do an apt-get update and it will start updating the container as if it's a new operating system which is running on the system, right? And also to show you guys that this is different, or this is completely independent from what we were doing outside the container. You remember we have Docker installed on our host operating system. Now if I try to access Docker from here, I will not be able to do that. So if I do a sudo docker ps, you can see that it says okay, let me do a command docker ps. You can see that it says docker command not found, right? So basically Docker is not installed inside of the container, and that is the reason it is not able to access Docker. Also, an interesting thing that you can see over here is that I passed the command sudo docker ps and it says sudo command not found. So the sudo library is not installed in the container, right? So I told you the bare minimum libraries which are required for a container to make it behave as a particular operating system is only present in the operating system, is only present in the container and nothing else. And that is why you can see even sudo as a command is not present inside the container. All right, so if you are inside the container and you want to exit the container, all you have to do is type in the command exit, and this will make you come out to your host operating system. But mind you guys, your container is still running. So if you do a docker ps, you can still see the container running in your docker ps space.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Alright, so this is how you can get inside a container. All you have to do is docker exec -it and then the container ID space the terminal that you're working in, which in my case was bash. Alright, okay. Now again, so this I already showed you that if you want to stop a container, all you have to do is sudo docker stop and then the container ID, hit enter, and the container will be stopped. And then if you do a docker ps, you will not be able to see any containers which will be running inside the system. So as you can see, once we did a stop, there are no containers running over there in a docker ps space now. Okay. You can also kill a container in case a container becomes non-responsive and you're stopping the container but it's not able to exit. What you can do is you can kill a container. It's similar to that of stop, but when you stop a container, it basically gracefully exits the container. It's just like shutting down your computer or just switching off the power switch from behind the computer's power outlet, right? So if you have the stopped the container, but the container is still not stopping because of some program which is running in loop inside the container or something like that, you can immediately kill the container using the command docker kill and then the container ID. Then you have something called as docker rm. So basically I told you guys that if you do a docker ps -a, you can still see the containers which were stopped, which were in the stop state, right? But as we saw in the lifecycle, there's a third stage of Docker containers, which is basically the delete stage. And to reach the delete stage, you pass in the command docker rm and then the container ID. And this would basically delete the container from your system. Now let's see how we can do that. For example, if I want to remove both these containers from the system, all I have to do is take the container ID, pass in the command sudo docker rm, and then pass the container ID, hit enter, and this would remove the container from my system. So similarly, if I want to remove the second container as well, I'll just have to pass in the command sudo docker rm, the container ID, hit enter, and the containers will be removed. And now if I pass in the command, let me just quickly clear the screen. Now if I pass in the command sudo docker ps -a, you can see there are no containers which now exist because we have just removed them from our system using the command docker rm. All right, moving forward. Now what to do when you have to remove an image? Now you guys know we already have an image in our Docker system, which is this. We have the Ubuntu image. Now if you want to remove this image from the system, the command for that is docker rmi and then the image ID. And this would remove the image from your system. So if I want to remove this, all I have to do is type in sudo docker rm. So rm was to remove the container. If you want to remove the image, just type in I as well in front of the rm command, and then the image ID, which is this. Pass in this, hit enter, and this would delete the image from your system. So if you do a sudo docker images now, you can see that the image is not present in the system anymore. All right, so this is how you can remove image from your system. And this was it, guys. So this was how you can basically go ahead and do these are some of the common operations that you would do in your day-to-day life while you're working on Docker. And I hope you guys are well acquainted with all these operations. So what I would suggest you guys is pause this video, try to do all those commands together, and once you're done with that, let's resume the video to going ahead, right? So our next topic is basically to create a Docker Hub account. So like I was comparing it to GitHub. So if you guys have worked on GitHub, you also have to create an account on GitHub in case you want to have your own repository where you want to push your own personal stuff or your personal code for your probably R&D or whatever you want to call it, right? Similarly, you have something in Docker Hub as well. If you have created a container for your own testing purposes or R&D purposes and you want to push it to Docker Hub so that in later time probably you can pull it whenever you want, or if you want to share that container with the other people, all you have to do is create a Docker Hub account and push your container image on that Docker Hub account. Right, so that is possible, but the first step would be to create a Docker Hub account, and for that you have these steps. So first you have to go to the website hub.docker.com. So let me quickly show you that. So all I have to do is go to the browser, go to hub.docker.com, and you would see a website which will look something like this. All right. The next thing that you would have to do is you will have to sign up on this website. So just choose a Docker ID. Now this Docker ID is basically like your username, and this username has to be unique. right? Enter the Docker ID, enter your email address, your password, agree to the terms of conditions, and just click on sign up. After this, you would get a verification email on the email address that you specify over here. Verify your email, and that's it. Your Docker Hub account is all set up, right? I already have a Docker Hub account, so let me just quickly show you that. So my Docker Hub account looks something like this. Just give me 1 second. All right. So guys, this is my Docker Hub account. And as you can see, I have some personal containers that I uploaded over here. And I'll show you guys also how you can do this. But before that, let's come back. So once you have set up your Docker Hub account, you would be able to see your Docker Hub account, which would look something like this, right? And always remember, guys, remember your user ID, because it's going to help you out in the future when you are basically pushing your custom images onto your account, that is your Docker Hub account. Alright, so always keep your user ID handy. Alright, so guys, this is how you can sign up for Docker Hub. Once you have signed up, let's go ahead and see how you can save changes to a container. Alright, so what does this basically step mean? So this step basically means that if I am on my system and say, I run my Docker command, now say I run a Docker container, right? So this is basically download and run the container for me. So sudo docker ps, this is the container that I want to go into. Alright, so I'm now inside the container. Now what I want to do is, let us do an LL, and you can see these are all the directories which are present inside the container as of now. Now what I want to do is, I want to say create a directory, and say I create a directory called app, right? So if I do an ls now, you can see there is a new directory app which has been created inside this container. Right now, if I exit this container and say I do an ls, if I do a sudo docker ps, I can see that the container is running. But the catch here is that if I delete this container, say I delete this container. Okay, so one more thing, guys. If you want to remove or delete a container which is running, you can pass in the command sudo docker rm-f and then the container ID. The other way to do is to stop the container first and then delete it. That is a general way of doing it. But if you're in a hurry and you want to delete the container which is in the running state right now, just type in the command sudo docker rm-f and then the container ID, and this would remove your container. Alright, so I've deleted my container now, and if I now type in, if I again run the image, that is sudo docker run -it -d and then the image name, and if I go inside this container,
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What are the key components of DevOps? A. Continuous integration. B. Continuous testing. C. Continuous delivery and monitoring. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
and if I do an ls, you can see the directory that I created, it is not nowhere present over here now. The reason for that is, whatever changes you made to the container, they were only present inside the container, and this container, when deleted, these changes do not propagate into the image that you downloaded originally. Alright, now if you want to make changes to a container and want those changes to be saved inside an image so that you can later on again launch a new container and it should have all those files or folders or softwares that you installed inside the container, you would have to save these changes inside the container, and for that you would have to learn how to save changes inside a container. Let's go ahead and learn how you can save these changes inside a container. Alright, so for saving changes inside a container, the command is called docker commit. Okay, so you have to pass in the command docker commit, the container ID that you want to save, and then the new image name. So basically this will create a new image of a container, and once you pass in the container ID space, you have to give the new image name that you want that custom image to have, right? So for example, in my case, if I create the folder, say app, I do an ls, I can see the app folder is there now. Right, I'll just exit the container. I'll do a sudo docker ps. I can see this is the container ID. So I'll just copy that and sudo docker commit, pass in the container ID, and then the new image name. So the image name, let's say I say the image name is test. All right, so with this, if I now do a docker images, I can see that there is a new image which is present, which is called test. All right, and now I can run a container on the image test, and all I have to do is sudo docker run -it -d and then test. This would run the container, and if I go inside the container now, I can see that my changes would be there inside this container. So if I do an ls, I can see that the app folder is present. And this is how you can create a custom container. So I, for demo purposes, just created a folder. You can also install softwares inside a container. Like for example, you install Apache, you install MySQL, or any other kind of software that you want. Then all you have to do is save the container using the docker commit command, and you're all set. Whenever you run that image again, you would have all those softwares installed inside that container. All right, and this is how you save changes to a container. All right, so now let's do this example. So basically what we're going to do is we're going to run an Ubuntu container. We're going to install Apache on it. And once the Apache is installed, we're going to save that container into an image. All right, so let's see how we can do this. So let's clear the screen. Let's exit this container and let us first clear everything up. So sudo docker ps. So there are two containers running. Okay, so let me show you one more command, which is basically like a shortcut. So if there are like tens or five or more than 5 or more than 3 containers running on your system, you always don't have to pass in the command sudo docker rm -f and then pass the container IDs. The shortcut to remove all the containers at once is the command sudo docker rm -f and then pipe it with another command, that is the sudo docker ps -a and then -q. You pass in this command, it would remove all the containers which are present in your system. So if I do a sudo docker ps now, you can see there are no containers running anymore. All right, so this is the shortcut that you can use while working with Docker. All right, so my next step is to basically install. So first I have to run an Ubuntu container. So I'll do a sudo docker -run -id Ubuntu. All right, so my container is now running. The next thing that I have to do is install Apache server on this container. Okay, so let's take it a little differently now. So basically, okay, so let it be like this. We'll come back to the part that I wanted to explain to you guys later. So basically now I'll just exec into this container. Okay, I'm in. First thing that I'll do, I'll just update the container. So apt-get update. Okay, once it's updated, the next step is to install Apache, and for that the command is apt-get install Apache 2. and this should install the Apache software. All right, and service Apache 2 status would give us whether Apache is installed or not. So it says Apache 2 is not running, so let's start the service. So service Apache 2 start, hit enter, and if I now check the status of Apache 2, I can see that Apache 2 is running inside the container now. Awesome, this is what I wanted. So let me just exit the container now and let me save the container. So we have installed Apache on our container. Next step is to commit these changes to the container so that it becomes an Apache container. Alright, so I'll do a sudo docker ps. This is the container ID. I'll say sudo docker commit, give the container ID, and now give the image name. So let's give it as Apache. Or let me make it a little more simpler for me when I move ahead. So whenever you want an image pushed to your Docker Hub account, there is a certain nomenclature that you have to follow when you're naming your image. So first of all, you would have to write the username for your Docker Hub account. Remember, I told you to remember your user ID, and this is exactly for that. So specify your user ID / and then whatever name you want to give to your container. So that would be Apache, right? So the naming would be specify your user ID / your container name that you want to give. All right. So sudo docker commit container ID and then the container image name that you want to give to your custom image. Hit enter, and this should basically save your images. So if I do a sudo docker images now, you can see that our image has been saved over here with the name hshar/apache. You should also notice that now my size of the container is 212 MB. Because I've installed the software, the size has gone up. It was 86 MB before, but because we have installed a software on it, it has now become 212 MB, which is fine. Alright, so now we have the new image. So what I'm gonna do is I'm gonna remove all the containers which are running now. So sudo docker ps, this is the container running. So let me just remove it. Okay, forgot to do the -f. Awesome.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
So now what I'll have to do, to check whether my image is functioning properly or not, what I can do is I'll just pass in the command sudo docker run -it -d and then the image name, this is hshar/apache. Okay, I'll introduce you to one more flag, which is -p. Now what -p does is it basically does port mapping. So when I've installed Apache, if I want to check if Apache is working or not, normally Apache works on port 80.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is the key component of DevOps? A. Continuous delivery. B. Continuous integration. C. Continuous testing. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Right? So on containers port 80 Apache would be running. But if I want to check the port of the container, or if I want to check if everything is running inside the container fine, I'll have to map the internal port of the container to the outside host operating system. So in this case, I'll have to map it, say if I want to map it to port 82 of my OS, of my host operating system, to the 80 port of my container. This is the command to do that. -p space port number that you want to specify, : the port number of the container that you want to link it with. So I want to link the port 82 with the internal port 80 of my container, which has the image running hshar/apache. All right. I'll hit enter. This would create the container, and if I do a sudo docker ps, I can see the container is now running. So let's exec into this container. So sudo docker exec -it, give the container ID bash, and if now I do a service apache 2 start, it should basically give me either an error that apache 2 not found, or it should start the service. So let's see what happens. So it says service Apache web server Apache. So this basically means Apache was present inside this container because we did the sudo docker commit. Apache was installed inside this container, and this now service has been started. Now remember guys, we have mapped it to port 82. So now let's check if we can access the Apache software on port 82 of this server. All right. So let me just go to the IP address of this server. So basically the server is running on AWS. So this is the IP address of the server, and I have opened it on port 82, right? So right now if I hit enter, it will not work. Reason being, I'll have to open the ports on this server. So let me just do that. Let me open all traffic so that we are on the safer side. Okay, so IP address colon port number, which is 82, hit enter, and you can see the Apache is successfully running. So mind you guys, Apache is not installed on the server, it is installed inside the container, and that software is able to access on the browser using the port that you mapped on the container. All right, so for our verification, what I'll do is sudo docker ps, and I'm gonna stop this container now. Sudo docker stop, pass this ID, and now if I do a refresh over here, you can see that it says the site can't be reached. Reason being, I've stopped the container over here. All right, and this is how you can save changes to a container, install software, and create a new image out of it. Now next step would be to push it to Docker Hub, right? So I told you guys, once you are done working on your container and you've created a custom container that you want your team to access, or you want it to be there on Docker Hub for safety purposes, you can push it to Docker Hub. And to do that, the command would be sudo docker push, which I'm going to explain in a little bit. But before that, we saw the life cycle, right? We saw we can push or pull from the Docker Hub. So this is the pushing state. So we had a Ubuntu container, we installed Apache on it, and then we committed the changes, and now we have an image on our local system. The next step is to push it to Docker Hub, right? And let me show you exactly how to do that. So this is your Docker Hub, guys, and the first thing that you would have to do is you would have to log into your Docker Hub from your console, and to do that you will have to type in the command sudo docker login, pass in this command. You'd be asked the username, so pass in the username of the Docker Hub and then pass the password. So if there is any problem with your password, it will give you this error. So let me just try once more. So I'll pass in the username and then I'll pass in the password. And on a successful login, you will get this message that is login succeeded. Awesome. So I have logged into my Docker Hub. Now what I want to do, I want to push my image. So I'll have to do a sudo docker push. And what was your image name? It was hshar/apache. This was the image name, right, that we gave to our custom container image. Hit enter, and it will start pushing your image to Docker Hub. And once it has pushed the image, all you have to do is you can just visit your Docker Hub repo, and you'd be able to see your image listed over here. Just do a refresh and just go to the last page, and you can see this is the image that I just pushed to the repository, which is hshar/apache. Awesome. So we have successfully pushed our image to Docker Hub. So it's very easy. Just type in the command sudo docker push, and that should be it. All right. So our next topic now is introduction to Dockerfile. And let us go ahead and learn what is Dockerfile. But before that, let us recap what we have just learned. So we understood what Docker is, why do we need Docker, what is Docker exactly. Then we went through some of the Docker operations, the day-to-day operations that you would be going through. We got acquainted through that. Then we saw how to run a container, and then how to do some changes to the container and save it on your local system. And finally, how to push that container onto a Docker Hub. This is what we have learned. Now, the next step is, what is a Docker file? So a little introduction about a Docker file. So you just saw that if I had to make changes to a container, I basically had to run the container first, go inside the container, install whatever software I want, install whatever I want, and then come out, commit the container, and only then it will get saved. But there's a shorter version of this. When you're working on production grade environment, everything has to be lightning fast, right? And for making changes to a particular container image, you can also use something called as a Docker file, right? So we're going to discuss what a Docker file is now. So let's go ahead and start with this topic now. So a Docker file is nothing but a text document in which you write how do you want your container to be customized, right? So one example, like I just told you guys, was when I did it manually. I ran a container, I went inside it, I installed the software, came out, committed the container, and then pushed it onto Docker Hub. Now, all these changes can be automated using a script style, which we call the Docker file. Now, a Docker file is very easy to write, and there are basically some nomenclatures or there's some syntaxes that you would have to learn, but I'm sure they are very easy to learn, and once you learn them, it will only be Docker file that you would be using rather than doing everything manually. Alright, so let's go ahead and see how we can create a Docker file. So guys, these are some of the syntaxes, these are some of the important syntaxes that are relevant to creating a Docker file. Now, the first line of a Docker file is always from, right? So the image on which you want to make changes. For example, we made changes on the Ubuntu images where we installed Apache. Right, so what we did docker run -it-d and then Ubuntu. So in Docker file, the first base image that you want to work on, you'll have to specify it on the first line using the command from. Okay, so this area of your presentation will basically tell you the Docker file content. So this is exactly how the content of the Docker file should look like. So the first command is from. So from Ubuntu. So the base image that I want to work on is Ubuntu. So this would be the first line. Second command would be to add all the files. So add is basically used to add files inside a container. Now, for example, say I create a HTML file and I want that HTML file to be added inside the Ubuntu container. So for doing that, the command add, the first argument would be the place where the files are present, and the second argument would basically be the location inside the container where you want all those files to be copied. All right, so add space dot, the meaning take files or take all the files from the current directory and put it inside /var /www and /html. All right, so this is what the add command does. The third is run. So whenever you want to run any command in the container, for example, I ran apt-get update and apt-get install Apache 2 inside the container, right? Now, if you want to run the same commands from the Docker file, you can do that using the command run. So over here, there are two commands that I want to run. The first is apt-get update, and the second is apt-get install Apache 2, right? The -y signifies over here the option that we get, that whether you want to go ahead with the installation, yes or no. So if you specify -y implicitly in Docker file, it would not ask that option, and it would continue the installation without any prompts. Alright, so run command is basically used to run any command inside the container on the terminal that you would have ran. Okay, then you have a command called cmd. So cmd keyword is basically used to run any command that you want to run at the start of the container. Alright, and these commands run only when there is no argument specified while you're running the container. So while you're running a container, you can also specify any command that you want to run. So in case you specify a command while so for running a container, the command is docker run command that you want to run inside the container. Okay, so if you don't specify anything like we did, then in the Docker file, this command will be running when we are starting the container. Otherwise, whatever command we specify in the Docker run command, that would be running. Okay, then so this was about the cmd command line. So in this case, what we want to do is, like, remember when we started the container, we always had to go inside the container and start the Apache service manually. That is, once the image is started or once the container is started, go inside the container and type in the command service Apache 2 start, right? So that had to be done manually. But when you pass it using the command cmd, which is nothing but all the commands run on the startup time. Whenever the container will start, this command will execute automatically if you specify it under cmd. So cmd Apache CTL -d foreground would do nothing but run Apache the moment the container starts, and this is exactly what we want, right? So this is possible using cmd. So again, I'll repeat it. cmd is used to run commands at the runtime of a container, and they run only when there is no argument specified in the docker run command. If there is no argument specified, the cmd command will run, otherwise it will be skipped from the Docker file. Alright, the next command is entry point. Now entry point is exactly the same as cmd, that is it runs at the starting of the container, but the only difference is cmd will not run if you specify an argument in docker run, but entry point will run irrespective of the fact whether you have specified an argument or not. Alright, so cmd and entry point can be used interchangeably, but if there are cases when you'll be running the container with an argument, so it's better to use entry point so that the command does not get skipped. cmd command will get skipped if you specify an argument after the docker run command. Okay, so in our case, we use the Apache CTL -d foreground with the entry point command. Alright, the next command is env. So if there are any environment variables that you want to set inside a container, you can pass it using the command env space the name of the variable and space the value of the variable. Alright, so in my case, I specified a variable name which has the value DevOps Intellipaat. Alright, so these are some of the commands that you can use to create a Docker file. Now let us create this Docker file on our system as well. So what I'm going to do is I'm gonna go to my putty software and I'm gonna specify nano and then Docker file. So let me just create a directory first. So let me create a directory called Docker file itself. So mkdir Docker file. Let us go inside it. So cd Docker file, and now whenever you are creating a Docker file, the name of the file always has to be Docker file itself, right? So I'll specify nano and then Docker file, We went inside. So the first thing that we want to do is we want the Ubuntu image to be called. Then we want to update this image. So apt get update. Then we want to install Apache inside it. apt get -y. Sorry about that. So apt get -y, install Apache 2. Alright, sounds good. Then we are going to add all the files from this directory to the directory var www.html. So we're going to create this file. Do not worry, we'll just create this file. Right, once we have done that, the next step would be to run Apache in the foreground, that is run it. So Apache ctl -d foreground. So this would run Apache automatically. Okay, and you specify the entry point and say I also want to specify environment variable. Say let me create an environment variable called name, and I want to specify the value as Intellipaat. Okay, sounds good. So this is my Docker file, and I'll just save this now. And let me create a HTML file as well. So let's create one.html, and let us make it a little simple. So this would be a hello world HTML file. Okay, the body, and in the body say I have an h1 which will say hello from Intellipaat. Close the header, close the body, and then close the HTML. Alright, this is what I want to do. I'll save this, and now we are done with the Docker file, and we have the HTML page in place. So the next step would be to build this Docker file. Now let's see how we can build it. So for building this Docker file, all you have to do is docker build. Where do you want to build it? I want to build it from the current directory, and the image that it will create, I want to name that image as say new underscore Docker file. Okay, so it will be named like this. So I'll hit enter, and I forgot to mention sudo. So let me just clear the screen. Alright, so let me first teach you guys how to run a Docker command without sudo. So for doing that, just type in sudo usermod -ang, and then docker, and then $user. Enter, and now all I have to do is just re-log in into your session, and this should work. So if I do a docker ps now without sudo, you can see the command is running. Awesome. So what I want to do is I want to go inside the Docker file. Okay, and now I want to build this Docker file. So docker build .-t new underscore Docker file. So you can see the Docker file is now being executed, and basically this is creating the container for me, and this will basically come up with an image which will have all the changes that we just told to the container. So now if I do a docker images, I can see that there is a new image which has been created, which is new underscore Docker file. So let us run this new underscore Docker file. Docker run -it-d. Also let us specify the port number. So let us open it at port 84 and then -d new underscore Docker file and then hit enter. Okay, so the container is launched now. So if I do a docker ps, I can see that a container has been launched 7 seconds ago. Awesome. And it being opened on port 84. So let's check if everything is working well for us. So we just have to change this to 84. And you can see Apache is running. Awesome, Apache is running. And now let's check our web page if it's there in the container or not. So we named it as 1.html. And yes, so this is the HTML that we created, which has been added inside the container. So let me show you inside the container what exactly happened. Okay, so docker exec -it container name and then bash, and let me just clear the screen. Okay, and let me compare it with my docker file. So the first thing that we did was apt-get update apt-get -y install apache 2. This basically installed Apache, so this was clear. Then we added everything from the current directory to where www.html, right? So if we go inside where and then www and then html and do an ls over there, you can see that the 1.html file has been added, and at the same time docker file was also added. So inside the directory we had these two files, right? 1.html and docker file. So both of these were added inside the container. Now to not have docker file inside your container, what you can do is instead of dot, specify dot / and 1.html. That would solve this problem. It would only add 1.html in the container. Okay, so it added 1.html, and index.html is basically the default page of Apache that you see, right? So we added 1.html, so this was added by the docker file. At the same time, what we did again was we defined Apache to run in the foreground. So as you can see, we did not invoke the Apache service by going inside the container.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the cloud platforms are not used for DevOps implementation? A. Google Cloud. B. IBM. C. Microsoft Azure. D. Amazon Web Services. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
We just went directly to the port number that we mapped the container to, and the Apache was up and running. So that is awesome. And the last thing that we did was we defined an environment variable. So what I can do is I can echo the variable, which is $name, and you can see this is the value of the variable that is specified in the Docker file. I specify the variable names to be Intellipaat, and if I specify echo $name, this is the value that I get automatically. So this was set by the Docker file in the container image that I just created. And now what I can do is I can just exit this container, and if I want you guys to use it, all I have to do is do a Docker push to this container on my Docker hub, and you guys will also be able to access this particular container. Alright, so for that I'll just have to change the name, do a Docker push, and you should be able to use it. But I'm sure you would not be needing it, because if you pass the same commands that are written over here, you would get the exact same container that I created. Alright, so let me know if you guys face any problems in the comment section, and we'll be happy to answer all the queries for you. Alright, moving forward, now we got to know how to create Docker files. We got to know how to build images from the Docker file automatically, kind of like a script kind of thing. All right, so now let's start with our next topic, which is introduction to a Docker volume. So what is a Docker volume? So Docker volume is basically used to persist data across the lifetime of a container. For example, I demonstrated it to you guys that when you create a container, you make some changes in the file system, you delete the container and you launch it again, and the changes are not there anymore, right? So that can be fixed. So imagine it like this. For example, you're using Apache container and you have a website inside of it, and the container stops responding because of some reasons. What you do, you delete the container and you launch it again. But with that, what happens is your website content is also deleted. And if your website content is not present in this new container, it becomes a problem. So to solve these kind of problems, we came up with Docker volumes. So what Docker volumes does is it basically maps, or it basically hosts the storage outside of the container and maps it to inside the container. That is, the storage is there on the host system rather than on the container, rather than the files being written on the container itself. They are written outside the container, and that location is basically mapped inside the container. So irrespective of the fact whether the container is deleted or started again, the container which is being attached to that volume will have the same file system as that of the older container. And that is how this problem is solved, that is of persistence of data across the container lifecycle. Alright, so there are basically two ways to do it. One is called a bind mount and one is called a Docker volume. Now, what are the differences between a bind mount and a Docker volume? Let us see that. So basically a bind mount would be that, let me just come out of the directory. A bind mount would be that I mount a particular file location inside the container. Okay, for example, I created this Docker file directory, right? So what I can do is I can map this Docker file directory inside a container. Now to mount this particular Docker file folder inside my container, all I have to do is docker run -it, and then there's a flag called -v that I'll have to specify. Specify the location of the directory, which is /ubuntu/.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What does DevOps stands for? A. Development and operations. B. Drive and operations. C. Digital and operations. D. None of these. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
home/ubuntu/docker file. Now this is the location of my folder, and then what is the mount point of inside my container? So say I say it's /app, right? So I'll specify that, I'll specify -d, and then I'll specify Ubuntu. I'll hit enter and my container is now launched. Now if I go inside this container, I will be able to see that there is a folder called /app which has been created, right? So if I go to app and if I do an ls, you can see the folder, the files inside this container are that of the Docker file. Now these files are not actually copied inside the container, but these are actually being mirrored from the directory on the host operating system. That is, if I duplicate this session.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Let me just duplicate this session. So I'll just go inside the directory Docker file, right? If I do an ls and say I touch a file, say 2.html, right? So if I do a ls in the container now, I can see that there is one more file, 2.html, right? So it is inside the container. So whatever changes I make inside this directory will automatically or dynamically be available inside this container. Okay, the reason for that is that this directory is mapped to the directory /app in the container. All right, so this is called bind mount. But there's a disadvantage with this. The disadvantage is that a bind mount will only work when the file system is the same that you have specified, like over here in this container, right? For example, what can happen is I can specify this bind mount to be in the configuration of the container, and I can push it to Docker Hub. So anyone who is downloading this container will automatically have this bind mount on his operating system. But the problem which will arise is that, say you download this container on a Windows operating system, right? In the Windows operating system, this file path that I gave /home/ubuntu/docker file is not going to exist, and that is where it is going to give you an error, and it will cause you a problem, right? So this way of persisting data is a little difficult, or is a little I'd say complex when it comes to different environment setups, when you're dealing with different environments. For example, if I have to talk about, say, a different operating system, say I want to work in CentOS, so in that the file structure would be a little different, right? For any other operating system it will be a little different. For Windows it is completely different, right? So a bind mount will not work in different environments, and that is where it has a disadvantage. But then this advantage is basically overcome by volumes. Now what are volumes? Volumes are basically entities, or are basically storage which is managed by Docker. Bind mounts are not managed by Docker, because you create the directory, you decide which directory your data is going to reside in, right? And inside that directory you are making the changes, and that is being reflected in the container. But if you create a volume, the Docker engine which has been installed on the host operating system automatically identifies where this volume has to exist, okay, and then creates that volume over there. Also, in bind mount it is a little difficult to basically migrate the data. In volumes it is very easy. You just take the volume up and then just put it on some other system and it will work. But in case of bind mounts, you will have to decide at which place you want to keep it, and then bind that place to the container. Only in that case it will work, right? Let me show you what happens in case of a volume. Right? So in case of a volume, if you want to create a volume, this is the syntax. So the syntax is docker volume create and then name of the volume. So let me show you how you can create it. So let me just docker volume create, and let us create a volume, say test. Okay. So this would create a volume called test, as you can see over there. Ignore the warning, guys. So this created a volume test, and if you want to see all the volumes which are present on your system, you can pass the command docker volume ls, and this would give you all the volumes which are present on your system. So on my system right now, only the test volume is present. I don't want to have to know where is it present, because Docker manages the handling part of the file system itself. I don't have to worry about that. I just want to know that if there is a volume. So yes, there's a volume on my system which is called test. Awesome. Alright, so the next thing that I have to do is basically I'll have to type this command docker run -it -mount. And so basically, if I were to give you the syntax, this is the syntax for mounting a volume. So docker run -it -mount. Source would be equal to the name of the volume. So in our case, the name of the volume is test. Then the target would be where do you want to mount it inside the container. So we want to mount it inside /app. Right, and then -d and then the image name. Alright, so once the container is launched, now what we can do is we can go inside this container to check if everything is working fine, and we'll go inside app and do an ls. So there's nothing inside this volume as of now, right? So what we can do, we can create, say, touch, then 1.html, and then touch 2.html. We can do all this, and then what we can do, we can also duplicate the session. Let me just duplicate the session, and what I'm going to do now is I'm going to launch one more container. Okay, so I'm going to launch docker run -it -mount, and then say source is equal to test, and target could be some other folder as well, but for the sake of simplicity, let's keep /app, and then -d and ubuntu. This would launch one more container, right? Let's go inside this container, docker exec -it, this, and then bash. Okay, let's go inside app. If I do an ls, you can see that whatever changes I'm making in this volume is also being reflected in this container. So say I create 3.html over here. If I go here and do an ls, I can see the 3.html as well. Alright, so this volume is basically being shared between two containers. Even a bind mount can be shared between two or more containers. A volume can be shared between two or more containers. But in case of volume, you do not have to worry where your volume is being stored. It is automatically handled by the Docker engine. Okay. The other cool thing over here is that if you delete this container and launch it again, it'll all be the container, or your end user will not even realize if anything changed. For that, let me give you an example. So let me just exit this container, and we created a image called new_docker file. Okay, so what I'm gonna do is I'm gonna launch docker run -it, and then source, say, is equal to let me create one more volume, docker volume create, and let us create a volume for Apache. Okay, now what I'm going to do is I'm going to launch docker run -it, and then -mount. Source would be Apache. Now look at this closely, you will get the difference. So source is Apache, and what I want to do is I want to target this particular directory var www and then html. So whatever would be inside this directory will automatically come inside the volume. Okay, so I don't have to add anything into the volume, and I'll show you how to do that. So you specify this -d new_docker file. This was our image name, and let us hit enter. So it created the container. Let's go inside this docker exec -it, and then this container, and then bash. Okay, so we are inside the container now. Now if I go to cd var www html and do an ls, you can see the files are still here, but these files are also now mounted on the volume, and that is evident over here. So if I exit this container and if I launch a new container with the mount as Apache, and target would be, say, /app, and the image is this. Okay, so this is the Ubuntu image, right? So it should not have the files inside it, but if I go inside this container now, can you see the files over here are same as what was there inside this container, var/www/html. Okay, now the beauty is this, guys, that if I come out, say I create a 2.html over here, right? So what I do is I come out of this directory, okay, and what I do is I create nano do.html. I create a file, and then I specify that HTML body h1. This is the new HTML file. Close the header, close the body, close the HTML, come out. Okay. Now I want to copy this tool.html inside this container. So what I will do, I'll do a docker cp dot slash to.html and then slash var slash www slash html and then the container id. Slash var slash www slash html. Okay, so now to.html is present inside the container. Okay, now what I will do, I'll just delete the container. I'll delete the new underscore docker file container, docker rm -f delete. Okay, so ideally if I now launch a new docker run -it -mount source is equal to Apache, target is equal to slash var slash www slash html. Okay, and hyphen p also we specify that we want 81 port to be exposed, and hyphen d and then the image name new underscore docker file. So what will happen now is this, that if I go on the browser, if I go to port 81, the container is running. If I go to to.html, you can see that the new file is also there in this container, that is new underscore docker file. So it does not matter if your container has the file or not. If you have mounted the volume and that volume at some point had that file inside it will have it inside this container as well. Okay, originally inside this image you don't have the to.html, right? And let me prove that to you as well. So if I do not mount the volume and I launch this container,
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
right? So if I go to this IP address but on page 82, you can see the container is up and running. If I go to to.html, it will say to.html was not found on this server. Reason being, the volume is not attached to this server. This file only has one.html that we wrote using the docker file, right? For volume, we have it attached in the container which is mapped to port 81, and that has the file 2.html, which is this. So awesome, guys, we have successfully understood what docker volumes are, and I am sure that you guys have also understood. If there are any doubts, guys, you can mention it in the comment box and we'll be more than happy to help you out with your doubt. Alright, so with that, guys, now we come to the next topic of our session, which is how are microservices relevant, right? So till now we have seen how we can deploy a single container and do things with it. But usually in a production grade environment, we have multiple Docker containers which are working with each other. Now, why do we have that? Let us understand that using this topic. So first let's understand what is a monolithic application. So guys, a monolithic application is an application which has everything inside one particular program, right? For example, let us take the scenario of an Uber app. So our Uber app has things like notification, we have things like mail, payments, location services, customer service, and passenger management. This is there inside one app, right? You can see all of these things inside one app. So if you can see it inside one app, that does not necessarily mean that it is actually one program of Uber that they have written, right? But for now, let's consider everything is under one program. When I say one program, probably you have written a Java file, or you have written a C file, and everything is there in that C file, or everything is there in the project in different files. Basically, everything is there on one server, is what I mean, right? So if that is the scenario, what will happen? That if I want to change code in notifications, I will have to pull the whole code base. I will have to go to the notifications file, and I have to change the code over there, and then I have to push the whole code again back to GitHub, which will basically get deployed on production after being tested and everything, right? But the problem over here is that if there is any problem in the notifications code that I just changed, it will have a repercussion on all the components of my app, right? There could be that I did a mistake and probably there is something wrong with the mail program now. Although my intention was not to touch the mail program, but because I had to work with the code base which had everything, probably something went wrong over here, or something went wrong over here, or something went wrong over here. So this was a problem with a monolithic application. That is, that you had to submit the whole code base, even if you had to change the minimest thing that is there in the code, right? And this also led to downtime, because when you are changing the code base, there will be a certain amount of downtime that will occur. And there is also a lot of risk, because like I said, the other files of the same project could be impacted. For example, in our case, I said that if notifications, or say if location services is not working, probably it will have an effect on payments, or it will have an effect on mail. If the code is related to each other, or if a function is being called from each other, etc., etc. That is how a normal a program is. In one file you define a function, in the second file you're basically calling that function. That happens, right? So all of these are dependent on each other, and whenever the components, whenever the modules, so all of these small things like notifications, mail, payments, passenger management, customers, or these are all small modules of a program. If these modules are interdependent to each other, it will be called a monolithic application, right? But when we talk about the disadvantages of a monolithic application, they are the following. So like I said, if the application is large and complex, it will be very difficult to understand. So if your Uber app is now having more and more features, and if someone has to add a new feature, he first has to understand all the dependencies between the components, right? He has to understand the whole code base, and then only he can add a feature as to understanding what will be the repercussions, or what all files he or her has to handle if he's going to put a code inside the code base, right? So it is a little difficult to understand. Second thing is, the whole application is redeployed. So like I said, the whole code is again deployed, and then there will be a certain amount of downtime which will be pertained to you updating the application, right? The third thing is, if there is bug in any of the module, and because in a monolithic application everything is dependent on each other, it can lead to an entire downtime of your whole application, right? It can bring down your entire application just because of a bug in a single module. So this is also a problem in monolithic application, because the components are dependent on each other. And the last one being, it has a barrier to adopting new technologies. And this basically means, say your notification code is in Java, and your and your passenger data program, because it's a monolithic application, also has to be in Java. all of your modules that you're defining, all of the features that you have defined have to be in one particular language. That is what a monolithic application means, right? So there was a restriction to adopting new technologies as well. So it could not be like one module of mine is written in some other language, the other module is written in some other language. This was what a monolithic application was.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What are the key components of DevOps? A. Continuous integration. B. Continuous testing. C. Continuous delivery and monitoring. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now, to solve this, we came up with the microservices architecture. Now, what is a microservices architecture? Each and every module, that is a customer services function or the notifications function or the mail function, the payments function, passenger management function, location services function, they're all segregated from each other. They all exist independently. That is, they're not dependent on each other. So if they have to interact, obviously they'll have to interact with each other. For example, in Uber, until and unless you don't make the payment, you will not be allowed to book a cab. Right? So still communication has to be there between these two components. That is, the payment and the booking has to be communicating with each other. But now they don't have to communicate through in between the program. They can communicate through probably HTTP ways, or by hitting the API of each other. They can do that by probably sending JSON to each other and stuff like that. So they can communicate in that way. They don't have to communicate from within the program. And that is the beauty of microservices, that the services that we are defining now are not dependent on each other. For example, say if the notifications is not working, the notifications module is not working, then in that case, it's not like your Uber app will go down. Probably in that case, it will say our notifications is having some problems, but you can still book a cab. You'll still be able to book a cab because booking of cab is nowhere related to notifications. But if we compare it to a monolithic application, in that case, because the code was dependent, and if there was something wrong in the notifications app, the whole application could come down. Right? Because the code was not isolated to their member functions or to the member modules. But now, because each and every function of the application can exist on a different server altogether, the downtime of the application becomes almost zero when we have to update a feature. For example, if a developer has to update a feature in, say, the payments app, for example, he has to add a new payment method, he will only download the code base for the payments app, make the changes over there, update the code on the payments module, and if there are any problems, there will be problems only to the payments module. The other services will not be affected. Okay, and this is what microservices are. Now, you might be wondering that this is a Docker session. Why and how are these microservices related to Docker? So to answer that question, these applications, all these microservices are deployed on Docker containers. Okay, so all these act as separate entities, and these containers then interact with each other. And now this also solves the problem of barrier of adopting of new technologies. Reason being, your containers could be of different technologies. For example, your customer service could be written in Python, your notifications could be written in Java. But if your customer service and notifications programs have to interact with each other, they can interact through JSON. JSON is a way of writing a file, just like we have CSVs, wherein values are separated by commas. In JSON, you have a structure, right? Any kind of program, be it any language, can convert a file into JSON, probably using libraries or having inbuilt functions for that, right? And then pass it on to the other service which has to read the information. So with microservices, our problem of barrier restriction, of technology restriction was also solved. So the advantages would be, because the application is distributed, can be understood really well. It is not like if a developer has to work on a particular feature, he has to understand all the features of the application. He should know which application should he or which modules of the program should that particular program that he's developing communicate to, and that all he has to know, and of course the code of his own function as well, right? And of course if he makes any changes and if he makes any bugs also in the program, it will not affect the whole application. It will probably affect only that function which he is creating. Okay, I guess we have covered all the advantages. So the first one being easy to understand, then the code which has to change will only be changed for the microservices which has to be worked on. Then the bug in one service will not get into all the components of the application. It will only be isolated to that particular function. And of course you can use any technology that you want with the microservice that you are working with. Okay, and all of this is possible using containerization. Okay, now because we were talking about deploying multiple containers, we have to talk about how to deploy them using Docker Compose. Now, if we want to deploy multiple containers, till what we have learned so far, the only way to do this is by either using Docker run, or probably creating a script file which will build multiple Docker files and then hence build those images. But there is even a shorter way to basically build images and run them, and that is possible using Docker Compose. Now, what is Docker Compose? Docker Compose is basically a tool which can be used with Docker to create multiple containers at once, create and configure multiple creators at once with a single command, right? And the way you can do that is by writing a YAML file, right? So you write a YAML file with all the configuration required for the containers. And of course, I'm talking about containers, that is more than one containers. You can have 100 containers also that you can launch with one single command using the Docker Compose file. Okay, and this Docker Compose file is written using a YAML format. Now we are working with us. Now, if I want to demonstrate the power of Docker Compose to you, I can do that using a sample Docker file that I have created. So this sample Docker file, what will it do? It will basically deploy a WordPress website. Now a WordPress website has a lot of dependencies, guys. It has to has MySQL in the backend. It has to have the WordPress container in the front end. And of course you'll have to configure the DB password and everything inside the container as well, right? Now one way of doing it is doing manually, that installing WordPress and then configuring the variables inside it and then doing the same with MySQL. But there's a shorter way to do that, and that way is using Docker Compose. Now this Docker Compose file has actually been written in YAML file. So if I were to take you through it, the version of the Docker Compose file is version 3.3, and there are basically two kinds of containers that we are launching. The first kind of container is the DB container, and the second type of container is the WordPress container. Okay, so the first we launched DB container, and the image that we are trying to pull for the DB container is MySQL 5.7. Okay, in the MySQL 5.7 container, we are defining a volume which is DB underscore data, and this is the target of the inside the container where it should be mounted. That is var live MySQL. Okay, so the environment variables for this container are MySQL root password, that is MySQL data, MySQL user, MySQL password. These are the values to these environment variables that we are also configuring inside the Docker Compose file itself, right? So inside this container, these are the environment values which will be configured. And then, so this is the end of it. This is what we have done in the DB container. Now we are talking about the WordPress container, in which we specify that it depends on DB, which this will basically create a link between the WordPress container and the MySQL container or the DB container, right? And with this, the WordPress container will be able to communicate with the DB container. Then we specified the image of the container that we want to download. So it's WordPress, and that to the latest version. The ports that we want to expose, so inside the container, the WordPress is available on port 80, and we are mapping it on the host with port 8000. Okay, and then the environment variables we specify that the WordPress DB host is DB colon 3306. So DB is basically the host name for this service that just got created, which has MySQL inside of it, and MySQL is always available on 3306 port number. So that we specify over here. Then we have the WordPress DB user. So we specified the DB user, that is the MySQL database user, as WordPress. So that is exactly the same value that we're specifying over here. And the DB password is again WordPress, and that is also that we specified over here. Okay. And what else? So this is it. And after that, we specify that the volume which has to be created is DB data. So this is for the whole YAML file. That there's a volume which is being created, which is called DB data. Now this is a YAML file which will create two containers, which will configure it, and then this will happen in like 3 seconds, right? So let us go ahead and try this sample Docker file out. But before that, Docker Compose, guys, actually has to be installed on the system, irrespective of the fact whether you have installed Docker or not. Right? So Docker, when you install, it does not install Docker Compose automatically, except the users who have installed it on Windows and Mac using Docker Toolbox. If you installed using Docker Toolbox, it has everything installed. But if you have installed it on Linux and you have just installed docker.io, it will just install the community edition version and the Docker Swarm. Docker Compose is not installed by default. Now to install Docker Compose, all you have to do is, let me first demonstrate it to you that Docker Compose is not present. So Docker Compose hyphen version. So you can see it is not there as of now. So what I can do, I can go to my browser. I will search for install Docker Compose, and the first link is basically the official link. Alright, so for installing it on Linux, just click on Linux, and these are the commands for installing Compose. So first we'll copy this command, that is, we'll have to curl the file. So the file has been curled now, and then we'll have to change the permissions for it, for the file which has just been downloaded, to be converted into an executable file. And that's it. And now if I run Docker Compose version, I can see that the Docker Compose version is 1.23.1 and the build is this. So Docker Compose has been installed automatically. Now the next step is to basically create a YAML file. So for that, let us create a YAML file for, so let me first create a directory. So it would be compose. Let's get inside compose, and now let's create a YAML file for WordPress dot YAML. Okay, and if you basically, this WordPress compose file is available on Docker Docs, so you can directly go here and you can try this YAML file on your own as well. Just copy this YAML file, paste it into your YAML file that you are creating, and then save it. Just let's verify if everything has copied correctly. So yes, it has. And now finally save this YAML file and then pass the command. Okay, so there's one more thing that I want you to know, but that will be evident from the error, which is that the Docker Compose file has to be named a proper, has to have a proper name. For example, if I pass the command Docker Compose, for basically running your Docker Compose YAML file, the command is Docker Compose up and then -d. You pass it, and then it'll give you an error, can't find a suitable configuration file in this directory, right? So it says that file can only be of this name, dockercompose.yaml or dockercompose.yaml, right? So what we're going to do, we'll just name it the same. So I'll just rename the file to be dockercompose.yaml. Okay, so the file has now been renamed, and now let's pass the command docker compose up -d. I'll hit enter, and as you can see, everything has started automatically, and it is pulling the containers as of now. Once it has pulled the containers, it will start configuring the container. So db container has been completed. Now it is downloading the WordPress container, and then it will configure it. And once the configuration has been done, yes, so it's done. So our WordPress website is now up, and all we have to do is go to the EC2 dashboard, go to the running instances. So these are the instances that we launched. This is my instance. I'll just copy the IP address, and WordPress would be available on port 8000. Hit enter, and here you go. So website is up and running, and if I go on continue, I just have to specify the value. So let's keep the site title as Intellipaat, username as Intellipaat as well. Password would be Intel123, and then your email, so it would let it be something random, intellipaat@intellipaat.com, and we'll click on install WordPress, login, and then username or password. So let us specify it as the same that we gave, right? And now if it logs in, that basically means that it is being able to communicate with the database as well, right? So your WordPress website is all up and running. It is now configured with your MySQL database, and that is how it is interacting. And this is your dashboard. This is basically from your WordPress container. Your data is all being stored on the MySQL container, and this is a classic case of a multi-tier app that you have just launched on Docker Compose. So if I do a docker ps, you can easily see that this is the WordPress container which is running, right? And it is being exposed on port 8000. And then you have this MySQL container which is running, which is being exposed on port 3306, on which this WordPress container is being able to interact. Alright, so guys, this was how you can launch multiple containers at once using Docker Compose, and this is also kind of like a microservice, although this can be further be broken down, but those broken down services can also be launched through Docker Compose, and everything can be configured in the Docker Compose YAML file itself. Alright, but again, microservices are actually not launched through Docker Compose. They are basically put on something called as a container orchestration tool. So what is exactly a container orchestration tool? Right? So a container orchestration tool is when you have multiple containers that you have launched and you want to monitor their health as well. For example, if I come back to this example that we just did, what I'll do, I'll just docker rm -f, and I'll specify the container ID. I'll hit enter. The container is removed, right? And now when I go over here and if I hit enter, it'll say the site can't be reached. If I hit enter again, it'll again say the same thing because your site is gone. You accidentally removed your container, or your container stopped working because of some reason, and now you're not able to access your container. Your website is down, it's gone. This was a problem which was there with traditional methods of using containers or microservices on Docker. But then there was something called as container orchestration, which became very popular, which basically says that all your containers' health will be monitored by Docker itself. So if there is a container which goes down, if there is a container which is not healthy anymore, what Docker Swarm does is it automatically repairs it by stopping the container and launching a new one in place of it, and the end user will not even realize what happened. Alright, so this automation led to what we today known as container orchestration. Now there are a lot of container orchestration tools. With Docker, pre-packaged comes Docker Swarm. So we're going to discuss Docker Swarm now. So what is Docker Swarm? So it's basically a clustering and scheduling tool which is used for container orchestration of Docker containers. And with Docker Swarm, you get the functionality of automatically monitoring the health of containers, and it helps you keep a healthy number of containers that you have specified always in the running state. That is the basic aim of having a Docker Swarm up and running. Now, how does a Docker Swarm basically work? So a Docker Swarm basically works like this. So a Docker Swarm cannot work with just one machine. All right. So because like containers, even machines can be faulty sometimes. Maybe you have configured Docker Swarm on a single machine, which can automatically repair containers. But what happens if the machine goes down? Right? So to mitigate those kind of things as well, we came up with distributed kind of an architecture wherein you have multiple machines running in the swarm. So there in the swarm there will be one machine which will be called as the leader, which will basically tell the workers what to do, and the workers will have the containers running on them, right? So you have the leader like we have it over here, and then you have multiple workers which are running on the cluster, and these workers will run the containers that we want to launch. So this was about Docker Swarm, but this is not it. Let's go ahead and start a container, or let us go ahead and start a cluster using Docker Swarm. So let us see how we can do that. So for that, let's go ahead and first launch a machine on AWS. So we have the master. Let us launch a worker. So for that, let us launch an Ubuntu system.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Okay, so now our Ubuntu system is now launching. Let's name this instance as a worker. Okay, so while this is launching, you'll have to do some steps on your leader. So say this is the instance that I want to become the leader for my Docker Swarm cluster. So what I'll have to do, I'll have to say Docker Swarm init, and then I'll have to specify the advertise address. So advertise address is basically the private IP address of the instance. So in my case, the instance is, this is the private IP of my instance, right? So I'll have to specify this over here, and then I'll hit enter. So with this, you will get this command: swarm is initialized, current node is this, and it is now a manager. So manager is nothing but a leader. Okay, and for any node which has to join to this manager, they'll have to pass this command, that is Docker Swarm join, and then this command that they'll have to pass. So for this, so basically I'll have to log in to this particular worker of mine to install Docker first, and then we'll go ahead and join it to the cluster. And let me make the font a little bigger so that you can also see what I'm typing. Okay, great. So this is my instance. Now what I'll have to do, I'll have to first install Docker. So let me do an update first. So Docker is updated. Now let me, the machine is updated. Now let me install Docker. So sudo apt get install docker.io. Alright, so Docker is installed. Let us verify that by typing sudo docker version. Great, so Docker is installed. Now Swarm is automatically installed when you install Docker. So all you have to do now is go here, copy this command and paste it over here, right? And also while we are doing that, I'll have to open the ports for these instances to interact with each other. So let me put all traffic over here, and now my instances should be able to interact. So I'll just pass the command here and hit enter. Alright, so I've figured out what the problem was. The problem was I've not specified the address correctly. So my master is basically on this IP address. So let me copy that and let me pass the command again. Now this is the command that we get. Let us copy this. Let us paste it over here. Hit enter. And you can see it says this node joined as a swarm worker. Alright, awesome. Now if I go here and I do a docker node ls, you can see that I have two nodes which are there. This is my current node, which is the leader, and it's in the ready state, and so is the second node, which is also in the ready state and is joined the swarm. So this is how you can create a Docker Swarm cluster, guys. So again, to be very clear, the first thing that you'll have to do is do a Docker Swarm init on the master node. Then you'll get a command. Just pass that command on the worker, and your worker will directly connect to your master. Now, if you want to leave the cluster, all you have to do is say sudo docker swarm leave, and you can see it will say node left the swarm. And if you do a docker node ls on the master, it will, in a few moments, when the health checkup has failed, it will say the status is down for this particular node. Okay, if you want even the master to leave the swarm, all you have to do is pass the command docker swarm leave on the master as well. Now, as you can see over here, this node, because it has left, the status is now down, which basically means that the node is no longer reachable. Okay, now if you want the master to also leave the swarm cluster, all you have to do is say docker swarm leave and then say -- force, keep enter, and it'll say node left the swarm, and your swarm cluster has now been left. Okay, so this is how you can go ahead and create a docker swarm cluster. And the command, like I said, is docker swarm init advertise address equal to IP address of leader. Specify that, hit enter, and just copy this command on the worker, and it will work like a charm. Alright, so our next step is now to deploy an app on the Docker Swarm. So before that, let me quickly launch the Swarm cluster again. Docker Swarm init advertise address and specify the IP address of the master, which is this. So this is the IP address. Just specify that, hit enter, and then copy this command and pass it on the worker. Okay, and if I do a docker node ls over here, you can see the cluster is ready. Awesome. Now what I want to do, I want to deploy an app on Docker Swarm, but before that we'll have to understand how does an application actually work on Docker Swarm. So an application works something like this. So basically you create services on Docker Swarm, and that service will basically create containers for you for that particular image that you have specified, right? So alright, so let's go ahead and create a service. So guys, this is the syntax for creating a service in Docker Swarm. What we'll have to do is we'll have to type in docker service create, and then specify the name of the service. Say I want the name of the service to be Apache, and then specify the number of replicas that we want to run. So say I want to run 5 replicas, and then the port mapping. So basically I want it to be launched on port 83, right? And then the name of the image. So say I'm launching it on hshar/web app. Okay, I hit enter. It'll run 5 containers. It'll verify if everything is running fine, and once everything is running great, it'll exit. So now if you want to see what all services are running on your Swarm cluster, all you have to do is say docker swarm service ls, docker service ls, and it will show you that this is the service which is running. It is running in the mode replicated, right? And it has 5 to 5 replicas running, and this is the image name. Now I'll show you a very awesome thing. So basically this port is 83 is exposed, right? So what I'll do, I'll go to the master's IP address, which is this. I'll go here, I'll type this, I'll go to port 83. Alright, this is working. Now what I'll do, I will go here, I will go to the worker, I will again go to the worker's IP address, and I will go to port 83. Awesome, isn't it? So basically in Swarm, any IP address, either of the master or of the worker that you go on, they will have the application ready on both the servers on port 83. And the most awesome thing is that I showed you guys that if I do a docker ps over here, I can see that there are out of 5 containers, there are 2 containers which are running on the leader, and there should be 2 containers running over here on the worker. So there are 3 containers running over here. So what I can do is I will basically just do a sudo docker rm-f, and what I'll do, I'll remove all the containers. Removed. And if I go to my master's IP address again and hit enter, I still have the containers running over here, right? Similarly, if I go here sudo docker rm-f, and then I say I want to remove everything. I forgot the sudo over here. It removed 3 containers, but if I go to my web browser and refresh the worker's IP address, I still have the container running over here, right? This basically means that my containers are being auto-scaled, which means if they get deleted, it again gets created. So you can see I deleted the containers over here, but if I do a docker ps again, can you see it has 3 containers now launched? And I guess if you go on the worker and do a ps over here, now it should have 2 containers, exactly as we saw, right? So it automatically creates the containers again, and it will always maintain the number of replicas to be 5, because that is what you have specified, right? That is what it will always retain. Now you can always scale the replicas, and for that all you have to do is docker service scale Apache, and then just specify the number of replicas that you want. Say I want only 2 replicas to be there. I'll hit enter, and then what it'll do, it'll basically scale down to only 2 replicas. Now if I do a service ps, docker service ls, you can see there are only 2 replicas running now. So if I do a docker ps here, I have 1 container over here, and if I do a docker ps here, I have 1 container running over here. Alright, so you can also scale up and scale. I can also scale up, right? So I can again just go over here and type in the command 10. It'll start 10 containers for that web app, right? And you can verify that. You can verify if I do a sudo docker ps over here, it has around 5 containers here, and if I do a docker ps here, it has around 5 containers here. If you want to remove a service, if you want to remove an application from the cluster, all you have to do is docker service rm and then specify the name of the service, and it will remove that service. And now if I do a docker ps, it should slowly remove everything out of here. So it's docker ps again. Slowly it will remove everything from the containers. So see, the containers are gone over here, and similarly if I see here, the containers are also gone over here as well. Okay, and again, like I told you guys, if you want to leave the node, all you have to say is do sudo docker swarm leave. This node has left the swarm, it will say. And similarly, if I want to leave the master as well, all I have to say is docker swarm leave, and on the master you'll always have to force, and it'll leave the swarm as well, and then you'll have a clean machine again. All right, so this is how you can deploy an application on Docker Swarm.
Puppet is nothing but a configuration management tool which is open source in nature, right? And it helps us in basically keeping configurations consistent with what we require and what is there on our production, on our test, and our developer environments. Right now, the awesome thing about Puppet is that it can basically be installed on various platforms like Microsoft Windows, various Linux platforms, etc. Right, so it is very versatile in terms of its working on different platforms, and also it basically does not use any programming language. It has its own declarative format in which you have to specify what basically if you want to install any type of or any set of configuration on any node or any group of nodes, the way to declare that is not dependent on any programming language. So Puppet has its own declarative language using which you can describe what kind of configurations you want on your slave nodes. Okay, so this is what Puppet is all about. Now, there are some key features of Puppet which we are going to discuss next. So, what makes Puppet so special? Why is Puppet so popular? So, the first and foremost reason that companies adopt Puppet is because a lot of other companies have also adopted Puppet, and basically it is a tried and tested tool which helps every company in its configuration management needs. Right, so Puppet has established itself in providing the configuration management needs, and therefore companies who are newly coming up and are trying to adopt configuration management, they prefer Puppet because a lot of other companies are also using it. The second point is that there is a lot of, Puppet being an open source tool, there's a very big community for Puppet which constantly keeps working on Puppet and keeps on adding features, keeps on resolving bugs, which makes the Puppet tool in itself very mature, right? Why mature? Because if there is a tool which is privately owned by a company, obviously the kind of work which will happen on that tool versus what is happening on Puppet, it's going to be slow. Reason being, there are a lot of people who are working on Puppet, there are a lot of people who are enthusiasts, right, who are not being paid, they're just doing it because they love working on.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the cloud platforms are not used for DevOps implementation? A. Google Cloud. B. IBM. C. Microsoft Azure. D. Amazon Web Services. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Or they love their profession and they love working on this tool which is Puppet, right? And out of that love, they create features, they resolve bugs. So the quality of features and the quality that this tool has to offer is more than what a private company can produce, right? So therefore, this is a key feature of Puppet, that there's a large open source community for Puppet which basically keeps on adding features, keeps on resolving bugs, and keeps the Puppet software in its most optimal state, right? The third thing is documentation. So documentation is very important for anyone who is trying to learn this tool, and there is an extensive documentation available for Puppet on their official website, right? So if you don't understand Puppet, you don't have to take help from your colleague. You don't have to search for tutorials. Just go to the Puppet online website and they have an extensive documentation on literally anything that you want to do with the Puppet software. Okay. And the fourth thing, which we have already discussed but is very crucial for its success, is platform support. Right? So Puppet can be used on Unix based systems, it can be used on Mac OS, it can be used on Microsoft Windows, it can be used anywhere. And because of this versatility of it being installed anywhere, it is very popular among companies where where the fleet of servers are on different platforms, right? Their web server could be on CentOS, their DB servers could be on Ubuntu, so on and so forth. You could have multiple environments or multiple platforms in your company which are basically serving different purposes, but Puppet as a software can be installed on all of them, and your configuration management need is solved because of that, right? So these were some of the key features of Puppet, why Puppet is so popular, right? So now enough of bragging about why Puppet is so great. In our next session, we're going to start with the core part of Puppet, right, which is the Puppet architecture. So before dwelling into how Puppet actually works or getting our hands onto the Puppet software, we're going to look at how the Puppet architecture basically works, or how Puppet internally works, with this slide which talks about the master and the slave. So the core part of the architecture of Puppet is the master-slave architecture. So there is one master and there could be numerous slaves which are being served by the master, right? So what happens basically, because Puppet is a pull configuration type of configuration management tool, so everything is initialized by the slave, right? So the way Puppet works is, so first the slave basically sends its state to the master, right? So when the master slave architecture is set up and everything is set, if there is any change on the master or if there is no change on the master also, the slave of Puppet, it time and again sends its state information to the master, and what master does is it checks whether the state sent by the slave is what is required from the slave or not, right? So there is a state for that particular slave which is defined on the master, right? So it checks against the state defined on the master whether the state is same or not. If the state is not same, if there is a change in the state, what master does is it sends the change catalog to their slave and tells the slave, okay, so these are the softwares and these are the versions that you have to install on yourself, right? So the Puppet agent then installs all these tools on itself or on the Puppet slave. And once it installs everything, it sends back a report to the master saying that, everything has been installed. Please check whether your requirements are now being met with my state or my metadata, which I'm sending it to you, right? So in the third and final step, master checks whether all the state is matching with what the requirements have been specified in its manifests, right? So this is a 3-step working of how the Puppet master and slave interact when there is a change which is supposed to happen on the slave. Similarly, now because there's a lot of communication or there's a lot of back and forth which happens between the Puppet master and Puppet slave, the communication which happens between these nodes is encrypted, and it is encrypted using SSL certificates, right? So there's an SSL connection which is established between the Puppet master and the Puppet slave, and the way it works is something like this, right? Now for SSL connection, we need certificates, right? So the first thing which happens is, because Puppet being a pull configuration type of tool, the Puppet slave first requests for the master certificate from the Puppet master, right? And which in turn the Puppet master, it sends the certificate back to the Puppet slave. So this happens instantaneously. Any slave which asks the Puppet master about its certificate, the master sends its certificate to the slave. But this is not where the connection has been established. Now what happens is, the moment master sends its certificate to slave, master also requests for the slave certificate, right? It requests a slave node to give master the certificate, and slave obliges for this request and sends the slave certificate to the master. right? But still at this point, the communication has not been established, although the certificates have been exchanged, right? Now for the master to authenticate the slave, there is a manual step of signing the certificate that the Puppet slave is sending to the master, right? And in this step, basically the administrator or the DevOps engineer will go to the Puppet master and he shall sign the certificates of the nodes which basically he wants to attach to the Puppet master, right? Once the Puppet master signs the certificates of the slave, only then a secure connection is established, right? A encrypted connection is established, and then the exchange of data takes place. So this is how the SSL connection is basically set up between Puppet master and Puppet slave, and this will be more clear to you when we'll be setting up Puppet, which is basically our next session, where we'll be setting up a Puppet master and a Puppet slave on AWS, and we'll try to establish connection between them, and then I'll show you how you guys can basically sign certificates on Puppet master so that the connection becomes encrypted. So guys, here is my AWS management console. The first thing that I'll do is I'll have to launch an instance, right? So I'll select the Ubuntu AMI, Ubuntu 18.04. I'll select this. I'll select the t2.micro, which falls under the free tier. I'll click on next. I'll select the number of instances as 2 because I want to create one node Puppet master server setup. So I'll mention the number of instances as 2. I'll click on next, add storage, and then I'll come to security group, right? So in the security group, what you have to do is you will have to have a security group which basically will allow TCP connection, all TCP connections from the IP address of your slave, right? Either you can do this, or what you can do is you can allow a TCP connection on the port 8140 from your this particular IP address, which is of the slave, if you want to be more specific, right? But for now, what I'm going to do is I'm going to open all TCP ports and I'll say it can come from anywhere, and I'll click on review and launch. The moment you click on launch, you will be asked to specify the private key that you want to use. So I have one private key already there on my system, so I've specified that. Now basically your instances are getting launched. So let's label these instances as master, and the next one would become slave. Okay, so we've specified this. And now while they are launching, let's have a look at all the commands that we're going to use to basically install my Puppet master and slave. So guys, these are all the commands. So these commands will basically run on my master, and then these commands will run on my Puppet agent, right? And in the end, we are also going to verify if our master and agent connection is successful by basically creating a file from the master on the agent with this particular content. So don't worry about it. We'll come to this part and I'll explain you what this file basically means when we get to this part of having the file ready on our system. Okay, so for now, let's start with the master. Let's start installing master. So let's see if our instances are ready. So yes, they are in the running state. So let's connect to our master first. So this is the master IP address. I'll connect through putty, specify the private key. Now this will basically let me enter my master server. So let me just change the font settings so it becomes more clear for you. And let me choose a color for the master as well, so that we don't get confused between the master and the slave. So this is my master server. All right. So while I connect to my slave, let me just update this machine. So while this machine is getting updated, what I can do is I can connect to my slave. So this is my slave, guys. Let's connect to it using putty. So this is my IP address. Let's specify the private key as well. And now we are connected to our slave as well. Awesome. Let's change the font setting for this. Let's make it a little bigger so that you guys can also see this. All right. So now we are on our slave machine. Let's update this machine as well. All right. So meanwhile, our master is now updated. Now let's go back to our notepad to see what we have to do next. So we have to install wget first. So wget is pre-installed on AWS. We don't have to do this. Next step is basically to download this particular file. Let's do that using wget on the master. So the file is downloaded, and now let's unzip the file using this command. So the file is unzipped. Now let's install Puppet Master here. So we are installing Puppet Master. Puppet Master is now being installed. Once it's successfully installed, we can check the installation status by going to the policy. So Puppet Master is nearly installed now. And now let's check the content of the policy. So yes, Puppet Master has been successfully installed. And now what I can do is I can check the status of the Puppet Master service. So this is the service status. So it is active and running. So that's awesome. So that's what we wanted. So our Puppet Master is now installed on our system. Next thing is to basically fine tune some settings. So let's do that. So we'll edit this file, which basically are the defaults for our Puppet Master for running. Right, here we are. So basically your Puppet Master by default would use 1 GB of memory, but since our system is also 1 GB, what we are going to do, we are going to mention that the Puppet Master can only use 512 MB of the memory. So Puppet Master can work in a 512 MB memory as well if you are dealing with less number of nodes. So since this particular setup is for our demo purpose, so we can mention 512 MB for our Puppet Master, which should be enough. So we'll save the file, and now the defaults are ready. And now for applying the defaults, we'll just restart the Puppet Master over here. So Puppet Master is now restarted, and now we'll open port 8140, through which basically Puppet communicates with the slave through the firewall of the OS as well. So that's done, and we're set. So Puppet Master is successfully set now. Let's go to our slave and start setting up our slave as well. So on a slave, we have updated the machine. wget is pre-installed. We'll first download this particular file. So the file is downloaded. Let's unzip the file. The file has been unzipped. Now let's install Puppet. So earlier we installed Puppet Master. Over here we're installing Puppet, which is nothing but Puppet Agent, right? So once Puppet Agent is installed, I have to manually start it, and we can do that using this command. But before writing this command, what we have to do is we have to go to each machine and change the host file, right? So in the host file, I have to mention the IP address of the master. So we'll have to do this for both the machines. So let's specify the IP address like this, and let's specify the master's IP address in the master as well, and in the slave as well too. So we'll do a sudo nano /etc/host, specify the IP address, write Puppet in front of it, and save the file. Alright, so now we're ready to start the Puppet agent. So let's do that. So Puppet agent has now been started. Let's enable Puppet as well, which basically means on restart also Puppet will be started automatically. So this is done as well. Alright, so now some steps happened in the background which we were not able to see. What were those steps? So that was basically what we discussed. So the moment Puppet slave starts, it basically sends a request for the master certificate. How does the Puppet slave know where the master is? We just specify the IP address in the host file, right? So it knows where the Puppet master is. So it sends the request to the master. The master in turn sends the master certificate, and at the same time it also requests for the slave certificate. So this when the master requests for the slave certificate, the Puppet slave basically sends the slave certificate, and now we have to go to Puppet master basically. So we are here. We'll say sudo puppet cert list, right? So this should basically list any certificates which have been sent to the master. So let's check if we have any. So as you can see, we have a request from the Puppet slave on the master. So how do we know it's the Puppet slave? You see this IP address 172.31.44.167, and if we compare it with our slave, it's 172.31.44.167, right? So that's the slave's certificate which has been sent to the master. So we'll have to sign it now. So for that, the command is sign. And if there are more than one certificate or more than 2 or 3 certificates and you want to sign them all you have to do is sudo puppet sign and then hyphen all. Specify this and your certificate is now signed, right? So my puppet master and puppet slave can now interact with each other. So our next step is to verify this. So what we are going to do is we're going to come back over here, and now basically we are going to create a manifest. Now, what is a manifest? A manifest basically specifies what all changes have to be made on the agent or on the slave, and these are the changes that we are going to do. So basically we are creating a file which exists in this particular directory, right? So the puppet master has to ensure that this file is present on this directory, and the permissions, the read write permissions of this file is this, which is the user should be able to read write and the other users of the OS should be able to read this particular file. Okay, and what should be the content of this file? The content should basically be it works on and then the IP address of the slave. All right, so this IP address is going to change with every machine on which this file is going to exist. So this is going to be the content. So let's create this particular file. So for that, first I'll have to create a path on the master. So this is my master. Let's create a path. Path is created. Now let's edit the manifest file on the master. So this is the manifest file and the content of the file should be this. Let's copy it, paste it over here, save the file, and once the file has been saved, all you have to do is restart Puppet Master. So I'll restart Puppet Master like this. So my Puppet Master has now been restarted, and all I have to do is go to the Puppet, and since Puppet is a full configuration tool, the slave has to request for the changes. So I'll say puppet sudo puppet agent hyphen test, right? So before I run this command, I want to show you guys that basically there is no file inside temp which starts with I. So I'll go inside temp, and if I do an ls over here, you can see there's no file called it works. So now what we're going to do, I'm going to say sudo puppet agent hyphen test. So this command will basically ask the master for the is there any changes required for this particular server. The master will send the changes to the agent. The agent will make those changes and send the report back to the master. So I'll hit enter now, and now you can see that there has been some things which have been done, and you can see a file has been created in /temp. Let's verify this. So let's do an ls now. So I can see a file has been created, it works. And if I do a cat on this file, I can see the contents of this file is it works on, and then the IP address of the slave, which is this, right? So congratulations guys, your Puppet Master slave setup is now complete, right? So now you can use the Puppet Master slave to basically do configuration management. So you just have to specify the configuration on the master, and then it will be applied on the slave. All right, so the most basic or the unit of coding in Puppet is basically a resource. So what is a resource? A resource could be a file, it could be a command, it could be a package, it could be anything, right? So this is the basic thing that you define in a Puppet catalog, which basically has to be executed or placed on the agents, right? And the way to define a resource is like this. So basically first you define the resource type. So like I said, it could be a package, it could be a file, it could be anything, right? And then you define the resource name. Okay, for example, if it's a file, you'll specify the path over here. If it's a package, you'll specify the package name over here, and then you specify the attributes, whether it has to be installed, whether it has to be present there, whether it does not have to be present there, what is the permissions of the file. So all that can be declared in the attribute and the value, and then you close the brackets, which basically means that this particular resource has been finished, this particular resource has been defined. Now don't worry if you get scared, don't worry if you're basically getting scared with the syntax. So let me go ahead and show you an example which will clear things out more than what we are understanding over here. So guys, this is a sample syntax for a resource. So over here we have basically defined a package. So say you want to install Nginx on agent, all you have to do is define this resource. So what is Nginx? Nginx is basically a package. So the resource type goes package, the package name is Nginx. And what do we want with Nginx?
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What are the key components of DevOps? A. Continuous integration. B. Continuous testing. C. Continuous delivery and monitoring. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
We basically want to ensure that it is installed on the system on which we are targeting on, right? So this is how you define a resource in Puppet, and through this you can basically configure your agent's configurations using the resources. So basically whatever resources you mention gets installed on the agent. All right, moving forward now, guys, when you combine a bunch of resources, now of course when you're dealing with an agent, it's not just one resource that you will install. You could be installing hundreds or thousands of resources together, right? So all these resources combined, they have to be one entity, otherwise you'll have to define each and every resource separately, probably in a separate file. So to solve that problem, what we do is we come up with something called as manifests. So what are manifests? Manifests are nothing but a combination, or they basically group resources together, and they are defined inside one file, and that file is called the manifest file. Okay, so the manifest file can have multiple resources inside them, and once a manifest file is basically applied on an agent or on a slave, all those resources are installed one by one. Alright, with this, guys, let's go ahead and start by creating our first manifest in Puppet, right? So what we're going to do is, let me jump onto my master. So guys, this is my master. Now the first thing that I want to do is I want to create a manifest, so that basically if I want to install, say, Apache on my agent, how would I do that? So what I can do is I will go inside cd/etc/puppet. Here you go. And now inside this directory you will have something called as code, right? So you'll have to go inside code. Then there will be something called as environment. We'll go inside environment. Let me just do an ls over here. Okay, so we have to create a folder called environment. We do not have a folder called environment by default. So what we can do is you can create a path. So I'll do a sudo mkdir -p, and let me specify the path now. So I want the environment folder, and inside the environment folder I want a folder called production. Now inside production I would need a folder called manifests, and inside manifests I will have to create a file. Alright, so let's first create this path. So this path is now created. Let's go inside this path. So we'll go inside environments, inside production, and inside manifests. Okay, so now we will create a file called site.pp. So let's do that. So what I'll do is I'll type in nano site.pp. Okay, and I'll hit enter. So this has to be backed up by a sudo nano site.pp. Awesome. Now the first thing that I would do is I'll have to specify the node. So right now we are not getting into which node we have to specify here. So we'll just specify node is default. That means that any agent who is basically requesting the master for an update, these whatever we are going to write over here is going to be applied on that agent automatically. Okay, so what we first want to do is say we want to install Nginx. Okay, so I'll say package. So first I have to specify the resource type. This I specified, and then I'll specify the resource name. So this is the package name Nginx. I've specified that, followed by a colon. Then I specify the attribute. So the attribute is ensure which should be equal to installed, right, followed by a comma, and now I'll close the package. That's it. So this is one resource that we have defined inside a manifest. Now let us define one more resource. So what basically I want to do is I also want to create a file, and the file should exist in /tmp, and the file name should be, say, status.txt, right? So again, it will be followed by a colon. Then I'll specify the attribute. Now the attribute for a file would be, the first thing that I would say is content. What should be inside that file? So inside that file there should be a text which says nginx installed, okay, followed by the mode, which would basically specify the permissions of this file. So say I want the permissions to be 0644 followed by a comma, okay. So everything seems fine till over here. So what I'll do now, I'll do a control X, Y, enter. So my file site.pp is now saved inside the manifest folder, which exists inside the environment production. Okay, so this is done. Now what I'll do, I'll go to any of my slaves. So let's go to slave 1. This is my slave 1, guys. So what I'll do, I'll just type in puppet agent -test, right, and I'll specify it with a sudo. So let's hit enter. Okay, so we'll have to specify -test, and we'll hit enter, and now it says applied catalog in 0.01 seconds. All right, so let's check if we have the tmp file over here, which should have a status file. So the status file is not there. Okay, I think the name of the folder should be manifest. Let's check that. All right, so I think, guys, I got the problem. The folder name has to be environments. Okay, so if you look over here, all right, so let's try this. So let's try to change this folder name. So for that, I'll have to come out, again come out, and now let's just copy this folder, cp-r, let's call it sudo, change the environment folder to environments, and let's move it so that it gets renamed itself. So let's do a cp here. Okay, that's done. And now let's just remove environment. Done. So if I go inside environments now, let's just check if everything is there. So production is there, manifest is there, and site.pp is there. So let's try to do a test again. So it says there is an syntax error at the end of the site.pp file. Let's check what syntax error are we dealing with. So it's a good thing that we're getting a new error now. So I'll do a sudo nano on site.pp, and okay, so here's the problem, guys. We didn't close the bracket. So let's close it, save the file, come back over here again, and do a puppet agent test. So now I think we are progressing. Okay, so the catalog has been applied, and now let's check if the software was indeed installed or not. So how we can check that? We can basically just go to our EC2 management console. We did this on slave 1 test, right? And let's just go over here and paste this IP address. So yes, nginx has been installed on slave 2 automatically. Again, if we want to check, so what we can do is we also wanted a file, right? So what we'll do a cat on /temp with the status. So yes, status.txt file also has been created, and if you do a cat on that, it says nginx is installed. Awesome, guys. So we have successfully implemented one manifest on your slave, which has basically installed nginx, and it has created a file on the agent itself as well, right? So congratulations guys on your first manifest. Let's see what is next in our slides. All right, so we've basically created a manifest. Let's go ahead and see the different things we can do with the manifest, right? So there are 3 components of manifest. Basically, we can call these components, which can be used inside manifest for greater functionality. The first component would be variables, right? So you can use variables inside a manifest file to basically store values and then pass them on to the body, or you can basically create variables inside any or at any place inside the manifest, and then that variable can be called inside any resource, right? So let's try and check this. So if you can see of the example over here, the example says that it creates a variable called $text and it saves the value hello world inside it, and then it creates a file, right? And the content, it says hello world over here, but basically what we're going to do is instead of this we are just going to put $text. Let's see what happens. So if I go to my terminal, so this is my master, so let me just change the site.pp. So what I'll do, I'll create, so like the slide says, you can create the variable anywhere. So what I'm going to do is I'm going to create a variable called text, and let's say the text says Intellipaat DevOps course. Okay, let's say it says this, and the content would basically be changed, and the content would go something like this. It will be $text. Okay, let's try to save it and let's go to our slave1 and let's see if we can do something with it. So what I'm gonna do is I'm gonna try and do the test again. So sudo puppet agent -- test. Let's hit enter. All right, so something happened. Let's check. So cat/tmp, the file name would be same, status.txt. Let's see what it says now. So as you can see, the text has changed to Intellipaat DevOps course, and this basically value was taken from the variable. As you can clearly see that I defined the text inside the variable, and that variable was called over here, and this content was basically added to status.txt, and this is exactly what we wanted. Awesome. So you have seen how variables work, but now let's make it a little more interesting. So let's talk about loops, right? So what are loops? So whenever you want to run something iteratively without having the need to write the code again and again, that's basically the main use of loops, right?
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Now, how can you use loops in manifest is something like this. So say you want to install multiple packages inside your slave, right? Say I want to install Nginx and I want to install MySQL Server. So how can I do that? Now, in order to do that, what I'll do is in my variable, I'll basically create an array. So basically I've created an array which contains 2 values. One is Nginx and one is MySQL Server, right? And then inside the packages, what I've done, while I'm naming the package, I've basically called the variable $package, and then I've ensured that these packages are installed, right? So let's try this code out. So what I'm going to do is let me switch to my terminal, and this is my master, guys. So let us remove some code from over here, and this is what we want to deal with. So what I'm going to do is I'm going to create a variable called packages, and let's give the values inside packages. The first value that I want to give is, say, Nginx is installed on slave 1. Let's try to install Apache 2, right? And let's try to install MySQL Server. Okay, so I'm gonna show you guys that if you see right now inside my slave 1, if I check, do I have Apache 2 installed to service, Apache 2 status, you can see it says the Apache 2 service could not be found. So once we run this test, let's see what happens, right? So first I want Nginx to be removed. So what I can do is sudo apt get purge Nginx. So I'll just remove it manually from over here, and then this should remove Nginx. Yes, so Nginx has been removed. So I can just verify that by going over here and refreshing on the IP address. Let me just see if the service is also down. Service nginx status. Service is running, so let's stop the service. So service nginx stop. We'll have to add a sudo. Yes, so nginx service is now stopped. So if I refresh it, I can see that the website says the site can't be reached. Awesome, this is what we wanted. Now what we are going to do is I'm installing Apache 2 and I'm installing MySQL Server on my agent. So I have specified the site.pp on the master. And now let me go to my slave 1. So this is my slave 1, guys. And what I'm going to do now is I'm going to test. So sudo puppet agent -- test. I'll hit enter. And now it's basically applying the catalog. So so first let's check if Apache is installed. So if I go to the browser and if I hit refresh, let's see what happens. Okay, so it still says it can't be reached. So let's check where the problem is. So if I do a service Apache 2 status, it says the Apache 2 service could not be found. That could basically mean that probably there's some problem in my site.pp. Okay, so here it is. Here is the problem. So I did not change the value of the packages over here. So I just have to specify packages and I'll have to save the catalog, and that's it. If I come back here, if I again do a puppet agent test, let's see what happens now. Alright, so Apache 2 has been installed, and as you can see in the browser, it automatically refreshed, and now you can see the Apache page. It is now installing MySQL Server. So let's wait for it to install MySQL Server as well. Okay, so MySQL Server is also created. Awesome. So Apache 2 service is now installed. So we can also check it on the browser, on the terminal. Service Apache 2 status, and you can see Apache is now running on this slave. Similarly, if I want to check service MySQL Server status, so MySQL D status, I'm not sure what the name of the service is. Service MySQL status. Yes. So MySQL service is also active and it's running. So we successfully installed 2 packages, 2 softwares on this machine using loops in manifests. All right. So let's come back to our slides. So we are done with variables. We're done with loops. Now let's go ahead and understand what are conditions. All right, so now let's discuss conditions. So conditions are basically statements which helps us to take a decision based on a particular output. For example, over here, we say we are basically making use of the keyword only if, right? So only if this command is successful, only then it will basically run this particular command, which is Apache 2 is installed, right? Otherwise it will not run this particular command. And what this command is basically doing, this command is basically putting this text which is Apache 2 is installed inside this particular text file, which is /tmp/status.txt. okay, so this command says only if this particular command goes true, it should execute this particular command, right? And what is this command doing? This is basically saying, is Apache 2 present or not? So if Apache 2 is present, it will return something on the command line, otherwise it will not. So only if command ensures that if this command goes successful, this will return a code which is 0, and only if the code returned 0 is seen by this command, only then it will run this particular command which is written over here, right? If this returns the value false or 1, in that case this command will not run. So let's try this out. So let me go to my master terminal. So let's clear the screen first. So sudo nano init and sudo nano site.pp. all right, so what I want to do is I want to execute a command. So let's do that. So let's remove everything first. Okay, so basically I want to define a resource called exec, which basically deals in passing commands to the agent. So I want to do exec and I want to name this thing as, say, conditions, right? I want to name it something. Let us name it like this. So conditions. And what I want to do is I want to pass a command which basically says that slash bin slash echo. Say we are checking if Apache is present or not, so we'll say Apache 2 is installed. So we'll say this, and this has to go inside slash tmp slash status underscore apache dot txt. This will go over there. So this command should run only if the command slash bin slash the command would be slash bin slash which Apache 2, and only if this command is successful it should run this particular command, right? So, and now we'll just close the resource, and that's it. Let's save the file, and now let's come to our slave, which is this. Let us try to run the test. So sudo puppet agent hyphen test. This basically has now created a file, so let's see if the file has been created or not. cd slash tmp slash status underscore. So we don't have a file over here, so let's see status underscore. Okay, so let us go inside tmp first and then do an ls. So I can see status underscore apache file is present, so I'll just cat it status underscore apache.txt. So it says Apache 2 is installed. Reason being, over here do have Apache installed, but let us go to another slave which I have connected to my master. Let's see if we have Apache 2 over here. So service Apache 2 status. So Apache 2 is installed over here. Reason being, okay, so it has been a lot of time. So this basically, because Apache 2 manifest was present on the master, this slave also requested master for the manifest or for any change, and the master told this slave to install Apache 2 on itself. No worries. So what I'm gonna do is I'm gonna sudo apt get, and I'm gonna purge Apache 2. Okay, so this will uninstall Apache 2. And now if I do a sudo service Apache 2 status, so it says Apache service is not found. Now what I'll do a sudo puppet agent hyphen test. So in this case there should be no file which should be created. Okay, so if I hit enter now, let's see what happens. So it says executed successfully. Now let's check what just happened. So I'll go inside slash tmp. I'll do an ls over here. It has a file called status underscore apache. Let's check that. So status underscore apache. What we can do is, probably this could have been created earlier. Let us remove this file first. Status underscore apache we have removed. We'll have to add a sudo here. So it's removed now, right? Let me just check if this command actually works or not. So slash bin slash which apache 2. So it is running service apache 2 status. That's not there. So we'll have to remove this particular file. So we can do that. So sudo rm slash user slash sbin slash apache 2. Either we can do this, or okay, let's first do this and then we can probably try something else as well. So user sbin slash apache 2. Okay, so now if I do slash bin slash which apache 2, do an ls here. Okay, so my status file is not present, and now I'll do a sudo puppet agent hyphen test. I'll hit enter. Alright, so the catalog has been applied. Now let's check inside tmp file. So cd tmp, we are inside, and now let's check by doing an ll, or let me do an ls. Okay, so we don't have the status underscore apache file over here. Now it can be present over here. All I have to do is change the content. So we just learned about only if, right? Now let's learn about unless. So what unless means is until and unless this file or this command is not sending me 1 or is not false or is not executing properly, till then do not run this command. The moment it does not or is not successful, run this command. Okay, so now what we will do is, because our Apache 2 is not present on slave 2, I can just change this to unless, right? And I can say Apache 2 is not installed. And now in this case, what will happen is if I go to my slave 2, I'll just do a Puppet agent test again. And in this case, it should create a file inside the temp folder. So if I do an ls, it has the status underscore Apache file. Let's do a cat on that. And it says Apache 2 is not installed. So basically we just made use of unless. So again, just for revision, what we just saw, unless basically deals with a command which it is waiting to become false. The moment that command becomes false, it will run this command. It will run this particular command which has been specified. Whereas the opposite of this is only if. Only if waits for this command to be successful, and only if this command is successful, this command will run. Unless this command is successful, this command will not run. Okay, so you can remember it like this. So with this, guys, we end the topic of basic coding in Puppet. Ansible, like Puppet, is just another configuration management tool. And what is configuration management? As we have already learned, it's nothing but installing softwares on multiple systems. For example, if you have a fleet of 150 or 200 servers and you want to do a particular software install on all those servers, if you do that manually, that will take a lot of time, right? And for that, we needed something which could automate the installation of softwares on multiple systems. And the way forward was configuration management. Right? And now what happens is any software that you want to install, you can do that on a single click of a button on all the servers which exist in your fleet using the master slave configuration, where on your master you would have the Ansible or Puppet master installed, and then on the slaves you just have to specify on which machine what to install, and everything will be done automatically. Right? This basically solves two things. The first thing is that the softwares which were installed, they were taking a lot of time if it were done manually, and now with Ansible or Puppet in the picture, where everything is happening automatically, it does not take that much time. Second thing is there is no room for error because everything happens automatically. Right? So if there was any error which could be committed while installing softwares, that is not the case now because everything is automated. So that is why, you know, configuration management as a concept became so popular, and that is why so many tools have been developed. And we have basically learned Puppet, and today we're going to learn Ansible, which yet again just solves the configuration management problem. Right? Now, some few facts about Ansible. So it was written by a person called Michael Dehan, right? And the name Ansible actually came from a fictional novel which was written by Ursula K. Le Guin in 1966, right? That's like 50 years before this novel was written. And there was a communication device in this novel, right? And the name of that configuration device was Ansible. So it is the name Ansible has been taken from there by Michael Dehan, right? And again, this software was acquired in the year 2015 by Red Hat. So now any updates or any features that are added to the software would basically be directed by the Red Hat company. But in its true nature, right now as well, Ansible software is open source and anybody can download it for free. Anybody can make changes to it because it is open source, right? So guys, as we discussed, that Ansible playbook is the core part of what Ansible does in its day-to-day activity, right? So whatever you write inside the Ansible playbook is actually executed on all the servers which are basically connected to the Ansible server. All right. Now, how do you write the Ansible playbooks? You write it in the YAML language, which is YAML int markup language, right? And this is the full form for that. And as we move along, I'm going to show you guys how you can start writing an Ansible playbook, right? So guys, Ansible playbook, let's focus on the word playbook first. Like, what is a playbook? A playbook means a book of plays, right? So a playbook essentially should have a lot of plays. So guys, you have the first level in the tree of playbook comes a play, right? And you can have multiple plays inside a playbook. Now, what is a play? A play is a combination of tasks that you want to do on a particular host, right? So you define a play, and inside the play you define the tasks that has to be done, and each task has something called as module, it has something called as notify, it has something called as handler, and a lot of other things as well, right? We will discuss these things in detail when we'll be talking about Ansible roles. For now, let's just focus on the word playbook. So like I said, playbooks has a lot of plays, and each play has a lot of tasks, right? Now let us see how we can define a play in a playbook. So guys, in a play, you can have 2 or 3 tasks or 4 tasks or 10 tasks or any number of tasks written, and these tasks are executed on a particular host using a particular condition, right? And that's why it's called a play. What has to be played on a host? This is one play that is being played, which is it is executing a command in host 1, and then it is also executing a script in host 1. This is just an example, although we will be doing this in this session, but let us take an example that these are the 2 tasks which have to be done on a particular host. So they can be combined inside one play and then they can be executed. Similarly, if I want to execute a script on host 2 and install Nginx on host 2, this would become play 2. Okay, now how do you write, or how would this particular playbook look like on screen? This is how it will look like. Okay, now out of these, which are plays, what are plays, and what are tasks? Let's look at that one by one, right? So guys, this particular block of code is one play wherein you have defined the hosts, right? So whenever you define the host, you start with a new line wherein you are defining the host. That becomes the starting of your second play. Okay, now the next thing is inside a play you have tasks. So as you can see, you have tasks over here, and the first task that we have is execute command date. This is the descriptive name of the task, right? So this does not get executed. This could be any string that you want to give, right? Second thing is you'll have to pass the command. Now what command has to be executed on the terminal? That same exact command you have to mention here. Okay, then the second name is execute script on server, right? So what is the script that you want to run? test_script.sh. This is the script that I want to run. So in this I have 2 tasks. One is execute command date. The next task is execute script on server. Every task will start with a name and has to be followed by a hyphen. Okay, hyphen marks the beginning of a new task. You specify the name of that task, and then you specify how that task will be executed. All right, for example, in this case there should be a command which is being executed. In the next case there should be a script which has to be executed. The syntax will remain like this, right? Now whenever you're starting a new play, in that case also you have to begin with a hyphen. You specify the host name, that is this hosts colon and then host 1. Then whether that particular command or whether that particular play has to use sudo, we mentioned that. So if you want to use sudo in these commands, all you have to do is type in sudo colon and then say yes. Okay, then you give the name of the play. So the name of the play, it could be anything. Like I said, it's just a string. You can pass in anything over here. And once you've specified all these info, you start with the tasks, right? So this is play 1, guys. Similarly, now if you have to write play 2, I'll have to begin with hosts again, which I've done over here. Now where I want to run these, run this particular play, I want to run it on host 2. What is the name that I want to give this play? I am calling it play 2. Do I want the sudo to run? Yes, I want the sudo to run. Then what are the tasks that I'm executing in this play? I want to execute script on server. This is the name. It could be anything. And then I specify the script which has to run on that particular host. Then I want to install a particular package. So I'll say the name of the task is install Nginx, and the task that I have to do is installation. So that's why apt is written over here. So when you're dealing with Ubuntu systems, you'll have to type in apt over here. If you're dealing with CentOS or Amazon Linux, the command over here would be yum. Okay, so apt colon and then the package name, which is nginx, that I want to install, and the state is latest. So over here you basically specify the version that you want to install. So I want to install the latest version. So this is how you write a play. Now let us summarize what we just discussed. So we missed out on this thing that we always start a YAML file with 3 hyphens, right? So any time when you're starting with a YAML file, specify these 3 hyphens and only then begin with your playbook. So I start with specifying these 3 hyphens. Next thing I do is that I have to create a play. So for creating a play, I'll have to start with a hyphen. And the next thing that I'll have to specify are hosts, right? And the name that you're specifying for the hosts over here has to exactly match with the /etc/ansible hosts file. So whatever IP address you have mapped to the host name over there, right? That host name only you will be using over here. You cannot use some other host name. Okay, once you have specified that, the next step was to specify the tasks. So each play is like a dictionary and has name, host, tasks, and the order doesn't matter, right? So you have the name, you have the hosts, you have the tasks, so it becomes a dictionary. So it has all these information, each play, and once you define that and execute that, then it executes according to what is asked inside that particular play. All right, so when you're writing a playbook, that becomes a list of dictionaries. So if this is one dictionary where you have hosts, name, and tasks, and this is some other dictionary where you have the separate version of host, name, and tasks, when you combine them together inside a playbook, it become a list of dictionary. Okay, so again, seeing what tasks are nothing but they are basically commands that we want or tasks, or I can say things that we want to do on the remote server from the Ansible master. Those are termed as tasks. Then the next step would be to basically creating a playbook. How can we create a playbook? So first, let me just move on to my Ansible master. So guys, this is my Ansible master. What I want to do is I'll create a directory called Ansible. Okay, so this is my directory. Now I'll go inside Ansible. This is my Ansible directory, guys. Now the first thing that I'll do is I'll create a playbook. Okay, so let's create a playbook called sudo nano play.yaml. Okay, this is my playbook. Now I want to create a playbook wherein I will be installing the Apache software on my host 1, which I defined in my host file. Now how can I do that? The first step that you have to do in creating an Ansible playbook is define these 3 hyphens. Once you have done that, now you have to start with a play. How can you create a play? Start with a hyphen and specify the hosts. So I want to do this particular play on host 1. Okay, then do I want sudo? Yes, I want sudo. The name of this play, let's call it play 1. Okay, and now let's specify the tasks. Okay, now inside the task, guys, the first thing that you would do.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the cloud platform are not used for DevOps implementation? A. Google Cloud. B. IBM. C. Microsoft Azure. D. Amazon Web Services. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
Is you'll have to define a task. So let's name the task something. So let's call it install Apache. Okay, let's call it this. Then what I'm gonna do is I'm gonna give the package name apt, and let's say the so if you want to see the syntax for that, the syntax is actually available here. So apt, and then you specify the name of the package that you want to install. So the name would be Apache 2 and the state is going to be latest. Okay, this is all you have to do when you're creating a play. All right, let's start by this. Let's see if this is working or not. So my play is now ready, right? Let's check if I can ping my host 1. So Ansible -m ping host 1. So it says could not match supplied host pattern. Okay, so I think that's because the name is slave1. Yes, so the name is slave1. So let's change that in our YAML file as well. So sudo nano play.yaml, and the host name is slave1. Okay, now let's try to run this playbook. Now how can I run this playbook? Type in Ansible hyphen playbook space play.yaml. Once you specify this playbook will start executing. Now before I execute this playbook, guys, let me quickly show you on my management console that if I go to slave1 right now, and if I go to this IP address, nothing is visible over here, right? It says the site can't be reached. Okay, now let me come back to my master. I'll execute this playbook. So now it is installing Apache. It will take some time, guys, because software installations take some time. So you can expect around 15 to 20 seconds it will take to basically install or do this particular task. And once this task is done, what I can do is, so as you can see, it says task, the change has been successfully done, and OK is equal to 2, changed equal to 1, and nothing has been failed. Now if I want to do this, all I have to do is come back here, refresh it, and as you can see, the Apache software is now successfully installed on my slave1. Awesome. So I have successfully done something on a remote system, right, which is this. So now what I'm going to do is, let me just uninstall Apache, sudo apt get purge Apache 2. I'll just uninstall the package, and I'll tell you why I'm doing that. So my package is being uninstalled. Now if I do a refresh here, you can see I'll again not be able to reach to this particular server. Now what I want to do is I want to add one more host to my Ansible cluster. So let us do that. Let us launch an instance. It has to be an Ubuntu instance, and the processor is t2.micro. Security group, I'll select an existing one. Review and launch. I'll launch it with my key pair, and now it's ready. Okay, so my server is being launched. Let's call it Ansible 3.1. Okay, and now if I go to my running instances, I can see that a new instance is now being launched. Now what is the IP address of this instance? It's this. So let's copy this and launch a putty terminal. Let's select the color to be white so that we can differentiate it easily. Okay, let's click on open, and now let's log into our instance. Alright, so I've successfully logged in. Now how do you add a host? All you have to do is update the machine, sudo apt get update, and the next step would be to install Python, sudo apt get install Python. Once this is done, I'll just have to go back to my master. I'll have to make the keyless SSH possible, and for that I'll have to do an cd into the SSH directory, and then I'll have to do a cat on id_rsa. Okay, this is the code that I'll be copying on my slave2. Okay, so this is my slave2, guys. Now I'll be going inside the SSH directory, and I'll be going inside the authorized key file, and now let's add this entry over here, save the file, and now let's try to SSH from over here. SSH ubuntu @ this is the IP address that I'm going to connect on, and yes, I'm able to log into my slave. So to verify, this is the IP address 172.31.29.34, and if I check it over here, it's 172.31.29.34. Awesome. So let us remove this. So let us exit the SSH connection, and now I'll have to add this host in the Ansible host file. So in order to do that, I'll have to do a nano on /etc/ansible/hosts. Okay, and now let's just scroll down and add one more slave over here with this name, Ansible_SSH_host is equal to this IP address that is of the slave. I'll add this, I'll save the file, and now if I do a Ansible -m ping all, I should get 2 servers ready over here. Okay, awesome. Now why did I do that? All right, so now let us go to inside Ansible, right? And let's try to edit our playbook. Let's try to add one more play inside this. So I'll add a play, and let's say I am doing it for slave 2. Okay, I want sudo to be there. I want the name of the play should be play 2. Okay, the tasks that I want to execute are as follows. So the first of all, the name of the task would be to install, let's say I'm installing Apache on this system and I want to install Nginx on my slave 1. Okay, so let's change all the things accordingly. So I'm installing Nginx on my slave 1 now, and I'm installing Apache on my slave 2. Okay, so name is equal to Apache 2, state is equal to latest. All right, seems cool. Now I will be executing this playbook and let's see how it goes. So basically with one command, what we are doing is we're installing software on 2 different systems, right? And the software that we're installing are also different, right? So this is the IP address for my slave 2. So as you can see, if I'm going to the IP address, I can't reach anywhere. Similarly, if I'm going to this IP address, I can't reach anywhere. Okay, now let's come back to our master. All right, now let me execute this command. So it is Ansible -playbook and then play.yaml. Okay, so let's execute this. So it is executing play 1. It is installing Nginx on my slave 1. All right, okay, so it has been done. Now we are executing play 2 and I'm installing Apache. So as you can clearly see right now, if I show you the browser, my server 1 is already ready and it says welcome to Nginx. Awesome. And my slave 2 is also done. So if I go here and if I refresh, I can see the Apache page. All right, so I've configured 2 different servers from my master, right, at the click of one button, right? I just executed one playbook which configured 2 servers of mine, installed 2 different softwares on it based on the name that I specified. All right, so awesome guys. I think we have almost begin. We are almost a beginner now with the playbooks. I'm sure you guys can also write your playbooks, but let's take it a notch up. Let's try to do something else as well. Now, if you have to execute scripts on remote system, how can you do that? Okay, so in order to do that, all you have to do is you'll have to create a script first in the same directory where your playbook is present. So I have my playbook present in this directory, that is Ansible, right? So in this, let me create a script. So let's say I create a script called hello.sh, and what I want to do in this particular script is I want to create a file. Let's call it let the content be hello world for that particular file, and I want to put it in /var/www/html. Okay, I want to put it over here. Let's see how it goes. So and the file name has to be 1.html. So in this case, what is going to happen is that I'm going to execute this on slave 2 where my Apache is basically installed, and that should basically create a website automatically. And if I go to this particular IP address and I go to /1.html, if I hit enter, it should basically show me the web page over here. Let's see how we can do that. So I've created this script, guys. So let's save the script, and now let's try to make it an executable file. So let me make it executable. So I'm just changing the permissions for this file, right? And this has to run in sudo. All right, so my script is now ready. Now I'll go inside my playbook, guys. So I'll go to sudo nano play.yaml, and I want to do this task on my Apache server, right? So I'm inside my Apache play, and I'm adding a new task now, which is adding website. Okay, and what I want to do is I want to run that script. So I'll type in script : and what is the name of the script? hello.sh. That's all I have to do. Now let's save this play And now let's try to run this play. So I'll do a Ansible hyphen playbook and I want to run this play. Okay, let's see how it goes. Nginx is installed. Okay, so on slave 1 everything was executed, everything is same. So it says okay equal to 2, changed equal to 0. On my slave 2 there's one file that got changed. Now let's try to do a refresh over here. Can you see automatically a website was created which is now called Hello World. Now let me show you one more awesome thing over here. Now I'm not going to any of those servers, right? This is my slave 2. I'm not going over here. I'm still on my master. Now what I can do is I can just simply change the script file. So if I change the script file to be, say, I'll go inside the script file. I change the text to hello world 1.2. Okay. Mind you, I'm not going to any other server. I'm just running the same command again, right? Again, the commands will run. As you can see, it says on slave 2 there's one change. And if I refresh it now, can you see the website has changed automatically, right? And this has changed without me going onto this server. And this is the power of configuration management, guys. Now imagine you have 100 servers and you have to change a file in all those 100 servers. How do you do that? It is impossible to do it manually. I'm saying it is impossible because time is of the essence when you're working in businesses, right? So you can do it using Ansible in this kind of way, right? Now let us come back to a slide, guys. So if I'll come back to my slide, all right. So now we created our first playbook. In this particular example also, they're basically running a command and then they are running a script. So we did similar thing, right? But when you're executing a command, basically you cannot see the output. That's why I changed this particular demo, but you can also try this demo also. So the syntax is clearly visible over here. You can just write the syntax in a YAML file and then try to execute it and see how it works for you. You can also create a demo for your own self as well and see how things work out. All right. So we created the first playbook using this particular command, and we created this shell file or the script file like this, right? And then we changed the permissions for that script file. Once everything was ready, we executed the Ansible playbook and the script file was automatically taken up and shifted or.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Basically copied to the slave that I want to execute it on, and then my playbook was basically executed. All right. So guys, this is how you create a playbook. So the first step that you have to do is you'll have to install Ansible on the master, right? But you do not have to install Ansible on the slave. That's because Ansible works in such a way that, Ansible installation is just required on the master. On the slaves, it just requires Python to be installed. If Python is installed, it can directly connect to that particular Ansible slave, right? So this is the first step. First step is install Ansible on master. Second step is to configure SSH from the master to the slave. That is, you should be able to do an SSH to the slave from the master without any key and without any password. So we'll see how we can configure this. Third step is that we'll have to set up Ansible host and then we'll have to test the connection. All right, so we'll do this step by step, guys. So let's start with step 1, which is install Ansible on the master. Now, in order to do that, you'll have to first launch 2 instances on AWS. Now, let me just quickly jump on to my AWS console. So guys, this is my AWS console, guys. And the first thing that I have to do is I'll have to launch an instance. And the OS that I want is Ubuntu. The processor would be T2.micro. I click on next. What are the number of instances that I want to launch? I want to launch 2 instances. I'll click on next. Move to the part where you'll have to select the security group. Now, if you don't have a security group, first create a security group and add a rule for all traffic. And it should be basically from anywhere. Click on review and launch and this will be done. If you already have a security group which has these kind of properties, what you can do is you can click here on select an existing security group and select the security group that has all the rules according to what software you're installing. All right. So once this is done, guys, click on review and launch, and finally review all the settings that you have done and click on launch. Okay. Select the key pair that you have on your system and click on launch instances, and this will launch 2 instances on AWS for you. Next step would be, guys, to basically go to my management console and naming my instances. So let's call my first instance is as Ansible 1, and let's say my second instance is Ansible 2. Okay, Ansible 1 is going to be my master and Ansible 2 is going to be my slave. Let's try connecting to Ansible 1 first. So I'll go to my putty tool, and this already has my my ppk file selected, which is HEM, right? So this is already selected. Now I'll click on open. So I'll click on yes, and I have successfully connected to my master now. Awesome. So I have connected to my master. The next step would be to connect to my slave. So for connecting to my slave, again, I'll go back to my management console, select the second instance, copy the IP address, open a new putty terminal, put the IP address over here. Let us change the color so that we can differentiate which one is my master and which one is my slave. And yes, now we are basically connecting to my slave. Let's enter the username, and we're successfully connected to my Ansible slave as well. So my green terminal is my Ansible master. This is ready now, and this is my Ansible slave. Now what are the next steps that I will do? First, I will have to update the master and the slave. So on my master, I'll type in the command sudo apt get update. Similarly, on my slave as well, I'll type in the command sudo apt get update. Alright, so my machines are now getting updated. Once I've updated my master, next step would be to install Ansible, and for that the commands are these, right? So once you've updated the machines, you'll have to install a package called software properties common on my master. Usually when you're launching an instance on AWS, this package is already the latest version. So as you can see, it says it's already the newest version, which is awesome. The next command that you have to run is you'll have to add the repository for Ansible in your master, right? So just type in this command, hit enter, and this will basically add the Ansible repository to your master. Next step is to update the machine. So let's update the machine with this command. So it says sudo apt get update, machine is updated, and now finally the command to install Ansible. Hit enter, and Ansible will now be installed on this particular machine. So while Ansible is being installed on this machine, guys, what do you have to do on the host or on the slaves? You'll have to update the machine, which you have already done, and just install Python. Okay. So this is my master. Ansible is successfully installed on my master. On my slave, I just have to install Python. Nothing else. No other Ansible software. So Python is being installed on this machine now, and Python is installed successfully. Okay. So Ansible is installed on my master. Python is installed on my slave. These both are ready, right? Now let's see what is our next step. So let me just go to my slides. So the first step was to install Ansible on the master. I've done that. Next step is to configure SSH access to Ansible host. Now what does this particular step mean? This means if I go to my master right now, and if I type in the command SSH ubuntu @ the IP address of the slave, I will not be able to connect to my slave right now with this command. Let's see. Let's verify this. So I'll go to my AWS management console, and this is the IP address for my slave. Let's try to copy that over here. Let me also explain you what is basically happening in this command. So I'm doing an SSH on this machine with the username Ubuntu. Okay, so that's why Ubuntu @ this IP address. Now if I hit enter, if I'll just type yes, this is basically asking should it add this IP address in the list of known IP addresses. I'll click on, I just select yes, and this IP address will now be added. I hit it enter, and now as you can see, it says permission denied. So you're not able to do an SSH to this instance with this particular IP address. Now we have to solve this. This should basically be a success. This should be able to connect to the slave through this particular command. Right now, why are you getting permission denied? That's because the only way to connect to that instance is using the PPK or the PEM file, right? We don't have the PEM file in this instance. So we'll have to enable my slave to be able to accept connections from this particular machine so that it does not require any key like a PEM file or a PPK file or any kind of password. Now this is a necessity when you're trying to install Ansible. Now let's see how we can do this. How can we enable keyless access into my slave? Now for doing that, guys, the first thing that you'll do is you'll have to go inside the directory .ssh. Once you go inside that, let me first show you the structure right now. If I do an ls, you can see there are two files. One is called authorized keys and the other is called known hosts. What is known hosts? When we were executing this particular command, ssh ubuntu @IP address, it asked us whether this IP address should be added to the list of known hosts, right? So inside this known hosts file, if I do a cat on known hosts, you can see that this is basically the code, or this is basically the encrypted form of this IP address that is that on the slave, and which tells it that, okay, so this is a known host that I'm connecting on. Okay, if you don't understand this, guys, don't worry. This is not a part of you getting to know Ansible. I'm just telling you this for your knowledge. All right, so this is encoded form of the IP address that you'll be connecting to. All right, what else is there in this directory? You have something called as authorized keys. Authorized keys is a file wherein you will be entering all the machines which can connect to this particular system, right? If I do a cat on this file right now, you would be able to see that this is the SSH, or this is the key code that of this particular file. What is this file? This is the PEM file that got downloaded on my system when I created a key pair, right? So when I connected to this instance, I connected using this particular file. So this is there in the authorized keys file, which means that if a machine is connecting to this particular instance and has this particular file as an argument, in that case, that allow that machine to connect, right? So if I remove this, nobody will be able to connect to this instance, even if they have this particular file. Okay. Now what I want to do is, on my slave, if I go to this particular directory .ssh, and if I do an ls over here, this file that is the authorized keys, I want to add one more key in this, which will basically allow my master to connect to my slave. Now which key I have to add, I'll tell you now. Now, in order for you to generate a key for your system, all you have to do is type in ssh-keygen. This will basically create a key for this particular machine. It is going to be unique for this particular machine, all right? So ssh-keygen, if I hit enter, it'll ask you to enter the file in which to save the key. Do not enter anything, just hit enter repeatedly, right? And then once you get this kind of a message, that means your file has now been successfully created. And where is it created? It is always created inside .ssh directory. Okay. Now if I do an ls over here, I can see there's a file called id_rsa.pub. Okay. Now the code which is there inside this particular file, I'll have to put it inside the authorized keys of my slave. Okay. So let's try to do a cat on id_rsa.pub. This is the code id_rsa, sorry for my mistype. This is the code which we have to enter on my slave now. Okay, so let's copy this code, and on my slave, let me do a nano on authorized keys, and now let's just paste the code over here. Okay, we have pasted the code. Let's save the file. And now if I try to do an SSH again from my master, I should be able to do it successfully. So I'll just again go to that particular command. This is it, right? Let me copy this command and let me clear the screen, guys. So I'll clear the screen so that it's visible clearly. Now I'll do an SSH on this particular IP address, and now you can see I didn't get an error. I basically got logged into my slave. And how do you know that? This is the username @IP 172.31.45.176. This is what you're getting on this terminal. And if I see over here, I have the same number over here as well, 172.31.45.176. So I'm connected from this machine onto this machine through SSH. Now, if you want to exit the SSH, all you have to do is type in exit it says connection to this IP address has been closed, and you can see it has reverted back to the same name that was of the master, which is IP 172.31.44.88. Earlier it was 172.31.45.176, which was of my slave. Okay, so I have done my second step successfully, which was basically to configure SSH access to my Ansible slave without any password and without any key. Right, you just enter SSH ubuntu @ IP address of my slave and you'll be able to connect to it successfully. Now what is my third step? My third step is setting up Ansible host and testing the connection. So I have SSH enabled on my master. It can easily connect to my slave now without any password and without any key. But how will Ansible connect? We'll have to configure that now. Right now, in order to add, or in order for Ansible to know that it has to connect to a particular machine, it has to have its IP address. Right now, where can you add that IP address? That IP address is basically added in this particular location, /etc/Ansible/hosts. All right, hit enter, and this is the file that will come up. Right, so these are all the commented lines are all the templates that you can use to basically add hosts, but I'm gonna tell you a new template in any case. So the way you add hosts is you start by square braces, okay? And inside square braces, you give a name. Let's say the name is production. What does this name symbolize? This name means that whatever is below these square braces is basically inside the group production. So this is the group name, okay? And now what I can do is I can add n number of IP addresses over here, and all those IP addresses basically will be inside the production group. Okay, you can name your group anything, guys. It's basically random. You can name it anything, but whatever IP addresses you will specify after that will get inside that particular group. Okay, now I have created a group. Now I want to add a host inside this group, so I can give my host a name as well, or I can give my slave a name as well. So let's call my slave as slave1, right? Then you'll give a space, and then you'll type in Ansible _SSH _host is equal to, and then the IP address of your slave. So in my case, the IP address of my slave is this particular IP address. Let's try to copy it and let's enter it over here. Okay, so you enter the group name, then you enter the host name or the slave name, space Ansible SSH _host equals to the IP address of my slave. So whenever I'll ask Ansible to ping any of my slaves now, it will read this particular file to get to know which IP address it has to ping on. Okay, now let's save this file. So my file is now saved, and now let's try to enter the command Ansible -m. So now what we are trying to do is we are trying to see whether Ansible can communicate with my slave. Okay, now in order to do that, I'll type in Ansible -m ping. Ping means ping that particular all the slaves which are basically connected to this Ansible master. How are we selecting all the slaves? We'll type in the command all. So Ansible -m ping on what? All the machines that are connected to this Ansible master. I'll hit enter. So it will go through that file which we created /etc/Ansible/hosts. It will see all the hosts which are added in that particular file, and then it will ping those machines, right? So as you can see, it on slave1 was the name that I gave to my host. On slave1, it was successfully able to send ping, and what it received was pong, which means that it was successfully be able to communicate with the Ansible slave. All right, I can also type in Ansible -m ping, and I can specify the group name. So the group name was production, let's say, right? I hit enter. As you can see, it automatically got to know, okay, so if I'm pinging production, these are the hosts which are inside it, and this is the message that you're getting, which is success. If I try to type in the host name as well, so I can also do that. I'll type in Ansible -m ping slave1, which is the host name, hit enter. It will again be able to ping the slave machine. But let's say I enter a name which is not there in the host file. What will happen in that case? It will not be able to match it to any of the name present in the host file, and hence you'll get an error. No hosts match nothing to do. Okay, so guys, this is how you can set up Ansible master slave on AWS using the Ansible software, which basically does not require you to install the Ansible software on the slave. Just install Ansible master on the master, the Ansible software on the master, install Python on the slave, add the IP address of the slave in the host file, and configure keyless SSH access from the master on the slave, and you're ready to go. All right, so let me just come back to my slide. So let us summarize what we did. We installed Ansible on the master and we installed Python on the slave. Then we configured keyless SSH access from the master to the slave. And the third step was we added the host's IP address on my Ansible master in the file /etc/Ansible/hosts. Right? Once I did that, I was able to communicate with my slave.
Let's talk about Kubernetes now. So basically containers are a very good way to bundle and run your applications. We talked about this before, right? You can have your applications divided into a various number of small independent pieces and you can bundle them together and run it dynamically and manage it. So right. So in a production environment, you need to manage these containers, right? So there are a lot of containers that you have broken your application down into. So you need to manage these containers to ensure that there is no downtime and there is no hindrance here and there. So that is where Kubernetes comes into the picture, right? So what basically Kubernetes does is it provides you with a framework to run on your distributed systems very resiliently. So it takes care of all the scaling that you have to do. So by scaling, I mean if you have, let's say, 3 replicas of a pod, we'll discuss about pods later. So you can make it to 4, 5, 6, 7 or bring it down depending on your needs. And if there is a failover for your application, it can rebuild it if it's required. If it gives you with a deployment pattern. So there are 2 ways of basically deploying things. You can recreate it. So what it means is basically if you have, let's say, 2 things which are running and you have an update right now. So you can either recreate the entire thing, which will give you a little downtime, or you can go with the rolling updates. So the rolling updates will basically move it one by one, all the replications that you have, and replace it with your new updated deployments, right? And it provides you with much more than that. So basically Kubernetes can be thought of as a portable, extensible, open source platform which is used for managing containerized workloads and services, and it facilitates both declarative configuration as well as automation. So it does both of those things. So what do we mean by declarative configuration? So you give your configurations as a file where you declare, okay, this is mapped to this, so this basically does that. So we'll talk about that when we talk about YAML files, and it gives you this automation kind of thing where it basically manages all your things through controllers. So it has a very large and rapidly growing ecosystem, Kubernetes. So various number of people are involved with Kubernetes ecosystem. A lot of people are there, so they give you this service and support, and there are different tools widely available which are very compatible with Kubernetes. So a lot of people are working with it. So there is a huge community to it where you can find different answers to the problems that you face in and around different communities. So it's a very, very, very happening and hot topic in the computer science field right now, and specifically towards the DevOps. So Kubernetes is a very, very good container orchestration tool. So it helps you manage all your containers and deployments and scale it.
Why do we need Kubernetes? So to understand this topic, let's go ahead and understand how our applications were designed before, right? So this is a sample monolithic application, guys. And this is exactly how our applications used to be coded in the past, right? A monolithic application is nothing but where all the features of the application are consolidated into one code base, right? For example, let's take this sample application to be Uber. Right? So you have features like location services, then you have customer service.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What are the key components of DevOps? A. Continuous integration. B. Continuous testing. C. Continuous delivery and monitoring. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Notifications, mail, payments, and passenger management. Right? All of this is part of one application that you have in Uber, right? But now when you click on notifications in your Uber app, what your application basically does is it contacts the server, and basically you get the notification from the server to your application. So your application is basically reflecting whatever it is getting from the server, right? Now, earlier, all these features used to be on one server, right? For example, if my application has to reach or stream notifications, it will reach out to the same server, and if I have to call the customer support, that API query will also go to the same server, right? Now, this might seem okay to you, but this caused problems. Reason being, first of all, this is all in one code base, right? So if I have to do any update to any part of this application, for example, if I have to make changes in passenger management, the way we work with passenger management, I want to change something in that code, I want to update something, right? So for that, I'll have to work in the same code base where my mail is, where my notifications is, where my customer service is, and chances are highly likely that some of these functions may stop working or may malfunction based on the changes that I'm doing in my passenger management, right? So there were a lot of dependency between all the features of this application, reason being it's in one code base, right? They're not interacting using JSONs, they're not interacting using some other communication, they're interacting within the code, right? And this caused a lot of dependency. So say for example, tomorrow my passenger management code fails, so that would lead to all the features will lead to basically failing, reason being all of them are dependent on each other, right? And this was solved by using microservices. Now, what was microservices? In microservices, we basically decided that all the features should have different code base and should be deployed separately. Now, my customer service is deployed separately. It's in a separate code base. My notifications have been deployed separately. It's in a separate code base, and all of them, they interact using JSONs, right? So if they have to communicate with each other, they'll have to send each other some files or encoded message, which the other service will decrypt, and then it will try to read it, and any response which has generated it is again sent to the other service using that same mode of communication, right? So now there were no function calls between these services. It was only API calls that is using JSON, that these services were interacting with each other, right? But the problem is now how to deploy these services. Where will I deploy these services? One way is that, say, my customer service module I deploy on one computer, my notifications would be on the other server, my mail service would be on some other server, and similarly, if there are 5 features that are listed over here, there will be 5 different servers which will be serving each services request. It sounds cool, it sounds very distributed also, but when it comes to scaling, it becomes a problem. Reason being that my customer service, the customer service module might not require that much of power that is there in one server, right? But still, my customer service module is occupying the whole server, and I cannot deploy anything over there. So downscaling it became a problem, right? Upscaling is no issue, you can also upscale it, but upscaling would also cause the same problem, that is, say, your server is able to handle 10 replicas of your customer service module, or say, let's your customer service module is being bombarded with requests, and it peaks your CPU to say around 85 to 90% of its usage. Now, what will you do? If you have deployed this application on some cloud, your cloud will basically deploy one more server which will have exactly the same service, and now the request will be divided between the two servers, right? But again, the problem is that on the second server, because just the customer service your module is running, it might not be able to utilize the full server, right? It will always be underutilized. So this was a problem that we had to solve, and we solved it using Docker. Now, how did we solve it using Docker? Now, Docker gives you a separate environment, right? So we deployed services on different servers because we wanted them to be totally independent of each other. They should not have any dependency on the other features environment, right? So what we did, we all Dockerized these services, and now all these services could exist on a single computer, right? But at the same time feel that as if they are on different computers. So your application in that case will only be down when your computer or your server as a whole fails, right? Still your applications are independent of each other. For example, your customer service could be running in a Red Hat Docker container, your payments could be running inside a ZS Docker container, your mail could be running inside an Ubuntu Docker container. They all could be different and they all could be running on the same system. So this solved the problem of underutilization or scaling, right? So upscaling is also okay. So if I feel that passenger management is being overutilized and it's causing a spike in my CPU, what I can do is I can probably deploy one more instance of passenger management, or one more container of passenger management, and the request will then be routed between the two. Also, if my passenger management is not working properly, what I can do is I can shut down passenger management, I can deploy one more container on it, and this will not affect the other application or the other features of your application, right? So with microservices, what you get is zero downtime, right? You get a chance to update your application without causing a problem to the other services, and many more, right? So when we got a Dockerized kind of a scenario, we were like, okay, so things seems to be okay now. But now again, the problem was that how do we monitor these containers, right? So if there are like 300 or 400 containers running, how do I assess which container is running fine? What is the health of a container? Say a container goes down, how do I automatically deploy one more container on it? So this orchestration of containers was a problem, and this is where Kubernetes came to our help, right? Now there are many container orchestration tools and all of them perform differently based on the kind of features they have. Kubernetes has the most number of features which are essential for basically doing container orchestration. Natively, Docker also gives you Docker Swarm, which you can use to do container orchestration. But personally, I feel Kubernetes has way much more features than Docker Swarm, and that is the reason we're discussing Kubernetes today, right? And most of the industries today are also using Kubernetes for the same reason, that it gives you a lot of flexibility in terms of what you can do with your application. So because your containers were in large number and you had to do monitoring, we came up with Kubernetes. So if Kubernetes was not there, what were the problems? Let's discuss that. So each service, which that is the each instance of a feature which is running, it became difficult to monitor it, right? Scaling a particular feature also based on load was not possible. Reason being that you could not automatically monitor it. You had to keep someone monitoring your usage of the containers, and if they feel that your container is being overutilized or your container has died because of some reason, then in that case it was manually updated that let's launch a new container and let's scale down the other container, or let's delete the other container. So because of this, like I said, there was too much manual intervention which was required from the programmer's end. Also, if you felt like I told you that all of this existed on one server, right? So the only way that your application will be down is when your server is down. So we had to mitigate this. So if we deployed containers on multiple servers, now to manage or to know how many containers are running for a particular service on multiple nodes also became a problem, right? And there was no way we could solve it without a tool which could basically orchestrate the containers for us. And this is exactly where Kubernetes saves us. So what is Kubernetes? So I think we have discussed most of it, but Kubernetes is nothing but a container orchestration tool which is used by our application to to basically monitor or orchestrate multiple containers. The kind of features that it gives us is monitoring. It helps us monitoring containers, it helps us scaling containers, it also helps us restarting containers if any of them fails, and this all happens automatically. There is no manual intervention required for this, right? And this is what Kubernetes is all about. Now, what are the features of Kubernetes? So we discussed some of them, like it could monitor it, it could scale it, but let's just come more about it in detail, right? So the features of Kubernetes include the first one being that managing multiple containers as one entity, right? So if you have 400 containers which are running, which probably have 5 features running on it, you will only see those 5 features. You will not see how many containers are running behind it, right? I mean, you don't have to worry about the number of containers running behind it, because Kubernetes automatically, it takes care of the health monitoring and scaling up of your containers, right? You only have to worry about what kind of services you want to launch. If there is a new feature that you have to include in your application, all you have to do is launch a new deployment, which will basically have those feature and the number of containers that you want for that to be supported with. You just have to specify the number, and Kubernetes will automatically take care how it deploys it in the backend, right? So managing multiple containers as one single entity became very simple for us after Kubernetes. Resource usage monitoring was also solved by Kubernetes. So with Kubernetes, what you can do is, for every container which is running, you can basically define how much of your computer resources it is going to utilize, right? And the moment the container utilizes more resources, what Kubernetes does is it deploys a new container, right? And that is how it basically does resource usage monitoring. Then we have networking. So networking is a fantastic feature in Kubernetes, wherein all the containers which are deployed on the Kubernetes cluster basically can interact with each other as if they were on one system. But they could be on 100 nodes or 200 nodes or 300 nodes, but still they can interact with each other irrespective of the fact that where they exist on the cluster. So that is also a fantastic feature. Then we have something called as rolling update. So if you want to update your application, you have the option of doing a blue-green deployment using the rolling update feature. Then we have something called as load balancing, right? So all your containers, if there are multiple replicas of the containers which are running inside your cluster, you can automatically load balance among these containers based on the request, right? That is also a feature which is there in Kubernetes. You have health checks, right? So health checks basically means if your container is not running as it was supposed to run, or say it is down, or the service itself is down, Kubernetes will take care to redeploy the container so that your service is always up, right? So you will never notice any downtime when your container is running inside Kubernetes until and unless there's some problem in the code, right? If your code runs fine, everything is going to run fine in Kubernetes. Moving forward, now let's discuss about how Kubernetes actually works, right? So Kubernetes, like I said, it's basically a cluster. So you have a master and then you have several nodes inside the master, right? The job of the master is basically to schedule containers on the nodes which are under it, right? Monitor the nodes, monitor the containers which are running inside each node, and also keep a track of the logs of what operations are being performed on each container, right? So basically the master plays an important role here of monitoring everything, of scheduling everything, while the workers or the nodes do the job of processing with whatever is required in your application. If it's processing, if it's sending API calls, it could be anything, and that is handled by the nodes. But Kubernetes is running on both the master and the node, right? And basically it's the same software running everywhere, and they can interact with each other as if they were one whole system. It is also very easy to add more nodes to the cluster, to an existing cluster. It can be done in a jiffy. All you have to do is there is one command that the master gives you once when it's initialized. Just save that command, and whenever you want to attach a new node to the cluster, all you have to do is first install Kubernetes on it and then run that command, and your node will automatically get joined with your Kubernetes master, right? So this is how Kubernetes actually works from the outside.
So let us begin with Kubernetes architecture. So basically Kubernetes follows a client server architecture. So basically there's a client, there's a server, you send a request to the server and it replies back, something like that. So along the ways, it follows a similar architecture to that. In this Kubernetes architecture, we have a master installed on one of the systems, and there are a lot of different slaves, as you can call them, or different nodes which are on the separate systems, and these are connected. So there's one master which controls everything, and there are a lot of slaves to it or different nodes to it which are created created on different separate Linux machines. So as you can, if you remember in our installation, when we tried using the AWS console, so what we did was we had multiple instances, out of which one we had as a master and rest of them we attached them with the token as a slave. So that's how the architecture is. And you can see the overall architecture here in this picture. So there is this one master node right here. Now master has different components to it. If you look at it, this is a worker node, this is another worker node, and here you can see a master node has an API server, a kubectl. A kubectl is basically a command line interface, which we'll be discussing on later. And there's an API server. So as a master, it has to host, so it has an API server there. And then there is a scheduler which can schedule different jobs, and there is a controller manager. So there are a lot of different things which can be controlled, which have a controller manager, which makes sure that certain things are created and maintained, if you will, for their requirement. And there is etcd, which is another part of the master component. And then in the worker node side, you can see there's a kubelet, there's a kube proxy, there are different pods, and then there is on above it, it's a Docker, but you can have any other containerization platform. If you have, you can create containers through that. You can use that as well. And then there is the internet. So we'll be hitting each of these individually one by one. So if you are starting off, so let's start off with the master. So we saw there was etcd, there was an API server, there's a kube controller manager, there's a scheduler, and there's a cloud controller manager. So we'll hit all of these one by one now. So basically etcd is something that stores configuration information, which can be used by each of the nodes in the cluster. It is a highly available key value store, which can be distributed among multiple nodes. Also etcd, the job of it is has to store all the configuration and the specifications, and it has to be readily available across all of the nodes, so that there's a constant availability of things and you know what is going on, right? So these configurations are accessible only by Kubernetes API server, as it may have some kind of a sensitive information. So it is kind of an encrypted area where you want to keep your sensitive information as a key value store, and it is a distributed key value store which is accessible to all. So this key value store contains all of the configuration information and other sensitive information that is required for it to run. So it this information helps Kubernetes node and server architecture stay alive, and it is just sometimes called as the brains of the Kubernetes, as it has all of the information which is required for it to run. And the next part is the API server. So as we mentioned, the API server is the one which is the only one that can access the etcd, right? So this provides all the operations on the clusters using the APIs. So there are different APIs. As we mentioned, it is a client server platform. So there's a lot of information which is all of the work which is done through APIs. So this makes sure that all the operations which are done on the clusters are done using the APIs. API server implements an interface, which means different tools, libraries can readily communicate with it. So it is a very key part of the architecture. And then there is a kubeconfig package along with the server side tools that can be used for communication. So what it basically does, that kubeconfig thing, is basically exposes the Kubernetes API. By exposing, I mean there are some things which stay internal and some things that you expose which is publicly available that you can see from the outside. So the kubeconfig package lets you expose your API so that others can reach it from the outside, right? So Kube API server is designed to scale horizontally. That is, you can scale more and more by deploying more and more instances. So if you want to scale the architecture, so in order to do that, you have to create multiple instances and divide your workload along it, and it scales horizontally. So it scales horizontally in that way. You can run multiple instances of a Kube API server and balance the traffic between those instances. So if you have multiple nodes, easily you can transfer whatever the traffic that is coming on, or whatever the request that the client is asking for, you can serve those by balancing those traffic throughout the nodes that you have with the help of the API server, as you have multiple instances. Coming to the kube control manager, it is the component on the master that runs the controller. Logically, each controller can be thought of as a separate process, but to reduce complexity, it is compiled into one binary and run as a single process. There are various components of the controller. So these are namely basically four kinds. First is the node controller, which is responsible for noticing and responding when the node goes down. So you have a lot of nodes. If you are creating like multiple nodes, so it has to make sure that all of the nodes are running. So our node controller's job is to make sure that it notices and responds when a node goes down. Then there is a replication controller. Now, when we'll be discussing YAML files, you'll see that you can have multiple replicas of a single pods, and you can have lot of like a pod can be thought of a set of containers, and those containers will have a lot of information, right? So if that container has your application, so you don't want one instance of that application to be running. You want it to have multiple instances. So let's say if I have a client which wants some service to be done, and that service is, let's say, image processing, and it converts image to black and white. It would be okay if I had only one customer. So now I have like 10,000 of customers, all of them requesting that their picture should be turned into black and white. But if you have only one instance, there will be a lot of traffic on it. So what you want to do is you want to have multiple replicas of the same pod. That is the pod which has the containers which basically turn the image to black and white. So what you want is multiple instances of that, so that each of them requests which are from your 10,000 clients can be served properly in a faster manner without having a downtime, and so that the traffic is also distributed. So the job of the replication controller is to make sure that if you define in your YAML file that I want, let's say, 10 replicas of this pod to be there, so it makes sure that there are always 10 replicas available, and if some replicas goes down or if it stops responding, its job is to recreate it. Okay, then moving on, there are endpoint controllers which populates the endpoint objects. That is, it joins the services and the pods, and it's basically making sure that the different endpoints of your application is running and they are in constant connection with each other.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the cloud platform are not used for DevOps implementation? A. Google Cloud. B. IBM. C. Microsoft Azure. D. Amazon Web Services. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Then there is a service account and token controller, which create default accounts and API access tokens for different new namespaces that you have. You'll understand namespaces in this module itself. We'll be discussing that in the add-on section. Now moving forward, we have a scheduler. Now scheduler is again a very key component of master. It is responsible for distributing the workload. So if you have a lot of workload, its job is to schedule it and distribute the workload. It is also responsible for tracking utilization of the workload on cluster nodes, then placing the workloads on which resources are available, and then accept the workload. So it'll look at the resources that are available, and then it will accept the workload, and then it's responsible for distributing it and tracking the utilization of whatever the resources that we have, right? So basically, in other words, what you can tell is that this is a mechanism which is responsible for allocating all the pods that are available to the nodes. So as I told you, there are a lot of different containers. So if you understand Docker, you know there are a lot. The basic container has a simple image. Now multiple of these containers together forms a pod, and this pod can be some kind of an application. So as I mentioned before, if we have multiple replicas of these pods, so there are a lot of replicas which can be deployed on a single node. And if one of the replicas is, let's say, busy or is down for some reason that it's facing some responsibilities, the scheduler is responsible for allocating these pods to different nodes and then making sure that if something is not working, then the work will be given to some other node. And that is the important part of the scheduler.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Then moving on, then there is a cloud controller manager. Now cloud controller manager runs the controller that interact with the underlying cloud providers. So in our case, it was AWS. It could be GCE, which is the Google Cloud Engine. And there could be a lot of different, you can use Azure or whatever the cloud that you are using it. So cloud controller allows the vendors code. So that is the cloud vendors, whatever is your cloud vendor, if it's Microsoft or Amazon, it allows that their code and Kubernetes code to evolve independently of each other. So it can, both of the codes are working, they're working simultaneously on the same thing probably. So it makes sure there is a coherence among these two while they're working as a single unit. So it is a very important part again. So the following controllers, cloud providers have their dependencies. So there is a node controller, there's a route controller, and there is a service controller and a volume controller. So there are 4 kinds in this also again. So the job of the node controller is for checking the cloud provider to determine if the node has been deleted in the cloud after it stops responding. So if it stops responding, its job is to make sure that the node, to determine if the node is deleted or not. And then there is a route controller. So the route controller basically is for setting up different routes in the underlying cloud infrastructure. So it's basically responsible for where the information goes from where to where and routing it basically. So basically what a router does. Then there is a service controller, which is used for creating, updating, deleting cloud provider load balancers. So like we have a scheduler for distributing loads in the master side of things, in the, let's say, pod side of things, or whatever we have. In the cloud side of things, the service controller is responsible for load balancing their traffic. And then there is a volume controller, which is for creating, attaching, mounting volumes. Now volumes are again can be thought of as storage, and it's a very this volume controller is responsible for interacting with the cloud providers to orchestrate these volumes. So as I told you, volumes can be thought of storage, like storage. So storage is there. So there's a lot of different storage. What you want is that your storage interacts or properly mounts and attaches itself to the cloud. So the job of the volume controller is for creating or attaching or interacting with the cloud providers and properly orchestrate, that is sending and properly giving the instructions, basically, if you will, to these volumes to properly work with the cloud. Then coming to the node side of things. So the Kubernetes nodes has three different parts. There's a container runtime, there's a kubelet service, and there is a Kubernetes proxy service. Now Kubernetes proxy service is another very key part of it. So let's discuss all of these one by one. Now let's touch upon the node side of things here. So the node architecture, as we saw earlier from the overall picture, contains of basically three major things. First is the container runtime, where we talk about different tools which are responsible for running your containers. Second one is the kubelet service, which is responsible for talking to etcd and the master and getting the information, which we'll discuss when we talk about kubelet service. And the final one is the Kubernetes proxy service, whose job is to make sure that some things are available to the external host without any hassle. So all of these things have been designed in such a way that it becomes a very hassle-free job when you're working with Kubernetes. So let's hit them one by one. So the first one on our hand is container runtime. So a container runtime is a software responsible for running the containers. And as I've mentioned earlier, that Kubernetes is a container orchestration tool. It is not something that creates the container. It is something that manages them. So you need to have a software that creates the containers. So that could be Docker, and I've mentioned here that Kubernetes supports several runtime containers, which is Docker container, and there is Containerd, there is Creo, then there is Archlet. There's a lot of different things, or any other implementation of Kubernetes CRI, which is container runtime interface. So you can use any of these to create your containers. So the first thing that is required in the architecture is a container runtime, something which creates and runs the containers. Moving on, the second part is the kubelet service. Now, this is a very small service in each node, which is responsible for relaying information to and from the control plane service. Now it interacts with etcd. So if you remember when we were talking about in master, that etcd is a distributed, highly available key value store which contains a lot of configuration information and specifications for your different deployments. So the job of this kubelet service is to interact with the etcd store and to read and store the configuration details. So it interacts with the etcd and it stores and reads and these configuration information, which is very responsible for us. It does more than that. What it also does is it communicates with the master component to receive the command and the work which is required for you to do. So the master and the node interact through this kubelet service, where it basically communicates with the master component. Then this process also takes the responsibility for maintaining the state of the work and the node server. So it does three very major things. It does interact with the etcd to get the configuration information. Then it interacts with the master to know what is the command and what is the job to be done. Then it also makes sure that whatever the specifications that we have read and what is the state of the work is required, it is there and the node is maintained. Finally, it also makes sure a few of the networking side of things, where it makes sure that ports are forwarded and the networking rules are well working and everything that is required. So it does all of that. So kubelet service is responsible for all the major networking related things. Then there is Kubernetes proxy service. Now this proxy service runs on each node and helps making the service available to an external host. So what does this mean? Let's give you an example. Let's suppose I told you before, right, that the pods are a set of containers which is deploying an application. Let's say I have two pods in one node, right? And both of the pods are mentioned as a replica of each other. Just what I've done is I've made a very small change in both of these pods, right? So since I'm an external person, I don't know where the pods are. I know where the node is. Maybe I know the IP of the node and I'm trying to reach that node, right? So what would be the information that I get? Will it be what it is inside pod 1, or will it be inside what is pod 2 or the container 2, whatever it is, or it is container 1 or it is in container 2? Which one do I reach, right? In that case, what will happen is when you don't know where it is, the job of the proxy service is to bridge that gap. Since you don't know where it is, it makes it look like you know where it is by routing you to the proper place. So if I hit the IP of a node, I do not know where actually the pod is, but the proxy service basically maintains that gap. It talks to the node and it communicates it to the pods and or the containers and gets back the information so that it looks like you are actually hitting the pods without actually hitting it. So it basically makes sure that that service, which is the whatever is inside your container, is available to the external host without actually them knowing where it is. It helps in forwarding the request to the correct containers and is capable of performing primitive load balancing. So as I was giving an example, so if I have two containers, if I make a very small change in both of them, let's say one says hello world and one says bye world or something like that. So the primitive load balancing that it does is if you hit that node again and again and again, there will be instances where you get hello world as the reply, and there will be some other instances where you get bye world as the reply. So that is the job of the proxy service, to make sure that you actually get informations from the container without actually knowing where the container is. Its job is to bridge that gap. Moving on, it makes sure that the networking environment is predictable and accessible at the same time. It is isolated as well. So it makes sure that it is predictable. So if I'm hitting a node, so I think it I should receive what I'm expecting. It makes sure that it becomes predictable, that I get what I want, and it makes sure that it's accessible. While I still don't know where it actually is, that is the time it's being isolated. So I don't know where it actually is, but I still receive the information with the help of this Kubernetes proxy service. That is the main job of it. It manages pods on nodes, volumes. Volumes are nothing but storage kind of things. Then there is secrets, which we'll be discussing on later on. So secret is something basically which you use to store information with an encryption. So if you have sensitive information like password and stuff like that, you can use secrets to pass that passwords on, or creating containers, health checkup, or whatever you want. Kubernetes proxy service does it for you. Now we'll be talking about the add-ons which are there in Kubernetes. So add-ons use resources like daemon sets, deployments, etc. to implement cluster features. These are all different features of a cluster that you can use because these are providing cluster level features. Namespace resources for add-ons belong within the Kubernetes namespace system. So if you have installed Kubernetes, right? You can just write Kubernetes get all pod -- all namespaces. You'll see different namespaces which are already available. Let me show you just before we begin. So this is my master. As we've been talking here in this slide, that there are a lot of different things which are there, and it will be available along with the kube system namespaces, right? So I'll just want to show you that if you type a very simple command, kubectl. Now kubectl, as we talked, is a command line interface that allows you to interact with your Kubernetes cluster, right? So this is there on the master. This is my master component. So kubectl get pods. I want to get pods, but what I want is, since I've not deployed any pods, so if I do that, I'll get no resources right now. It's because there is no default namespaces which is there. So what we want to do is we want to get all the namespaces. So we'll type kubectl get pods -- all - namespaces. We'll discuss about namespaces later on. So what you basically want to know is, like, if there is we define resources in different namespaces where they work. So if you type kubectl get pods -- all namespaces, we will see currently all of the different pods that are running inside of Kubernetes, which are responsible for its running, right? So as soon as I've hit, as you can see, these are all kube system. The namespace here of everything is kube system. Now this has Calico kube controllers. Now Calico is our basically our network manager kind of thing. This we installed, you have seen while we were installing it. There is an etcd IP, as you can see. There is Kube API server. Then there is Calico kube servers. There is kube proxy servers, kube scheduler, and everything. All of these information that we were discussing, core DNS and everything, you can see inside this is running, right? So let's get back to what we were talking about. So these are the different namespace resources. The add-ons belong within the kube system. So whatever the namespaces that add-ons that you will be adding, these all belong to the kube system namespace. As we saw, when we did all namespaces, we saw kube system, whatever namespaces it had. We did not add many add-ons in there, but there are a lot of different things still. So there is DNS. DNS is a mandatory add-on. So in my, if you can see my terminal again, this the Kube DNS was already present in here. This core DNS. This is still inside the Kube system. The core DNS is already present. So DNS is a important mandatory add-on which is there, but along with that there are a few other add-ons that you can use. There is a web UI dashboard. There is a container resource monitoring tool which you can use for monitoring how the status of your containers are right now. Then there is cluster level logging also. We'll talk about that, all of these in detail in the future modules, but we'll give you a zest of it now because we'll show you even how to set up your web UI dashboard for Kubernetes. We'll even show you how to monitor these resources, which we'll be using for using Prometheus and Grafana, where Grafana is used for visualizing those information. There is cluster level logging. We'll show you all the logs and stuff as well in the hands-on in the future modules. But just now we just need to give you a zest of things, so we'll explain it to you here. So starting off with the DNS. Now cluster DNS is a DNS server in addition to other DNS servers in your environment, which server DNS records for Kubernetes service. Containers started by Kubernetes automatically include this DNS in their servers. DNS server in their DNS searches. So I was telling you, this is a mandatory add-on. This you need to have if you want to work with Kubernetes. It's already present, predefined in it already. But the other things which we are going to talk about in these add-ons, they are not very necessary when you're working with it. It's a good thing to have them as well because it helps you work better, faster, and in a more informative way. But this is something which you actually require. Moving on to the web UI dashboard. Now dashboard is a general purpose web-based UI for Kubernetes clusters. It allows you to manage, troubleshoot applications running in the cluster as well as the cluster itself. Even you can, when you go with the web UI dashboard, which we'll show you after on. So all the concepts that I'll be teaching you how to run through a command line interface, you can do most of it through the dashboard as well, but we'll be teaching you command line interface because it is important for you to learn how to use command line interface when you're running with the Kubernetes, because it gives you a better zest of things, and not all the production environments that you'll be working with will allow you to do dashboard based things, right? Moving ahead, there's a container monitoring resource. So container resource monitoring are generic time series metrics about containers in a central database, and it provides UI for browsing that data, right? So for this, you can use a lot of different tools again, but what we'll be showing you in this course is using Grafana as well as Prometheus and Helm, where Helm charts are used to get data through Prometheus, and finally, we visualize those data through Grafana. So we'll be showing you that as we go along the modules. But basically this is used to see how your nodes are performing, how their health are, and how many of them are getting killed and they're restarting and stuff like that. All of that data you can get and monitor your containers, right? Then there is a cluster level logging. Now cluster level logging mechanism is responsible for saving the container logs to a central log store with search/browsing interface. So all of the containers that you have, they have logs of their own, right? So what you can do is sometimes when you want to receive some information or when you're trying to troubleshoot or debug something, you need to have the information of what your container has been through. So cluster level logging mechanism is responsible for that. It stores all of the container logs to a central log store with search browsing interface. Now next is kubectl. Now kubectl I'd say is not just add-on, it is again a very mandatory add-on. It is a part of the master, if you will. It allows you to basically communicate or interact with the Kube API server and send commands to the master node. Each command is converted to an API call. As you saw in the example that I showed you, I had a command line interface that was my bash terminal, and there I typed kubectl get pods. Now that is a command. Now that command is turned into an API call, which is through the API server. It is sent to the nodes, and then according to whatever the command is, there it reads the information and it gets back the whatever the information that they have to give on our command. Like if I give the command, so they have to give me the information regarding that command, right? So that will come back through there, and all of this is then my information that the command that I want to pass through the master is given through kubectl. I give my commands through kubectl to the master, then the master gives it to the nodes through the API server, and through the API server these are responding and everything works through APIs and all of the API calls are made, and then finally you get the result, right? Kubernetes is one of the most sought after container orchestrating tool in the world right now. Almost all of the organizations who are using containers are using Kubernetes as the tool to orchestrate those containers, and hence kubectl is an integral part of it, where you can use it as a command line interface to interact with your Kubernetes cluster. So the first command is create. So what do I mean by create? So basically, what I mean by first command is the simple fact that if you see on your screen right now, the kubectl will be the starting of all of these commands. So the first word that you write will be kubectl. So it basically tells you that this is being interacted with the help of kubectl. So kubectl will be there, and the first thing that you write after that is create. Now, create is a command which is used to create resources from a file. It could be of the file .json, or it could be of the type .yaml. Either way is accepted. Other use for create is also there, so you can use create to use a lot of different things. So in this, when you are using with a file, the syntax is kubectl create -f and then the file name, and it creates those resources inside of those files. But create can be used to do a lot of different things. You can create service loads balancers, service node port, service account, cluster role binding, config map, cron jobs, deployment, namespace. All of these things can be created using this command. There's another thing that you can use to create files configuration as well. So you use kubectl apply, and using that apply, you can apply some configurations to your cluster as well. So that is something else that you can use. So you can use for creating resources from a file, you can use create or you can use apply. So let's quickly try creating a file using kubectl create. So I have my Kubernetes cluster here up and running. I only have one node right now. Let me show you that really quickly. Kubectl get nodes. So this shows you the number of nodes I have. Just wanted to show my cluster is up and running. Now let's create a file. So I have a file ready in here. So this is a YAML file for deployment. So a YAML file for deployment, basically this has the specifications of the deployment that I want to create. So it has the name of the the kind is deployment, and the name is Nginx deployment. That is in the metadata, and it has 3 replicas. So basically it will spawn 3 pods, and you have another match labels, you have images, you have container specifications and things like that, right? So let's create this file. So in order to do that, I will switch to my terminal really quickly. I'll have copied this. I'll move to my terminal really quickly. Now in here, I will type the command nano t2.yaml. I'll just paste this particular YAML file which I have really quickly. And once I've done, I will just save it and I'll exit. So my file is ready. Now what does the command say? The command says kubectl create -f file name. You can see right here, right? Kubectl create -f the file name. So we'll do that. Let's quickly go to the file. Kubectl create -f and the file name, which is t2.yaml in our case. Once I do that, you can see the deployments has been created. Now, if I check for pods, so I have 3 replicas in my deployment, right? So I have 3 replicas in my deployment. You can see, so it has created the deployments and it has created everything. So you can check by kubectl get deployments. This is Nginx deployment, which was created, is up and running. Cool. Let's move on to the next command. So I was talking about this, right? So you can use create to do a lot of different things. Like you can create a cluster role, you can create role binding, secret, a lot of different things. All of these things which are mentioned here can be done with this. But the syntax will be a little bit different from what we did just now. So I have that syntax ready for you as well. So if you wanted to say, let's say, create a deployment with the name and you can give this image. So the syntax for it would be kubectl create, then whatever that you want to create. So if this was a deployment, it's a deployment here. If it was a cluster role, it will be cluster role. If it's a secret, it will be a secret. Then here the things will change accordingly according to whatever you are creating, right? So this will change. For deployment, it will remain deployment's name, and -- image, and whatever the image that you are pulling, that image, and then the commands and arguments. So like for example, you can do kubectl create deployment and call it my deployment, and image of Nginx and replicas equals to 3. So let's see what happens when we run this command. So let's bring up our cluster, kubectl create. Let's bring on top of it so that it's better for you to understand. So you can see kubectl create deployment, and name it deployment. I will say name it my dep -- image equal to Nginx -- replica equal to 3. Let's see what happens. As you can see, a new deployment is created with the name of my dep. So if I do kubectl get deployments, now I have another deployment coming up. As you can see, the nginx, which was created when we did the before one, and mydep, which we created just now, has been. So you can use create commands in the way to create something from a file, or you can create some another resource with some arguments and some names and everything that you have to keep in mind about the syntax. Using these syntax, you can do this. So this is one of those commands. Let's move on to the next command, which is kubectl get. So we've been using get now exclusively. So we are doing kubectl get pods, kubectl get pods wide, and different things like that. So basically, get command, what it does, it prints a table of most of the information about the specified resource. For example, when I was doing kubectl get deployments, it was getting the information with respect to the deployments. You can filter the list using the label selectors, and you can use selector flags, and you can do a lot of different things. So let's say if I wanted to get deployments from a particular environment or namespace, we can do that as well. So that can be done. If the desired resource is in the namespace, then only you will see those results, otherwise you will not. And if you want to see all namespaces, then you have to pass the parameters, which is -all namespaces. Let me show you how that works. So the basic syntax is kubectl get and the resource name. So let's start with the basic one. I'll show you all of these commands really quickly. So kubectl get pods. You can even type get po, and that will also work for pods. I'll show you. Get po. Oh, sorry. Kubectl get po. This will also work, and kubectl get pods will also work. Both are the same thing. You can see same results. So we are getting pods like this, right? And let's say if you wanted to get some particular pods and you wanted to pass some particular thing, then you can have that as well. But let's say if I wanted to, this is getting me all of the pods in the default namespace, because that is the namespace that I've designed. But let's say if I wanted to see pods of all namespaces, so what you can do is kubectl get pods -all namespace and pass this parameter. You can see the S was missing, namespaces, it's namespaces. So you can see all of the pods which are there in different namespaces. You can see which all namespaces it belongs to. So default ones were the one which were coming here, and their cube system is another namespace which we have, and you can see all of the pods which are there in various different namespaces. I have started also spawning, right?
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What are the key components of DevOps? A. Continuous integration. B. Continuous testing. C. Continuous delivery and monitoring. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
You can do that as well. Another thing that you can do is kubectl get pods -o wide. Now what's that command? We've seen something here which is -o wide. So this basically returns you all of the pods with more information, like all the pods which you have in with more information. So you can see before what we were getting is, let's say, the name, the status and restarts and the age. Now we are getting all of those plus the IP plus the node that it is on plus the nominated node and readiness gates. So we have all of the information coming in, and that is with the -o wide. So if you want to get more information with respect to any particular resource, then you use the flag -o wide, right? So that's that. And you can get services, deployments, anything. So you can get kubectl get deployments. We saw that before. You can also get services, kubectl get services. You can get ingresses. You can get basically anything that you want, which you can if you want to print something. There's like a print statement for the resources that you have, and that is how it works, right? So that's that. Let's move on to the next command. So we got done with get, right? So next one is expose. Now what you can do with expose is like whenever you have a Kubernetes service running, right? So if by default it is on like the cluster IP interface, and your deployments and everything which are not on the exposed end, it is not reachable externally. So let's say if you wanted to expose a resource as a service to an external point, then you use the command expose. So basically it looks up a deployment service replica set replication control or a pod by name, then uses the selector for that resource as a selector, and it sends it to a new specified service point. For example, let's say my deployment, I have created a deployment right now, right? But that deployment resides inside of my cluster. Nobody from the outside world can see what is going on in there. That's the problem. What if I wanted to, make it externally reachable, so that somebody who can type in the port numbers or the link or the address, whatever it is, they can reach the particular deployment. So what I'll do is I'll expose that deployment as a service at some given particular port, and using that I can reach it externally. So let's try to do that. So the basic syntax for that is kubectl expose, and then you can have the type or the file name. So for example, here the deployment is the type name of the resource that we are providing, deployment and the deployment's name then you have to give. So deployment and deployment's name is nginx, and -- port 80, that is the port that it is currently serving on, and the target port is 8000. So you have to provide both in order to do that, right? So you can do that really quickly. So let's expose us deployment that we have right now. So I'll open. So let's run this command. So kubectl first let's get the deployment. Okay, we have the name of the expose deployment. Let's say mydep. We will expose mydep -- port equals to 80 -- target port equals 8080. You can see a new service is created. So if I do kubectl, now to get service, you can again type get svc or get service, both will work. You can see a new service has been created with the name mydep, which was the name of my deployment, and it has been exposed to a port 80, which was there initially, right? So that is the idea behind it. So that is how it works. You can also expose it as a particular type of service, which can be externally reachable IPs as well. That can also be done. So, but that is not required for now at the moment. But just know that you can expose your deployments as a service. So my service deployment was exposed. So my deployment was exposed as a service on the port 80, right? So that is that. Let's move on to the next command, which is delete. Now what you can do is you can delete some resources as well. So a lot of times you will be requiring to delete resources, and it depends on what you're deleting that will determine what all will be deleted. So let's say kubectl delete, and then you can have the file name -f file name, you can have -k directory, you can delete an entire directory, or you can have a type or label and you can delete particular things. For example, if you wanted to delete pod, so kubectl delete pod, and then the pod name will delete a specific pod. But let's say if I wanted to create everything created by my deployment, so that is my deployment should also be deleted. My number of pods created through that deployment should also be deleted. So I can delete a file. So kubectl delete -f t2.yaml will result in all of my deployments with respect to the nginx deployment being deleted, as well as all of the pods which were created will also be deleted. So and you can delete things with the help of label as well. So you can see this example in here, which is on the bottom left side of the screen. Kubectl delete pods, services -l. So you are deleting pods and services which have the label where name is equal to my label, or by the label name equals to my label. So wherever this exists, all of those pods and services will be deleted. So you are passing it as an argument. So these particular things I want to delete. Let me show you these really quickly so you get a better understanding of things. So first, let's try to delete the deployments that we have. So let's see what all do we have. So kubectl get deployments. So we have 2 deployments right now, and kubectl get pods. And you can see we have 3 pods coming from the nginx deployment and 3 pods coming from the mydep deployment. This is according to the replicas that we created initially. Now let's say that I wanted to delete the nginx deployment and all of the pods associated with it, right? So all of the pods associated with it. So what do I do is kubectl delete -f t2.yaml, because these things I created through a YAML file, right? So I'm going to delete that particular file. So what happens? Let's see. So you can see it has deleted the deployment. So if I get kubectl get pods now, terminating, you can see. And if I do kubectl get deployments, only one of the deployments is remaining. If I do get pods now, you can see my nginx 3 of them have terminated, only 1 is remaining. And in a second, I think the last one will also be gone. So that is basically how you can delete all of the everything which is created from that file will get deleted if I do that, right? Now, what if I wanted to delete a particular pod, right? So let's say kubectl get pods. So this is the mydep pod name. So this is the pod name. So if I do kubectl delete pod and then the pod name, so you just copy that. So the problem with this one will be that since it's a deployment that we created, that is the mydep is a deployment, so it will keep respawning the pods. But you can see, just notice the name 4DZZ4, it will not be spawning once we delete it. Let's see.
So it has deleted a pod. It'll take a couple of seconds. We'll just give it a couple of seconds. So it has deleted a pod. So if I do get pods now, I will still get 3 pods from the my deployment kind of thing, but none of them would be this particular pod that we deleted, like 4DZZ4. You can see that particular pod is deleted. Since that is the feature of deployments that we keep on, it will, once we specify, let's say I want 3 replicas at all time, no matter if it gets deleted or it stops responding or whatever, Kubernetes has this capability where it respawns the pods constantly. So that is the advantage of using deployments. That is why people prefer using deployments. So if your pod fails for some reason, Kubernetes automatically restarts a new pod for you. So that is that. So this is the kubectl delete command. Let's move on to the next one. So the next one is autoscale. So you can give a command to autoscale. So you can autoscale your deployments, and basically it creates an autoscaler that automatically chooses and sets the number of pods that run in Kubernetes cluster, and looks up deployment, replica sets, stateful sets, as well as replication controller. So all of these four you can autoscale, and it basically gets them by the name and creates an autoscaler that is given with for the resource as a reference. So let's say if I say I want to autoscale deployment and then deployment's name, and I will define how many minimum or maximum pods I need. So this is basically done because let's say if you are Grofers or if you are Flipkart or Amazon, you don't get the same number of people trying to access your website every single day, right? It will not happen that every day you will get the same amount of traffic, but sometimes, let's say during a sale period or during some festival season, you will get a lot of traffic coming to your particular website. So how do you know that when it's going to hit, and how do you autoscale? So you can basically tell Kubernetes that whenever, let's say there is huge amount of traffic coming, so let's say if there is something you can define. So if let's say my pod can handle 3 requests at the moment, and for example during a sales season that 3 becomes 6, my Kubernetes autoscale command will basically enable my pods. So let's say I have only 3 replicas, it can automatically scale up to 5, 6, 7, 8 just to serve the requests. It can basically do that. So it has that capability as well of auto scaling. So you can do that with the help of Kubernetes as well. Let's move on to the next command, which is scale. So I'm moving on to the next command because I cannot show you auto scale right now. I can show you scale. I can show you how you can improve the replicas. And basically what you have to do is you can scale for a new size of a deployment, replica set, replication controller, or stateful set. Works for all of these 3, and basically allows you to specify 1 or more preconditions to scale also. So whatever you need, you can replicate that as well. And basically if you wanted to manually increase the number of replicas that you have, then you use the command scale. So very simple command. So the syntax for it is kubectl scale, and the resource resource version equals to version, and then current replicas count, and then the replicas count and file name and type. So let's try this out. Let's see how this works. So I'm going to be opening my terminal again. So I have a deployment which is running, which is my dep. So kubectl scale replicas equal to 4, and then it says to write the file name and or the type, right? File name or the type name. So replicas equals to 4, and then we are going for my deployment, which is of the name my dep. Let's see. As you can see, it says the deployments was scaled. So I had 3 pods running before. Let's see what happens now. Kubectl get pods. Sorry. As you can see, 1, 2, 3, 4. It has scaled my number of replicas just by a ping of a command. And you can do the same thing with the help of autoscale, where you can define the number of replica sets that you want. You can, in here you can define minimum 2, maximum 10. So at all times it will be minimum of 2, but based on the service request, it can be scaled up to the maximum of 10 to serve all the service requests. So that is the use of the scale command. Okay, let's move on to the next one, which is called describe. So as the name suggests, it's prints out a detailed description of the selected resources, including the related resources, events, controllers, and whatnot, right? So if you are going to get the detailed information for, let's say, one particular resource, then you use the command describe. The syntax is pretty simple and pretty straightforward. So you type kubectl describe, and then you write the type of the thing that you want to describe. So let's say if it's a pod, so kubectl describe pod, and then pod's name. So whatever pod you want to describe, you mention the name, right? And if it's a service, then you write kubectl describe service and then the service name, kubectl describe deployment and then the deployment's name. So whatever it is, then you go ahead with that, right? Let's quickly dive in and see how that works. So we have, I'll clear the screen so that, because the describe will give you a lot of information, that's why. So kubectl get pods, that is just to get the pod's name. So that's that. Kubectl describe pods and then pod name. Right? It returns the entire information with respect to the pod. So everything for this pod has been here: the name, the namespace that it is in, the priority it has, the node where it is residing, the start time, the labels it has, the annotations, the IP, the controllers, the ID, container ID, image ID, and what ports it is on. If it is being pulled, restart counts, when was it, type of the conditions like initialization is true, container is ready, true, pod schedules true, and normal everything, all of the events that has happened with respect to this pod, and everything, the volume mounts and everything about this pod you can find in here. That is what describe is used for. So when you want detailed information of a particular resource, you go for describe. That is the basic idea behind that. Let's hit clear and move on to the next command. So next command is logs. So basically logs, as you can suggest, it prints the log of a specific pod or a resource, and if the pod only has one container, then the container name is optional. So when you can have pods with multiple containers also. So if they are multiple containers, then you would have to specify the container name as well. But if you have only one container, then it's fine, right? It's optional then. If you wanted to get, so the syntax for it is kubectl logs, then -f, -p, depending on whatever that you are using, the pod and or the type name, and the container name that you want. So if you want to get all of the containers in a pod by the label app equals to nginx, then what you do is kubectl logs, then -l for the label, and then the app equals to nginx all control containers equals to true. So what we'll do is we'll try to get logs of one of our containers, and let's see how that looks like. So it's kubectl, let's get pods first, that we can copy the pod name. Yep. So kubectl logs -f pod, because I think we can give the type name. Yeah, so we can give a pod or type name pod, and then the pod name, which is, let's say, this one. And since I think it has only one container, so I don't think I need to give the container flag, so it should work. Maybe we don't need to specify pods in here. So you can see the logs with respect to this has been printed. So you don't need to give the name, you just need to give the name of the resource and it will work. So that was the logs for this particular thing, right? So don't need to give that, and you can directly go ahead with that. We could have given some label, but we just went with the resource name, right? So that is that. Let's move on to the next command, which is exec. Now exec is something which is used to execute a command. Even you can use exec to get inside of the containers as well. So you can get inside the containers, you can change different resources in there. So you can use exec command for that. So basically any commands that you want to address, you use the command exec. And the syntax is very simple: kubectl exec, and then the pod or the type name, and then you have different flags which you can put in. For example, kubectl exec my pod, and -date, it will give you the running date of the pod. Let's quickly try that. Yes. Kubectl get pods, kubectl exec, then your pod's name, and then whatever the command that you want, right? It's not clear. I just wanted to move this here so that you can see the command, and the way I'm typing is the same. Exec, and then any pod name. So go with this pod, go with this pod, -. You can see Wednesday, deck 9, everything with respect to that has been delivered.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Nagios is nothing but an open source software which helps us in continuously monitoring applications which are running on remote hosts, right? For this, Nagios follows a master-slave architecture. There is one server on which Nagios is installed, and the others are basically just normal systems on which applications are running, right? So in order for this Nagios server to interact with the services which are running on some other server, you have to install some plugins on those servers, on those hosts which wants to get monitored, and these plugins are chosen based on the platform that they're running. For example, are they running a Windows platform, or are they running a Linux platform, right? Now, what all can you monitor with Nagios? So as you can see over here, you can create monitoring service for literally any kind of things. You can monitor printers, you can monitor applications, you can monitor switches, network switches, right? And you can monitor hosts, right? You can monitor literally anything in Nagios which is in the computer realm and is running on a remote host. What are the components of Nagios, right? So there are basically three main components of what make Nagios the most effective continuous monitoring tool. So the first component is the Nagios GUI, then you have the scheduler, and then you have plugins in Nagios. So let's understand this one by one, right? So let's first talk about the Nagios GUI, guys. So inside, basically the GUI is the web interface that Nagios offers you, and that is basically a dashboard for you on which you can monitor all the services which are running on different servers that you have attached to your Nagios server, right? And also you can have a look at all the hosts which are connected to your Nagios server, right? So along with checking them, you can also have a look at their status. You can also have a look at the logs. All of that is possible inside the Nagios GUI. So basically Nagios GUI acts as a front end for you, right? The second component is a scheduler, right? Now scheduler itself is again a very main centric component of Nagios, which basically does all the work of scheduling, right? So what has to be monitored and when exactly it has to be monitored. For example, you are basically monitoring the ping service of a server, right? Now, when do you have to manage it, right? So at what intervals you'll have to go ahead and check whether that ping service is working or not, and what exactly do you have to manage, right? If, for example, ping you have to manage, what all other services you have to manage, and what all servers you have to manage it on or monitor it on, right? So that all of this job is done by the scheduler, right? And then you have plugins. So basically, when you talk about monitoring hosts, talk about monitoring different servers. So if you have like 1,000 servers in your company that you have to monitor, it's not that you have to install Nagios on the servers that you have to monitor. For example, like I told you guys, you need a Nagios server. So your Nagios server will basically take care of all the monitoring part, right? And with your Nagios server, you attach your application servers, right? And your application servers are basically going to have some plugins. So you don't have to install Nagios on them, on the application servers. All you have to do is install a plugin on it, right? And those plugins are called NRPE plugins, right? You install it on them, and using the NRPE plugin, what the scheduler does is the scheduler basically sends a request to the NRPE plugin along with the command using which it has to monitor that particular host, and the NRPE plugin basically helps the scheduler to get all the log related to that particular service which was requested. And once the logs have been received by the scheduler, they get forwarded to the GUI part of Nagios, and then that Nagios GUI then represents the log in terms of their status, in terms of graphs, in terms of many other useful visualization techniques through which you get to know how your host is performing in terms of its hardware, in terms of the application which is running on it, and etc. Right? So this is how basically the Nagios architecture works, guys. So Nagios follows a master-slave architecture. All your hosts are on separate machines, right? And your Nagios has a dedicated server for it. You can also have applications installed on the same system as the Nagios is installed on, right? And Nagios has the capability of monitoring its own services as well. But usually when you talk about it in production environment, or you talk about how companies use it when they're dealing with monitoring application, it always happens on a scale that you have a Nagios server, and beneath the server you have a lot of hosts which are basically hosting your application, getting monitored by Nagios scheduler. So let me quickly jump on to my browser so that you guys can see that we have two hosts right now, localhost and slave1. This we already did in the last session where I showed you guys how you can add a host to the Nagios server, right? Which the host which is being monitored. So right now the status of this host is that it is up and running, right? Now what I want to do is I want to create a monitoring service which for an application which will be running on this slave. So what I'm going to do, if I go to services right now, I can see there are no services which are monitoring any application which is running on the remote host, right? So what I'll do is I'll first install a service called sudo apt get install Apache 2. I want to install an Apache service which I can monitor in Nagios for this particular server. Okay, so Apache is getting installed. Yes, so Apache is installed now. Now if I go to the browser, I should be able to see for the Nagios slave an Apache service, right? So Apache page is working. Now what I'll do, I'll go to my server, right? Let me just clear the screen. And now I will go to templates, or let's go to templates, or let us go to localhost configuration first, right? Now in this localhost configuration, you will find a service for, right? So I want this service to be copied. I'll just copy this service, right? And what I'll do, I'll make changes to this particular service and I'll make it a service for monitoring the HTTP connections. So what I'll do now, I'll just go to the configuration file of my host 1, right? And I'll paste the service over here. And let's make changes to the service now, right? So this is the service. Now we want to use a template for the service. Let's say it's not a local service. I'll say it's a generic service. So there's a template for generic service inside templates.cfg. You can have a look at that. The host name for this service would be the same as the host name for your host. So the host name for my host is slave1, right? So I'll write exactly slave1 in my service as well. So I'll do that. I'll call it slave1. Service description, what do I want this description for this service to be? Check Apache. Okay, and the command for this particular service would be check _ HTTP, right? So this is the official command for checking the if anything is running on port 80 of any computer, right? So you can have a look. If you want to try some other application that you want to monitor, you can just Google out the service or the command that you would use over here to monitor that particular application, right? And most of the times you will get a command. In case you don't get a command, just Google how you can define a command for basically monitoring the application that you want, right? Now all you have to do is, if you find the right place where you just have to create a command, go inside commands.cfg, right? That is there in your etc directory. And inside the commands.cfg file, all you do is create that command, and which I'll show you in a moment, the way to create a command, and then you can use that command over here as well. So check _ HTTP is already a command which is existing in my Nagios server, and I'll show you the definition of this particular command when we go in commands.cfg. For now, the service is ready. So what I'll do, I'll just save the service, right? And now I'll just restart the server. So for restarting, this is the command. I'll pass this command. So my Nagios server is now restarted. Now if I go inside hosts, I can see slave1 is up. Now if I go inside services, I can see that slave1 now has a service which is in the pending state, right? So what will happen, it will basically take like 2 minutes for this to refresh and to check whether a service is actually running on port 80 of slave1. Okay, so let's give it that time and then check after some time. Alright guys, so as you can see, the service that we defined is now under the status of OK, right? So now my service is running fine, and you can check the status over here that HTTP is OK, and 11,192 bytes were responded back to the request in 0.002 seconds. So you can get all the performance details here. You can see that the service is up and running since the past 5 minutes. So I think it took around a good 2.5 minutes for the service to turn green, because Nagios took that time to basically analyze if the service is healthy or not. Alright. Now similarly, if I disable the service, you will be able to see that in another 2 minutes, this server will go into critical state. Right. So let us do that. I'll just go to my terminal and I'll say sudo service apache 2 stop. right? I just did that. And now if I go to the IP address, I can see that the page is no longer coming. Now it is 5 minutes 39 seconds right now. So let's see 6 minutes 45 seconds right now. Let's see when our service gets into a critical state. Alright guys, so as you can see, the status has now changed, and it says that the status has changed since the past 18 seconds, right? So it took a good 4 minutes for this service to go into critical state. I guess that's how long Nagios checks in intervals as to whether a service is working or not, right? So as you can see, it says connection refused, reason being now Apache is not running on that particular system. Alright guys, so this is how you create a service in Nagios, and similarly you can create any kind of service for your particular application that you want to monitor. Right, all you have to do is either check if you have an internal command which is going to match for your application, or you'd have to create a command for yourself using some plugins, right? So all of that can be checked online when you're working, because there could be zillion applications that you would be working with. Having a look at all the applications is difficult, because with everyone they'll have different kind of needs for the kind of applications that they are monitoring. Okay. Alright, so I forgot about one thing. Let us also have a look at how you can create a command in Nagios, right? So let me jump back to my terminal. So all I have to do now is I'll have to go inside commands.cfg, right? So let's go inside it. So we use the command check_HTTP, right? So let's first that command first. So if you go inside commands.cfg, you will have all these commands over here. Notify host by email, then you have check host alive, then you have check local disk, check local load, then you have check local procs, check local user, check local swap, check local MRT, check FTP, right? So all these commands are then being mapped to their command line usage. So if you pass this command, this command is basically being passed on your Nagios host if you are using the command check FTP. Okay, then you have check HPJD, check SNMP, check DSP. What I'm gonna do is I'll just go click on where is, and I'll search for HTTP. Okay, so here I get it. So on this command, you can check that if you want to define this command, the command name is check_HTTP. The command line for this is $user1 and then check HTTP -i host address $argument1, right? So this is the command which you are using when basically you are just calling check_HTTP while defining a service. So basically what you're doing is in your service, you're basically calling the check_HTTP command, which in turn is calling this particular command, which is being passed on to the command line, through which you are able to check whether HTTP is working or not, right? So let's define a command for ourselves. Let us call this as command name would be command_name. Let's call it test_HTTP. Okay, and the command line for this, the command line command for this would be this. Let's paste it, right? And let me just align it. All right, so this is done, and now basically all we have to do is close the brackets, save the file, right? So the file is saved, and now let's go inside sudo nano host1.cfg. okay, and now I would want to create a service, right? Let's name this service as, we'll use everything which is the same here except the command. So we'll just go down to the earlier service that we created. We'll just copy everything, paste it here. So we have to paste this commands here, and then we'll close the brackets. The check command will now change to test_HTTP. The check Apache, let's change the text to check Apache test, right? And everything else will be the same. Okay, now let me show you one more thing. So you can also control the interval in which Nagios is basically checking your command. So what you can do is, let me just save the file here. We'll go to templates.cfg, right? So let's go inside. So we're using the generic service template, right? So let us go inside sudo nano templates.cfg.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the cloud platform are not used for DevOps implementation? A. Google Cloud, B. IBM. C. Microsoft Azure. D. Amazon Web Services. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And now let's try to search for generic service. Right, so here it is. So the generic service is defined like this, that you have check freshness is 0, notifications enabled is 1, event handler enabled 1, flap process performance data, and you can check over here that in check interval it's 10 minutes, right? And the retry interval is 2 minutes. So if the service is normally functioning normally, in that case, it should check for the freshness of the service, or check whether the service is again working or not in 10 minutes from the time that the service goes down. So let us change this to 1. Or what you can do is you can also change this when you're calling this service. So let's change it over there. So basically you have to remember that this keyword, which is check underscore interval and retry underscore interval. Okay, so let's go out. We're not going to change anything here. What I'm going to do is I'll go to sudo nano host 1 underscore cfg. And now in the service, I'll specify retry underscore interval. And I'll give that number to be, say, 1 minute, right? Similarly, what I'll do, I'll say check underscore interval. And I'll again specify it to be 1 minute. So every 1 minute, even if the service is up and running, it will check if the service is running now. If not, it will retry again to check the service whether it's up again or not in the another 1 minute. So with this, you should get a faster response onto when your service will become okay on your Nagios dashboard. All right. So we have specified this. So we have changed the services. So let's save the file now. So I'll save the file like this, and now I'll restart Nagios. So let's search for that command. Here it is. I've restarted Nagios. And now if we go inside the browser, here's my browser. What I'll do is I'll do a refresh. I'll go to services. And now I can see there are 2 services which are running. So because we stopped the Apache service on our server, that's why it is saying it's in a critical state right now. So what I'm going to do, let me go here and so we'll start Apache server, but first let's wait for this pending state to become to critical. So what I'll do, I'll just click refresh once again. I'll go to services and let's wait for this service to become critical. In that case, what I'm going to do, we're going to see that in how much time it becomes okay from the time when we basically up the service. All right. So let's wait for this to become critical. All right. So as you can see, the service is now critical, and what we can do now is we'll go to this system and we'll start the service now. So I'll start the service like this, right? So this service of mine, which is check Apache, is basically working at 10 minutes interval and 2 minutes retry time. On the other hand, this service, which is check Apache test service, is retrying at every 1 minute and checking the service also at every 1 minute. So let's see if there's a difference that we see over here. So we'll just refresh it and see which service becomes up and running again. Alright, so you can see that my check Apache test is already in the OK state now, right? So it became OK faster than the check Apache service. If I again refresh the service, I can see that my check Apache service is still in the critical state. Reason being, the check interval in that case I did not configure, and it took the default values of my generic service template, which had 10 minutes of check interval and 2 minutes of retry. Right? So basically, if this state is in the retry state right now, it should take around 2 minutes for this to become okay, right? On the other hand, my Apache service, because my check intervals is just 1 minute and even my retry interval is 1 minute, it became okay faster because Nagios is now checking the service pretty early than the way it is checking it with this particular service. So if I again click on these services, I can still see that this is in a critical state, and check Apache state is in a OK state. All right. So this was it for this session, guys.
Now, I've told you about a lot of things that you have to know. Now, some of you might have already, these skills that I just discussed about. Some of you might not have these skills or might have some skills in the list that I told you. And some of you might not have any clue as to, what skills I've just mentioned. But do not worry, guys, nothing is impossible. If you want to become a DevOps engineer and if you have the zeal to learn and if you are really interested in this technology, you can go ahead and prepare for this profile. Now let's talk about what all are the things that you need to prepare for, and I'll also tell you how you can go ahead and prepare it in a sequential manner. Okay, so first of all, you need to learn about DevOps tools. So if you are applying for a DevOps engineer profile, the first thing that should be really clear in what you're doing is about knowing the major DevOps tools which are a part of the DevOps lifecycle, right? What are those major DevOps tools? I'll be talking about it in a little while. But first, you have to clear your knowledge about all the DevOps tools. You should know about how they work with each other. And only then you should move forward and understand about programming languages, right? So if you are planning to learn Python, this is the time. Once you have understood all the tools in DevOps, once you have a knowledge about how those tools can work together in conjunction with each other, now you go ahead and learn a programming language like Python, right? And in Python also, there are a specific set of things that you have to learn. It's not about, picking up a Python book with 1,000 pages and starting to read about it. It's not like that. There are specific things which are actually used in jobs that you can learn. And I'll be talking about that also in a little while. And once you have that knowledge, you should then, take a deep dive into understanding Linux operating system. Now, when you're implementing the DevOps tools, at the same time, you will also have the option of, learning about or using some commands in Linux operating system, but you will not get a deep dive of how Linux basically works. So once you have the knowledge about how all the DevOps tools, how they work, right, and then you have the knowledge about programming language, you understand loops, you understand if statements, conditional statements, you understand about variables, data types. Now is the time to go ahead and understand how the Linux operating systems basically work. Okay, and once you've understood that, then you have to go forward and basically familiarize yourself with other programming languages which are also out there, right? Why? Because let's say you understand how Python works. Now, it could be that your company is not using Python. They might be using C++, or they might be using .NET. But the concepts that you have learned in Python will all be the same in all programming languages, whether it be object-oriented programming languages or non-object-oriented programming languages as well. They will all have loops. They will all have conditional statements, and the logic is going to be the same in any skill that you pick up when it's related to programming language, right? So this I will recommend you all when you are applying for a specific company. Then probably it's better to learn about the language that they have specified in the JD. It's better to just refresh yourself by all the syntax which might be there, and understanding the key differences between the programming language that you know for sure, like Python, and then comparing it with that programming language and understanding what are the behavior differences between the two languages. Okay. After that, you have to learn about cloud. So learning about cloud is also very important because most of the companies these days, they are now putting their infrastructure on cloud. So once you understand how DevOps tools basically work with each other, now is the time to implement them on a cloud provider like AWS or Azure or Google Cloud Platform. If you pick up one, I think that should be enough. So you can probably learn AWS because the chances of a company using AWS are more than Azure and Google Cloud Platform because AWS is the largest cloud provider in the market right now, right? Similarly, you should then go ahead and do a deep dive on tools like Ansible, which is a configuration management tool and is very important, right? Jenkins, which is the CI/CD tool, and it's probably the most important tools of all the tools which are there in the DevOps lifecycle, right? So first is Jenkins, then comes Ansible, and then Docker, Git, all these things, all these tools are there, which, it will not take much time of yours to learn these tools, but learning about Ansible, learning about Jenkins is a lot of scope, and you should focus more on these tools. And that's why companies specifically mention that you should be good at these particular tools. Okay. Then, like I said, cloud infrastructure is something that you need to go ahead and learn. Testing skills. So you're not expected to write test cases, but you should understand how a test basically works in a DevOps pipeline. So that is again something that you should go ahead and learn. So you should have passion, proactivity. So these are all soft skills that you need to learn. And finally, later, probably you can get to know about databases if you already don't know about them, right? But this should be the least on the list of things that you should learn, because databases is not something that you will be dealing with every day. And even if those companies have written it in their job descriptions, you will actually not be, asked about databases at all, right? You will be asked more about how, in different scenarios you can apply a different CI/CD rules, and what if a failure point happens in a CI/CD pipeline? What do you do then, or how do you handle that with the automation that you're implementing in the DevOps pipeline that you're creating?
Let's look at some facts, guys, right? So according to Glassdoor, the average salary of a DevOps engineer is $100,000 in the US. Now, this doesn't mean that you don't get salary above 100,000, but the average salary of a DevOps engineer is $100,000 in the US. According to payscale.com, a release manager, who is basically nothing but a DevOps manager, you can say, earns around 9,50,000 per annum on an average in India, right? According to Indeed, as of September 2019, that is our current month, there are 7,000 plus vacant DevOps engineering jobs that you can apply to. Okay, so this is the current scenario. This is the current scene in which you can get jobs for DevOps engineer. Moving forward, now let's talk about the average salary of DevOps engineer, what we have summarized from the previous facts. So in the US, the average salary is $100,000 in annum. That's what we just learned. In India, the average salary is 5,69,000. If we take into account freshers who are becoming DevOps engineers, even experienced people like a release manager or a DevOps architect or a cloud DevOps architect, all of them, the average salary which you get is 5,69,000 an annum. And obviously, I have friends who are DevOps engineers who are very senior. They must be around, when I say very senior, not in terms of the number of years of experience, but in terms of what all things they know. And they easily earn up to around 20 lakhs per annum, and even more than that, right? So if you talk about people who are 10 to 15 years experienced in the IT industry, they can easily get even up to 45 to 50 lakhs per annum. That is the upper limit that I'm telling you in India as a DevOps engineer, right? And in the UK, it's 62,500 pounds an annum. That's the average salary of DevOps engineer. So our first question asks us, can we explain the Git architecture? Now, this is fairly an important question, reason being, only if you understand the underlying basics of how Git works, will you be able to troubleshoot a problem when you face it and when you are working in a company as a DevOps engineer. All right. So let us try to explain what Git basically is and how its architecture is. Now, most of you might know that Git is a distributed version control system. Now, what is a distributed version control system? Let us explain it using a diagram. In a distributed version control system, basically your repository is distributed among the people who are contributing to that repository, and that is why it is called distributed. So that means that anyone who wants to make a change in the code that is present in this repository has to first copy this repository on his local system, commit the changes to the local file system of this repository, and only then he can push this repository onto push the code changes or the feature additions and everything to the remote repository, right? Nobody can work directly on the remote repository, and that is the main principle of how Git works, and that is the reason it is called a distributed version control system. Right? If you were to talk about the life cycle as to what are the steps to implement if somebody wants to say upload or change some code present in our remote repository. So the first thing that they have to do is pull the repository from the remote system. Once they have pulled the repository, it becomes their local repository. Change whatever files they want to change, and then once they have done with the changes, they will have to do a Git commit, or they'll have to commit the files to the local repository, Once the files have been committed, they will have to be pushed to the remote repository so that it becomes visible to anyone and everyone who will pull this project the next time. All right. This is how the whole Git architecture works. Now, I hope you guys understand what is the working of Git and what exactly is the architecture of Git. Moving forward, now let's talk about the next question, which says, in Git, how can you revert a commit that has already been pushed and made public? Right? So basically you have done some changes in the code. You committed those changes to your local repository, and now you have also pushed the changes to the GitHub repository. Now, if you have a CI/CD pipeline in place, which basically means that the moment you commit to Git, it automatically takes the code and deploys it on a server. If that is the kind of configuration that you have done, then probably the code that you have pushed has also been deployed on a server. And that is when you come to sense that the code is wrong, and you quickly have to change the code so that everything becomes working again. Right now, this is a very hot fix, or this is a very quick fix that probably every DevOps engineer employs whenever there is a problem in the production server. Right. So what is that quick fix? The quick fix basically says that whatever last commit was working perfectly, just roll back to that so that everything becomes normal until and unless you have fixed the new commit. That is basically the intention behind the revert procedure. Now, how can you implement the revert procedure? It can be implemented using the git revert command, and let me show you a quick demo of the git revert command so you know how you can implement it in a computer. All right. So this is my terminal, guys. Basically, I will SSH into an AWS server, and I'm in. So I have a GitHub repository that I have created for demo purposes. So like we discussed, the first stage in the lifecycle of Git is to clone the repository. So we'll just copy this address. One second. Yes. So we'll just copy this address, and then we'll come here and we'll type git clone and then the address. Okay. Now this project is basically a website that I created. It's a small website that I created. Now, in order to see that website, we will have to paste this code inside our Apache folder. So let us go inside our Apache folder, which is present in this directory. All right. Now I'll do a quick git clone along with the repository address, hit enter. And now if I do an ls, you can see that there is a folder called DevOps IQ, which has been created inside this folder. I will go inside DevOps IQ and do an ls. And you can see there's one more folder called DevOps IQ. All right, so let's go inside that. And now if I do an ls, these are the two files which are present inside my code base. Okay. Now, if you were to see what this website actually looks like right now, I can just go here and I can type in the IP address. So it's 18.222.58/DevOps IQ and /DevOps IQ. All right. This is how the website looks like for now. Now I have to make some changes so that the background becomes a little more better. So what I can do, I'll just go back here. I'll go do a nano and change the code of the website and say I'll change it to, I have an image in the images folder. Let me change it to 1.jpg. All right, let us save it. And once you've saved it, the next thing that you have to do is commit the changes to your local repository. And let us do that. So first I'll have to add the files to the repository. Now I'll have to commit the changes, and the message should say changed background. All right. So the changes have been committed, and now I'll push these changes to the remote repository. So it's HSHAR and the password is this. Now before making these changes, let me quickly show you the code that you are currently going to see before I push anything on this repository. So can you see the code is images/2.jpeg. I've changed the code to be 1.jpeg. So let me hit enter and let's see if our code gets changed over here. So now if I do a refresh, let me do a refresh. You can see the code has been changed just now. So it says 44 seconds ago, the code was changed. Awesome. So now because my code has been changed, if I go to this website now and hit enter, you can see the background is now changed. It is now a different background. Now what I want to do is I realize that this change that I did is probably wrong, and I want to revert to a particular commit, to the older commit that was actually working. All right. So what I can do is I'll just come back to my terminal. Let me clear the screen. First thing that you do is do a git log. So now you get a log of all the commits that you have made to this particular repository. Now this is the particular commit that you have particularly applied right now, and this is causing you a problem. So just copy the commit ID for this, and now just go ahead and do a git revert. So git revert, and then give this ID which you just copied, okay, and hit enter. So once you do that, it will tell you the information about this particular commit ID, right? So just review everything, and then you can see that the commit has been reverted. So now I've not pushed the changes, but then if I come back here and if I hit enter, you can see the older website comes back because the code has now been changed. And if I want to make these changes to the remote repository as well, all I have to do is git push origin master, and it'll ask me the credentials, and the changes have been pushed, right? Now if I come here and I just see the code again, if I do a refresh, you can again see that the code has changed back to 2.jpeg, which was our earlier code which we made changes to. All right, so guys, this is how you can do a revert on a basically a commit and a push that you have made to your remote repository as well, right? So if you encounter any problem during working while working as a DevOps engineer, you should remember this session where I taught you how to revert a particular commit. All right, so with that, let's move on to our next question, which says, have you ever encountered failed deployments, and how have you handled them? Now see, any DevOps engineer in the world will have faced a problem in which, probably the things that he had planned, the things didn't go according to his plan, right? That absolutely happens. And if somebody is asking you in a DevOps interview, have you committed mistakes? So you should, just to impress them, probably never say yes, right? So if you have never committed mistakes, that's awesome, right? But then I know that every engineer or every DevOps engineer who has worked in the industry would have faced a problem while working and would basically account to a mistake that he made while deploying things, all right? Now, the important thing or the important key takeaway from this kind of a learning should be that whatever mistake you make, you learn from it, right? And you never commit it again. And that is basically the intent behind this question as well. The interviewer would want to know, if you made the mistakes, what did you learn from those mistakes? Okay, so if an interviewer was supposed to ask me this question, I'll say, obviously I have encountered failed deployments, and what have I learned from them? I'll just give you the best practices that I think are viable for any DevOps engineer who is working in the industry. So the first thing that everyone should follow and should make it a thumb rule is that you should automate code testing. Not only does it save time, because now your tester does not have to wait for your developer to basically push the code and then check it. The developer can check it in real time because you have written a script for his application, and all the major tests which are to be done, which are pretty common, can be done using automated code testing, right? Now, like I said, it's not only for time saving, but also it removes the part where a human error can occur, right? So if you are working, if you are now, when you work with people commit mistakes. But if you can write a code which will basically test each and every functionality, that code will never make a mistake. And that is why you should always automate things as far as possible, right? So like in my example, what happened was that there was basically a commit to the repository, which was basically a feature addition, right? And the tester did not see all the functionalities, or forgot to see some of the functionalities that could impact the other components of my product. And because of that, when it got pushed onto production, basically a disaster happened. Everything stopped working, right? And that was only because the testing did not happen properly, right? So for all the critical processes of your website or your product, you can basically create a code which will test that website. And basically that would basically close down most of the doors to mistakes. All right. The next thing is you should always use Docker for same environment, right? And this is basically the ideology behind DevOps, that these kind of problems where a developer used to work and a tester could not run his code on his computer, but the developer said that everything is working fine on his system. Docker basically solves that problem, right? So use Docker as much as you can for the same environment problem that you might face. Then we should always use microservices. Now, when you are working in a company, it could be that the product is in the legacy phase and hence it's on a monolith kind of a thing, but you should never encourage this kind of an architecture, right? Reason being, say you did a bad commit or you did a bad push on the production server, but it should not impact the other components of your product, right? If probably you have done something to search, and if it's a bad commit or a bad push, the only functionality that should be impacted should be your search functionality and not the other functionalities. And that is the sole reason behind why we should use microservices. That is, we should divide our application into different small products which we would deploy on servers, and these products should be independent of each other. When you talk about the monolithic architecture, all these components are coinciding with each other, have the dependency upon each other. But when you talk about a microservices kind of an architecture, you remove that dependency so as to, even if one component fails, it does not impact the whole application.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. What are the key components of DevOps? A. Continuous integration. B. Continuous testing. C. Continuous delivery and monitoring. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Fourth point being, you should always overcome risks to avoid failures. Now, this basically means that if there is a code change, or if there is a feature addition which works sometimes and sometimes it does not, and you're not able to figure out why is exactly that thing happening, it is better to wait and troubleshoot it than to push it just to meet your dates, right? Because the latter can cause you a big problem in production when you're in a company like probably like Airtel, or in a company like Samsung or Ericsson, where their products, each second of their website's uptime brings in money, right? So if your website is down for 30 seconds, that could amount to a huge loss, and that would be on you, right? So for you to not face that kind of a situation, always be 100% sure before you make a change or a release onto the production server. All right, so this is the end to the domain of continuous development. Let's go ahead and now talk about virtualization and containerization. All right, so let's start with the first question of this domain, which says, what is the difference between virtualization and containerization? Now, this is a very important question, guys, because most of us get confused between virtualization and containerization. So let's see what are the differences between these two things. So virtualization is nothing but installing a new piece of operating system on top of a virtualized hardware. What does that mean? So basically there are softwares like hypervisor or any other software which specializes in virtualizing hardware. So if you have a server which has around 64 gigs of RAM and 1000 TB of hard disk space, with a software like hypervisor, what you can do is you can take that space and divide it among multiple operating systems, right? You can deploy multiple operating systems on the same hardware by virtualizing the hardware so as to the operating system will feel that, say, if you virtualize 1 GB of RAM from this whole system and say around 100 GB of storage, the operating system will think that, it only has 1 GB and 1 GB of RAM and 100 GB of storage space available to it. It cannot go beyond that. Reason being, it does not know of the hardware which is beyond or which is ahead of the hypervisor software. All right. So in virtualization, basically you have an hypervisor which sits on top of your operating system and virtualizes the hardware beneath it, right? Then you have a guest operating system. So basically once you've virtualized the hardware, you install guest operating systems on top of that. For example, the best example for this would be VirtualBox, right? You install VirtualBox and then you can install operating systems on the VirtualBox with the given spec that you will decide, right? And once you've installed the guest operating systems, on top of that, there would be the binaries or the libraries that you probably would be downloading or that came with the operating system. And on top of that, you have the applications which would be running, right? So the key takeaway from virtualization should be that it's the whole operating system is installed from the kernel level to the application level. Everything is fresh, everything is new. Now let's talk about containerization. So the thing in containerization is that the host, on top of host operating system, you install a software called the container engine. Now the container engine is just like any other software, like you have an hypervisor, you have a container engine. Now the container engine does not encourage installing a whole operating system. For example, if you want to run a container for Ubuntu on, say, a Mac machine, you can do that, right? But it will basically, in that container, you will have basically the bare minimum libraries that amount to become the Ubuntu operating system minus the kernel, right? So in a container, you do not have a kernel. The kernel is always used of the host operating system. And this is the main difference between virtualization and containerization, that in virtualization, you have a separate kernel present of the virtual operating system. But in containerization, you do not have that. And that is the reason the containers are very small. They have the bare minimum libraries required for that container to behave as a particular operating system, but the container itself does not contain any operating system. It basically is based on the same kernel on which the host operating system resides. All right, and this is basically the main difference between virtualization and containerization.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
Moving forward, now the next question says, without using Docker, that is without using Docker to get into a container, can we see the processes that are running inside the container of the Docker container engine? All right. So this basically is relating to the same fact that if you want to see the processes of a container which are running inside the Docker container engine, if you can see them from the outside, basically that means that the processes are running in the same kernel of the host operating system, right? The processes that are running in the Docker container engine would be basically as an addition to whatever is running on the host operating system as well. And you can see that using the ps-aux command, right? So for the host operating system, it's just like any other software or any other process that it has to run. But for the container, it basically thinks that it is running inside an operating system, which it actually is not. right? So can you see the processes? So the answer is yes, you can see the processes which are running inside a Docker container. And how can you see that? How can you basically see these processes? Let me demonstrate it to you. Okay, so we have come back to our AWS server. Let me clear the screen. All right, so if I do a Docker PS right now, you can see that there are no containers which are running on this system as of now. Now what I'll do is I'll run a container for Ubuntu. So I'll do a Docker run -it and then -d and then Ubuntu. All right, so this ran a container for me. And if I do a Docker PS now, you can see that there's a container running, which is basically of the Ubuntu image. So if I go inside this container now, so I'll do a Docker exec -it and then bash. Docker exec -it and then sorry, I forgot the container ID. So the container ID and then bash. So if I do that, I'm inside the container, right? And there's no process running inside this container as of now. Now, if I were to duplicate this, let me quickly again do an SSH. So I'll do an SSH into the same server again so that I'm on $. Okay, great. So if I do a PS AUX, these are all the processes which are running inside the operating system right now, right? But let us make it a little simpler. What we can do is, let me see all the processes which has the word watch in them, right? So let me make it more clear for you. So these are the processes which have the watch keyword inside of them. Okay, so there are basically 4 processes which are running and which have the keyword watch inside of them. Now what I'm gonna do is, inside this container, I'm gonna launch a watch process. So what is that watch process? That watch process is basically going to watch a particular command in a set interval of time. And what is that command? I basically want to say, let's see the ls-l command. Okay, so what is it doing? It is keeping a watch on the command ls-l in every 1 second, right? You can see the time over here. It is incrementing every second, and basically it's keeping a watch on all these files which are there inside the container continuously. Okay, now again, so this is the $ prompt. That we are outside the container right now. Now if I again do the same command, that is again I search for processes which have the word watch in it, I can actually see that there is a new process which is running over here, and this process is running inside the container, which I'm able to see from the host operating system level, right? So the host operating system is basically treating this particular process as if it was running on its own system. That is, the container and the host operating system, because they are sharing the same kernel, the host operating system is taking this process as if it was running inside of it, right? But if we look closely, this watch command is running inside the container, right? Let me just quickly stop it. You can see we are still inside the container and we have stopped the watch command. And if I go here and if I refresh, you can see that this watch command is again gone, which was being mentioned over here before. And this is exactly what we wanted. We basically wanted to see a process which was running inside a container from outside the container, that is from the host operating system, and that is exactly what we just did. All right. So the question that without using Docker, can you see the processes that are running inside a container? So the answer is yes, you can do it. All right. So the next question is, what is a Docker file used for? What do you basically use a Docker file for? So a Docker file is nothing but it's basically a text document to create an image using an older image and adding some files into it. All right. So it's basically like a script that you run in Linux which can do all the things for you that are required. For example, I might need an Apache image and I want my website to be put inside the var/www/html folder inside this particular Apache container. Now, in order to do that, if I were to do it without a Docker file, I would have to first download the Apache image. So I would probably type docker run -it-id and then Apache. Once I've done that, I will exec into the container and then go to the directory called var www.html. Probably I'll do a git clone of the website that I want, and then my website will be available in that container, and hence I'll be able to use it, right? This is one way. Second way is I can create a Docker file which will basically build this image for me without me having to do all these things, all these manual things which I just told you. All right, so let's see how we can do that. So let me just exit this container and let me remove the container which are just running inside my system right now. Okay, so if I do a docker ps now, it's clean. Now what I want to do is I want to run this particular container, docker run -it-p. I want to basically expose the port 83 to this container's port 80, and I want to run it as a daemon so that it runs in the background, and that is it. Okay, so I have the container running, which is this, and what I want to do is I want to basically copy the website into this container. So let me do a docker exec into this container -it. This is the container ID, and then container ID and then bash. So I want to go inside this particular folder. So if I do an ls over here, you can see that there is an index.html and an index.php which are running, right? So it's exposed on port 83, which basically means if I go to a browser and if I go to the server's IP address on port 83, I should be able to see this Apache page, and this is basically the container which I just ran over here. Okay, what I want to do is inside this particular directory, I would be basically copying the code of my website. Now let's see how we can do that. So let me just exit this container. Let me do a docker ps. Let me do a docker stop to this particular container. So what would this do? So basically, if my Apache was running over here, it should stop once I have stopped this container. Okay, so it is stopped. So if I do a refresh over here, you can see the site can't be reached. This is exactly what we want. Okay, now let me do a git clone of my GitHub. I'll do a git clone. All right. Awesome. Now I'll go inside this folder, and basically I want to copy this particular folder inside the container. All right, so for doing that, let's create a Docker file, and what I want to say is in the image shhar/web app, I want to add the folder DevOps IQ. And where do I want to add it? Inside the container, I want to add it in this particular directory. Okay, This is where I want to add it, and inside DevOps IQ. Okay, fair enough. And that is it. That is all you have to do. I'll just come out of this editor, and I'll now do a Docker build of this Docker file with the name test. So it says successfully built an image and it has been tagged as test. Great. Now if I run this image now, docker run -it -p, say I run it on port 84, run it as a daemon and run the image. Okay, great. So if I go to port 84 now, let's see if the container is working first. So yes, the container is working. Now if I go inside DevOps IQ, what do I see? Great. So I can see the web. So basically my website is now available inside the container by simply writing a Docker file to do that. And this is exactly what we wanted. Awesome, guys. So what is the Docker file used for? It is basically used for creating an image without having to do all the manual stuff of adding your files and everything. All right. Now, once this image of yours is ready, you can push it to Docker Hub and anybody in the world can download it and can basically use your website on their local system. Great. Now, the next question is explain container orchestration. Okay, so till now we have seen that, we can deploy a container, we can use it, we can probably deploy an application on it, and we can use it on the web browser, right? But it is not that simple. When we talk about a website like Amazon or a website like Google, right? It has a lot of components with it. For example, on Amazon, you would see that you have a comment section. Then on the home page, you see that there are a lot of products which have the prices, the ratings. Now, each and every component, the prices, the ratings, the name of the product, the image of the product, the comment section, each and everything is basically a microservice. It is a small part of an application which is running independently of all the other parts of the website, right? And all of this is possible using containers. So basically what they would have done is they would have ran each and every component inside a container. Now, the problem over here is, now when you have a website like Amazon, you would be dealing like you would be dealing with minimum like 10 or 11 containers for one particular copy of that website or one particular instance of that website, right? Now, when you're dealing with 10, 11 containers, these containers have to be working in conjunction to each other. They should be in sync with each other. They should be able to communicate with each other, right? And they should also be able, we should also be able to scale a particular container in case it goes down. For example, the comment section container, it goes down for some reason. Now, if it goes down, we have to keep a watch on it and we have to redeploy it if it goes down. And all of these activities, which I just told you, comes under container orchestration, right? If you were to manually deploy these containers on Docker, you will have to keep a manual check on all these containers. But imagine when you have thousands or 10,000s of containers that you're dealing with, in those kind of scenarios, you need container orchestration. Now, container orchestration can be done using various softwares. So you have a software called Kubernetes, and before that there was a software called Docker Swarm, which basically made our life easier by doing all the manual work for us. That is, it will check the container's health. It could scale them in case they become unhealthy. They could always also notify the administrators by an email in case something happens, right? They can also run a monitoring software for you, which basically gives you a report or the health status of all the containers which are running inside that software. So this is a very small part of what a container orchestration tool can do, right? And basically, if you were to understand what container orchestration is like I said, when you work with multiple containers, you have to take in note a lot of things, and that is possible using the container orchestration tools like Kubernetes and Docker Swarm. Okay, so the next question is, what is the difference between Docker Swarm and Kubernetes? Now they're both container orchestration tools, we just saw that, but why do we have two? Or if I were to choose between Kubernetes and Docker Swarm, which should I choose? All right, so let's look at the differences between each one of them. So the first difference, which is probably the most important difference, or probably I'll say is the deciding factor whether you should go ahead with this tool given that you have a short deadline and you have to deploy a project. So installing Docker Swarm is very easy. It comes pre-packaged with the Docker software. So if you have installed Docker Swarm is already installed on your system. You don't have to worry about anything. On the other hand, installing Kubernetes is a very tough job, right? There are a lot of dependencies for Kubernetes. You'll have to see the system, you'll have to see the operating system on which it is running, and a host of other things, right? It has a lot of dependencies and hence it is very tough to install. But the moment you install it, it becomes very helpful. That is, Kubernetes becomes very helpful because of the features that it offers, which brings us to our second point. Docker Swarm is faster than Kubernetes, reason being that it has less features than Kubernetes and therefore making it a very light software and hence faster than Kubernetes. So if you want to use Docker Swarm, you should be reading about what Docker Swarm does not offer and what Kubernetes offers. And if you feel you do not need all the features that Kubernetes is offering, you can go ahead with Docker Swarm and deploy your application in a faster manner. But like I said, Kubernetes is complex and it has a lot of services and features, because of which its deployments are a little slower when we compare it to Docker Swarm. The third point, which is the most important point, is Docker Swarm does not give you the functionality of autoscaling. Meaning if your containers go down or if your containers are basically performing at their peak capacity, there is no option in Docker Swarm to scale those containers. On the other hand, because of Kubernetes monitoring services and the host of other features, you have that option of providing auto scaling to your containers, which basically means you can automatically scale your containers up and down as and when they are required. And this is an amazing thing that Kubernetes handles for us. Alright guys, so these were the questions around the domain virtualization and containerization. So moving ahead, now our next domain is continuous integration. So let's shed a light on what continuous integration is. So our first question itself is, what is continuous integration? So continuous integration is basically a development practice, or I'll say it's a stage which basically connects all the other stages of the DevOps lifecycle. For example, you push your code to Git, like we took an example. When you push the code to Git, you might have provisions which might allow you that the moment the code is pushed onto the remote repository, it automatically gets deployed on the servers as well. Well, if that is the case, basically that would be possible using integration tools that would integrate your Git repository with your remote server. And that is exactly what Jenkins does. It's a continuous integration tool which helps us integrate different DevOps lifecycle stages together so that they work like an organism, right? This is what continuous integration means. So, because we discussed about what continuous integration is, our next question says, create a CI/CD pipeline using Git and Jenkins to deploy a website on every commit on the main branch. So on every push that you make to the remote repository, the code should automatically get deployed on a remote server. All right. So this is something that we're going to do just now. All right, but before going ahead, let's see what is the architecture for this kind of a thing. All right, so this is how the whole thing is going to work. Basically, the developer is going to commit the code to his GitHub. GitHub basically, once it sees a change in the branch that we mentioned, it is going to trigger Jenkins, which in turn will integrate or will take the website from the GitHub repository and push it onto the build server on which we want the website to be deployed. All right, sounds awesome. Great. Now let's go ahead and do this demo. So for that, we will have to SSH into our server. So let us do that. Okay, so I'm in now. Let me clear the screen. So first let's check if our Jenkins is running on this server. So let me check the status for Jenkins. So if I do a service Jenkins status, I can see that the Jenkins service is active. Awesome. So I'll just go here and I'll go to the Jenkins website, which is basically available on 8080. All right. So I'll enter my credentials. And this is how the dashboard for Jenkins looks like. Now our question is, or our aim is to create a job which basically will push a website that we are uploading to GitHub on a particular server. All right, so let's create a new job first. So let's call our job as a demo job. Okay, and let's name it as a freestyle project and click OK. So this will create a job in Jenkins for us. All right, so our job has now been created. So what we want to do is I want to take code from my GitHub. So I'll have to specify the GitHub repository over here. Okay. And similarly, I'll have to say that I want to trigger the build the moment anything is pushed on my remote repository. All right, and this should be it. Great. So I mentioned that anything that is pushed onto my master should trigger a build on Jenkins. Okay, and what should this build, or what set of commands do I want to run once build is triggered? So first I want to remove all the containers which are running inside my system. So I want to clean up, right? So for that I'll say sudo docker rm-f, then a $. This basically is going to clean all the containers which are running currently in the system. Once this is done, I want to build my website, which is going, or build my container, which is going to have my website. All right, now how can we do that? For that, I'll have to push the code to my GitHub, which will have the Docker file as well. Okay, so we created a Docker file inside. Okay, so here it is. So we have our Docker file created in the DevOps IQ folder, which was there in my home directory. Now what I want to do is I want to push. So what is there inside this Docker file? We saw that we could create a Docker file using, if we write something like this in our Docker file, and this would basically create an image with our code which is there on GitHub. All right, so what we'll do, we'll just push this code to our remote repository. And let's add the message that we have ordered a Docker file. Great. And now let's push it to our remote repo. Great. So it has been pushed to my remote repo. And now if I just go here and check if my changes have been done or not, let me just quickly refresh it. So yes, I have a Docker file in my Git repository right now, which was committed 42 seconds ago. Awesome. Great. So now what I'll do is I'll come to my Jenkins and I will say that build sudo docker build the Docker file. Now, where is that Docker file? The Docker file will basically be downloaded in the Jenkins workspace. So that is in var lib Jenkins workspace, and then the name of the job, which is demo job, and that is it. So inside this, I will have my Docker file, and it will basically build it and name it as, say, Jenkins. It'll name it as Jenkins. In the next step, what I'll do a sudo docker run -it and then -p, and say I want to deploy it on 84 or say 87 port. Okay, and what do I want to deploy? I want to deploy Jenkins. Okay, so this should do these this should basically do all the stuff. So in the first command, basically we're removing any container which is running on the system. In the second command, what we're going to do is we're going to build the Docker file which is available in this workspace, and this workspace will basically have my GitHub project and the link I have specified over here. So it'll basically just copy, or it'll pull the project and save it in the workspace of demo job. So in this demo job, there's a Docker file. So we are building this Docker file and we are naming this created image as Jenkins. And then we are running this image and exposing it to port 87. Okay, so let's save it. Awesome. Now what we have to do is I'll have to go inside. So if you want to configure a webhook, the way to do that, when I say a webhook, basically you want your GitHub to interact with your Jenkins whenever there is a push to a particular repository. So in your repository, go to settings and then go to webhooks. So this is a webhook that I created for my Jenkins, right? So let me create it again for you. So all you have to do is click on add webhook, right? And enter the URL for your Jenkins over here. So in my case, it is this. I'll just enter it over here, followed by this keyword, which is GitHub-webhook. And that is it. Once you specify that, just go down, click on add webhook. And this should basically send a request to Jenkins, and if everything goes well, it will say last delivery was successful. Okay, so any changes that I make to my GitHub now should trigger a change over here. Now let me delete this job, because I think even this job gets triggered when my GitHub, any changes made to my GitHub, right? So let me delete this project. Okay, great. So I just have this job now. Awesome. Now let us see how it actually works. So what I want to do is I'll come back to my terminal, do an ls, and let me go inside DevOps.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the cloud platform are not used for DevOps implementation? A. Google Cloud, B. IBM, C. Microsoft Azure, D. Amazon Web Services. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
IQ, and let me do some changes in the code. So let's say I go into nanoindex.html. So the first thing that I do is I change the title of the website. So I call it as Jenkins test website. Okay, and I change the image from 2 to 1.jpg, and that is it. Let us see if I just push, or if I just push this website onto my server, what will happen. So I'll do a git push sorry, first I'll have to add these changed files into my repository. Git push origin master, sorry, git commit, and let me label this commit as test push. Okay, done. Now let's push this to our remote repository. Git push origin master, and let's give the credentials. Awesome. Now if you wait here, it should basically start a job. So as you can see, there is a job queued which is for demo job, and this got automatically triggered by my GitHub. Okay, so let me refresh this. Okay, so the moment it gives you a red, that basically means that your job has been failed. So let's see what had just happened, why our job got failed. So if you go here, you can see the console output just like this. Okay, so basically we forgot to add a sudo here, and that is causing us a problem. Okay, so we can fix this by just going down and adding a sudo here. Save it, and again we'll have to change the code. Let's call it as Jenkins test 2 website. We'll do a control X, Y, and now let's add our files to our local repository. Git add. Now let's commit it. Test push 2, and now let's push this to our master. I'll enter the credentials, and this should be it. Okay, so let's see. So our second job got triggered automatically, and it gives us a blue. Now blue means that your job was executed successfully. So let's check what happened. So we were deploying it on port 85. So let's check if it has been indeed deployed. So it was on port 85, and the folder was DevOps IQ. Okay, so let's check. I'm not sure if it was port 85. Let's check what are the port that we have specified. So the port is 87. Okay, so let's go to port 87. Okay, so it's giving an error saying unsafe port. So for our troubleshooting, let's check if the container is running. So yes, the container is running on port 87, but it says an unsafe port. So what we can do is, let us change it to say 82. And now let's just try to build the job from here. We'll just click on build now. Job has been completed, and the port was 82. Yes, so Apache is working. Now let's try going inside DevOps IQ folder. And there you go. You have your website with this title which you pushed on GitHub. Now for one more time, for testing purposes, let us push our code once more and see what happens. So I'll say that this website is test3 website, and say I'll change the image as well to 2.jpeg. Okay, save it, do a git add, do a commit, and say call it test push 3, and now let's git push origin master. Enter the credentials. Great. Now let's check what will happen. Okay, so our build has been started and it has been completed. Great. So if I refresh this now, it says Jenkins test 3 website and the background also has been changed. So congratulations guys, we have successfully completed the demo. So basically if you change anything in your GitHub, the website is automatically getting deployed on your build server, right? And on top of this, just for making it more interesting, what we can do is we can do a git log and we can revert on this commit that we saw earlier. Okay, so let's do a git revert and then paste it, agree to everything, and then push to master. Enter the credentials. Everything has been pushed. Job is getting triggered. Job is completed, and if I go here again, my website got reverted to a particular previous version. Awesome guys, so we have completed the demo, which basically asked us to create a CI/CD pipeline using Git and Jenkins to deploy a website on every commit on the main branch. So we have done it successfully. Awesome. Let's move on to our next domain, which talks about configuration management and continuous monitoring. Awesome. So what is configuration management and what is continuous monitoring? Let's understand it. So what is the difference between Ansible, Chef, and Puppet? Now, before understanding the difference between Ansible, Chef, and Puppet, these are basically configuration management tools. What is configuration management? If you have, say, around 200 servers and you want to install a particular software on each of these servers, what will you do? One way what you can do is you can basically go to each and every of these servers, run a script, and that basically will install software on that on these servers, right? The other way to do it is install a configuration management software using which you can deploy or you can install all these softwares, or you can control the configuration of all these servers from one central place. And that is exactly what configuration management means, right? Now, in configuration management, you have many tools like Ansible, Chef, Puppet, etc. But these are the 3 top tools which are used in the industry. Now, the question is, what is the difference between Ansible, Chef, and Puppet? All right, so let's go ahead and see the differences.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below. Now, let's continue with the session.
All right, so let's first talk about Ansible. So Ansible is very easy to learn because it is based on Python. So you don't have to sweat a lot, or you don't have to sweat much on learning the commands for Ansible because it is based on Python. So if you know Python, Ansible is going to be a cakewalk for you. It is preferred for environments which are designed to scale rapidly. Basically, with Ansible, the thing is that you don't have to install the Ansible client software on the systems on which you want to basically deploy the configuration. Ansible just has to be installed on the master, and that is it. No other configuration required. You can directly control the configuration of the client server given you have the access to it. So it offers simplified orchestration, reason being, like I just told you, that you don't have to worry about installing softwares on the client machines. Ansible can standalone take care of all the complications that come forward when you are dealing with deploying configurations without installing a particular software on the client machines. But this is basically a disadvantage of Ansible, that it has a very underdeveloped GUI. That is, you only get the CLI to work with right? And it has very limited features when we compare it with Puppet and Chef. Now let's talk about Chef. How is Chef different from Ansible? So it is Ruby based and hence it's difficult to learn. Now Ruby is a language that not many people are acquainted with, and hence people might find it difficult to get versed with the commands of Chef. The initial setup is complicated. When I compare it with Ansible, the setup was very easy because I just had to install Ansible on the host machine, and on the client machine I didn't have to install any software. So, but with Chef you have to do that, and hence it becomes a little complicated. But once all the setup and everything is done, Chef is very stable, right? It has been, since it's a community product and it has been well contributed to, it's a very stable product and it offers you resiliency. So of course, when you're working on production servers, probably working on Chef would be a better idea than Ansible, because Ansible does not have that great community when you compare it with Chef. And of course, Chef is the most flexible solutions for OS and middleware management. Now middleware basically means the software management part. Chef offers to be a great choice for configuration management. Reason being, it is very reliable and is very mature, because it was probably among the first configuration management tools to come out, and because community has contributed a lot to this project, it is very mature in its development stages as well. Now let's talk about Puppet. So Puppet can be tough for people who are beginners in the DevOps world, right? Because it uses its own language called Puppet DSL, right? The setup part is smooth when you compare it with Chef, but it's a little harder than Ansible, because when you're using Puppet, we use a master and an agent as well. So you will have to install Puppet agent on the client machine, and only then Puppet will be able to interact with the client software, right? Now it has a strong support for automation. So if you're planning to do some configuration management that you want to automate, Puppet is very compliant in that part. You can easily do the automation part using Puppet, and it is not suitable for scaling any deployment. So if you have say around 50 or 60 servers and you plan to add more in the future, probably Puppet would not be the right choice for that kind of an architecture. It is good to have when you have a stable infrastructure where you're probably not adding servers now and then. But if you are working on cloud and you do not know the capacity that you would be running, probably Puppet would not be a good idea to manage your configuration on your clients. Okay. Our next question is, what is the difference between asset management and configuration management? So asset management basically deals with resources. It deals with hardware, which we'll have to plan so that our IT workforce can work with maximum efficiency, right? So we'll have to plan the planning of your hardware, of how many resources a particular team might need. Giving the right resources to the right people is what asset management counts in. When we talk about configuration management, it basically employs not the hardware but the software component of what all softwares are required by a particular employee of a team or a particular person in the team, what softwares are required by that person, and for other person what software is required. I mean, rather than taking the radical approach of installing every software in every machine, which should not be done because some softwares are licensed. So configuration management basically means installing the right software on the right system on which a particular person or on which a particular workload is going to run. So our next question is, what are NRPE plugins in Nagios? Okay, so NRPE plugins are basically extensions to Nagios which help you monitor the local resources of the client machines, right? So you don't have to SSH into the client machines to see how much of memory or how much of CPU is being used. Nagios being a monitoring tool, you just have to install the NRPE extension on the client machine, and it will give you a real-time data of the resources that are being consumed on that particular client machine. And obviously, when you're working in production environment, you will be monitoring multiple machines, and with NRP plugins installed on each of those machines, you can easily monitor the resources of them at one central place. And that is exactly what NRP plugin is. Our next question is, what is the difference between an active check and a passive check in Nagios? Okay, so in Nagios, if the data, the monitoring log that you're getting from your clients, if it's being delivered by a Nagios agent, in that case, it is called an active check. Reason being, Nagios is actively involved in taking all the data or in collecting all the data from your clients. But in case when you're dealing with systems wherein it does not allow you to install any other software, or probably the software itself can generate monitoring logs, in those cases, what happens is rather than Nagios, the software component pushes the logs to the Nagios master, where it can take the logs and probably create a graph or create the metric for you in the dashboard. So basically, using those logs which are being published by some other software, Nagios will create a report of the health monitoring part of your client systems, right? And that is why it is called a passive check. Reason being, Nagios is not involved on the client side at all. It is basically the software's own services which are basically pushing the log to Nagios master, and hence it's called a passive check. All right. But if you talk about the architecture or the working or the life cycle of how this actually works, on the master itself, the logs which are published are actually published to a queue, right? And whether it's an active check or a passive check, the logs have to be published to that queue so that the Nagios master can pick them up and create the monitoring metric which is required. All right. So in a passive check and in an active check, the queue is going to be there, but it's the only difference between the agents. That is, in an active check, the Nagios agents are involved, but in a passive check, third-party software tools are involved, which publish the log to the Nagios master. All right. So our next question says, create an Ansible playbook to deploy Apache on a client server. So basically, we have to do configuration management. So as to, without, going inside the client system, we'll have to install a particular piece of software inside it. Okay. So let me quickly do an SSH into my AWS machine. And what I'm going to do is, I have a slave machine which I have already configured, which can interact with my master. That is, if I do a Ansible ping all, you can see that there is a server 1 that I have configured, which has successfully responded to my master's request. Okay. Now let me show you the server, which is basically working. So this is the server which is configured with my master, right? This is my client machine, and on this machine I'll have to install Apache. So if I right now go to the IP address of this machine, it says connection refused. Reason being that there is nothing installed on this server, or there is no Apache software installed on this particular server right now. All right, so let's install Apache. Now to do that, you will have to write a playbook. Now what is a playbook? A playbook looks something like this. So it's basically a YAML file that you'll have to create. So I have created one for me. So where do you want to install the Apache software is the part where you'll have to specify in hosts. So basically my client machine is a part of a group called servers that I've created, right? So the hosts are servers. And where can you actually specify what part is your machine, or which group is your machine a part of? So that you can specify over here. So it's in /etc/Ansible and /hosts. Okay, so as you can see over here, this is the group name, that is servers, and inside servers I've specified a server 1 client machine which has the IP address this. So this is the IP address of my slave. So if you can compare, it's 18.223.101.172, and if I compare it with my slave, this is the IP address of my slave, right? And this has been configured over here. So I can refer to my server 1 as servers, or I can refer it to as server 1, right? So if I do, let me do a clear over here, I can say Ansible -m ping, and I can say server 1 as well. It will reach out to my server 1, or I can say servers as well, because it's part of the group servers. Okay, so this is how it works. Now I want to install Apache. So for installing Apache, I'll have to write a playbook which looks like this. Basically it's a YAML file. So you start with the 3 dashed lines, and then you specify hosts. So hosts, I've specified every server, every machine which is inside the servers group should install Apache on it, right? And what is the task? I want to install Apache 2. This is basically a name. You can specify anything over here. Then I've specified apt. Basically I want to use the apt package to install Apache 2, the latest software. Okay, now what I will do, I will type in Ansible -playbook, and I'll type in apache.yaml. I'll hit enter, and now it has started to install everything. So it is installing on the servers group. It is gathering the facts, and it saw that it is able to communicate with server 1, and now it is accomplishing the task of installing Apache. All right, so it has been done successfully. So if I go to my Chrome browser now, and if I refresh the address, you can see that Apache is installed on this server automatically. So I didn't have to basically SSH into the server. It all happened automatically. And if I had like 5-6 computers which were running on AWS, and if I wanted to install the software on it using Apache, using Ansible, this would have been the same way. It's only that in the server group, I would have specified more IP addresses which my Ansible could talk to. Okay, so this was our task of basically deploying an Ansible playbook on a client server without SSH, doing an SSH into that client server and doing it from a central location. All right, so this is done. Now let's move on to our next domain, which is continuous testing. Now what is continuous testing? So we talked about continuous development, which is done using GitHub. We talked about continuous integration, which is possible using Jenkins. We talked about continuous configuration management, which can be done using Ansible. And next online is we have continuous testing. So once the code has been deployed, it has been integrated with Jenkins, it has been deployed on a server. The next thing is automated testing that we discussed in the best practices before, right? And it can be done using a tool called Selenium, a software called Selenium WebDriver, right? So the first question is, list out the technical challenges with Selenium. So the Selenium tool is used widely for automatic testing or automated testing, but what are the problems that you get with Selenium? So if you're using Selenium, mobile testing cannot be done. So if you have developed an application for your mobile, you cannot test it using Selenium. The reporting capabilities of Selenium are very limited. If your application or your web application deals with pop-up windows, or it gives pop-up windows, Selenium would not be able to recognize those pop-up windows and work on them. Web app, and Again, Selenium is only limited to web applications. So if you have an application that probably runs on desktop, probably it's a software that you have designed, you cannot test that software using Selenium. Selenium is only for those applications which can run inside a browser. And if you want to check whether there is some image in your web page and that image should have some particular content, it is a little difficult to implement it in Selenium. Although it is not impossible, it is possible. You'll have to import some libraries and other things like that. But natively, Selenium does not support image testing. You'll have to work around. You'll have to work around with Selenium to import some libraries which could do it for you. But like I said, natively Selenium does not support image testing. So our next question is, what is the difference between verify and assert commands? So let us see the differences. So if you're using assert in Selenium, if the command fails, the whole execution comes to a halt. Whereas in verify, it does not come to a halt. It keeps on continuing the rest of the lines which are written in the code. Now, how can it be helpful? How is it helpful to basically put execution at halt whenever there is an error which occurs for a particular line? It is helpful when you're dealing with critical cases. Like for example, if there are 5 cases and say if case 3 fails, case 4 and 5 cannot execute because they have a dependency on case 3. In those cases, I would say that you would have to use assert with the case 3. But in the same example, if you talk about case 1 and case 2, they do not have a dependency or they do not create a dependency for any other test cases that have to run, right? For example, case 3, case 4, case 5 are not dependent on case 1 and case 2. In those cases, we can run the verify command, which will not stop even if the test case fails, right? And this basically is done to basically see what all is working and what all is not in one shot in a testing program. And for those cases, you would use verify. But in the cases where you are testing critical cases and you do not want to waste your time testing other things, if one of your case fails, in those cases, you will use the assert test. So like I said, it is used to validate critical functionality, assert command, and verify is used to validate functionality which is of the normal behavior kind of scenario, which comes into the normal behavior. That is, it does not create a dependency for other things to not work because it stopped working. All right. So our next question is, what is the difference between set speed and sleep methods? So set speed is basically used for executing tasks at a particular interval that we specify. For example, say I want to echo hello world at intervals of 5 seconds. In that case, I can specify it using set speed. But sleep method basically suspends the execution of the whole program for a particular interval. For example, if you're doing a Selenium web test and the web page takes around 3 seconds to load, and you don't want testing to happen just after each line, you can specify a sleep method of say around 3 seconds, where it waits for 3 seconds for the website to load, and only then it will start executing the tests which follow that particular line. All right. So this is the difference between set speed and sleep.
Just a quick info, guys. Intellipaat provides DevOps online training validated and certified by NASSCOM Future Skills and IBM. The course link is given in the description below.